Would you like to learn how to make a 2D top-down game using Godot? You are in the right place, and this series will guide you step by step. You will create a 2D top-down farming game with detailed tutorials on how to use tile map layers and create scenes with Y sorting, allowing your player to move seamlessly in front of and behind objects. You will also design tools that let players chop down trees, mine stones, till the soil, and grow crops on your farm. In this series, you will interact with other characters using a dialogue manager, adding depth and interactivity to your game. You will also learn how to grow your crops using day and night cycles that bring your farming game to life. You will learn how to speed up your development by creating custom components like hit, hurt, damage, collectible, interactable, and navigation components. Plus, you will set up smooth NPC movement with navigation regions and navigation agents to ensure they navigate the environment effectively. You will create interactive UIs and style your controls using theming for game elements such as the tool, inventory, day and night panels, giving players a seamless way to interact with your game. This tutorial series is packed with techniques and tips to help you design and build your own 2D top-down game. Now, before we begin creating our game, we will use the Sproutlands asset pack by CutNoodle. You can find this on itch.io, and I will leave this link in the description below. So once you've downloaded the asset pack, we will then unzip this pack and organise the assets into different folders, and we will rename them. And we will do this before we start creating any scenes for our game. Now let's hop over to Godot. Once the game engine loads, let's create a new project. And for this game, we will call it Crop Tales. And if you leave create folder checked, it will automatically create you the game folder in your project path. So feel free to set your preferred project path before setting up the project and game name. We will leave the renderer on forward plus, and for version control, we will just set this as none. However, if you do prefer to use Git, and you do want to add this into your source control, then leave the version control metadata to Git, and it will create you a git ignore file automatically in your game folder. Now let's select create and edit. Once the editor loads, you can see that you have your scene and import on the left hand side, your editor in the middle, and the inspector node and history on the right hand side, with the file system underneath scene and the ability to modify files underneath. However, in my tutorials, I have my own layout, so I can select this by using the editor layout option, and this is a layout which I have already created myself and I have saved, so you won't have this layout. So what I'm going to do, I'm going to just change to this, and you may wish to use the same layout, so just move the panels by changing the dock positions, and once you have the same layout as this, just go to editor and save the layout. You may wish to use the same layout as me so that it is easier to follow the tutorial steps as I'm moving files around, creating scenes, or changing variables in the inspector. As we are only creating a 2D top-down game, we don't need the 3D editor options. So to make the editor a little simpler and to remove this 3D option here, and also remove the 3D scene from here, we can say editor, manage editor features, and just turn off our 3D options. This is where you can turn features for the editor on and off. So we can just click this here. If we click OK, you can see that the 3D option has been removed here and we can't choose those 3D scenes. Our editor is now ready, so we can begin bringing over the assets from the Sproutlands asset pack. In the root folder, let's create a new folder, and we will call this asset. Click OK, and we can then go inside this folder. In the Sproutlands asset pack, once you have unzipped this, you will get a characters folder, objects folder, and tilesets folder. What we will do is just highlight these folders and drag them into the assets folder. These assets will now be imported. I will now rename the folders and the file names so that we follow some good practices I will make them lowercase and the spaces will be underscored. So I have now finished renaming the folders and all of the different assets. And it's always good to follow a naming convention. It keeps everything neater and also it is better organized as well. I will now create a new folder and call this game. And I'll just move these asset folders into there. And in future tutorials, we'll be adding more assets for the UI and also our sound effects and music files as well. I will show you how to create tile map layers in Godot to better organize and separate different types of tiles in your game. These layers offer more control and flexibility compared to the older tile map node. Plus, I will guide you through creating animated tiles to add dynamic effects to your game environment. Let's begin by creating a new folder and we'll call this Scenes. Click OK. And inside the Scenes folder, we'll create a new folder and call this Test. Now let's create a new 2D scene. Press F2 on the node and let's call this Test Scene Tile Map and press Enter and let's save the scene. So we'll save that in our test scene. I'm going to use a different approach to building this game from the last tutorial series. I'm going to use many more different test scenes so that we can create the different components in isolation. This means we'll have a test scene for tile maps, a different test scene for our player, our different NPCs, and other scenes that we create and add to our game. Now, the benefit of creating test scenes is that we can create all the different components in isolation. Therefore, at the end, when we create the level and put all of our components together, if we find that something isn't quite working, we can always go back to the test scene and see whether or not that game component is working in isolation. We will start to create our tile map by adding some tile map layer nodes. So let's go and add a child node and we will choose node 2D and let's call this game tile map. And then we'll add some tile map layers. So add child node again. And as you can see, the tile map has been marked as deprecated, and this was used in previous versions of Godot. The difference between tile map and tile map layer is that in tile map, you used to create the layers inside the tile map, whereas now we create different tile map layers. So choose this option here, and we won't use this in future. So click create and press F2, and we'll name this as water. And in the tile set, if we just pull this up, let's just click on here and click new tile set and right click, save as, and we'll do a new folder in here and we'll call this tile sets. And inside the tile sets folder, we will call this game tile set and click save. This will now give us a new tile set here. Now click the tile set pane at the bottom. So this brings up the tiles, and then in the tile sets folder, click and drag the water PNG file into the tile set. Now when this dialog displays, we don't want to automatically create the tiles in the atlas, so just click no here. And the reason is that these tiles are going to be animated. So let's just click the first tile to add that to our atlas. Now choose the select option and click the first tile. Now to animate the tiles, we have 4 tiles as columns. So for the columns, choose 4. Then what we need to do is add an element. So click add element will add the next tile in the sequence for our animation. And if you look at frames, we have a 1 second duration for each animation. So I'm going to reduce this and make this 0.2 seconds. So choose 0.2 and then add the element, 0.2 again, add the element for the very last tile in the frame series, and then just change that to 0.2. Now let's begin drawing the water tile. So click on tile map at the bottom pick the first tile as these are all animated tiles, and then choose the square option, and in the top left corner, let's just drag and draw those tiles. So let's begin running our first scene. Now usually we use the run button here, but because we are creating test scenes and running them in isolation, we are going to just use run current scene. So click this button here and it will launch the window, so we can see that our water tile sets are now in the top left corner and they are animating. But what we need to do is to set some further project settings which sets the viewport resolution correctly. We will also set some integer scaling so that we have our pixels rendering correctly. And we will also set up the test window. So let's just close this window. Let's head over to project settings and under the display option, choose window. And we'll see that the viewport width and height is currently set to 1152 and 648. Now I would like to use a lower resolution and my monitor is set to 1920 and 1080. So I'm going to put 1920 and then divide that by 3, which will give me a resolution of 640. And for the viewport height, I'll put 1080 and also divide that by 3, which will give me a viewport width and height of 640 by 360. I will leave the mode here to window, but in the future we will use options such as exclusive full screen. And what we'll also do is set the stretch mode to be viewport. The aspect ratio we will change to keep height. And the scale mode, we will set this to be integer. And setting this to integer will stop the pixels from changing size when the window is being stretched. And this option is much better for low pixel resolution games. So what we'll do is let's just close that. As you can see, the viewport has now changed here. And you may notice I don't also have a camera in my scene. And we don't need one in the test scene as long as I draw the tile map within the viewport window here. So let's now run this current scene. The viewport window has launched. I'm just going to check my settings again because the window size is slightly smaller. So actually let's switch on advanced settings and we can override that size. So let's say 640 and then multiply that by 2 and we'll say 360 and also multiply that by 2 and just enter on that. Let's close that again and let's launch our test window. So as you can see, the animation is now working on the tiles and we have our water tiles here. So let's close the window. So I'll explain a little bit about exclusive full screen. If we launch the window again, our game test window is 1280 by 720, yet the pixel resolution for the game is 640 by 360. So if we just maximize the window, you will see that because we set integer scaling, we will get these black bars around the game. And this is so that the pixel resolution is always correct in integer scaling. And this prevents the pixels from stretching. So when you finish the game, you would want to run the game as exclusive full screen. So let's just close this window and then go to project settings and choose exclusive full screen. And then close that. And then when you launch the scene again, it will launch as full screen and you can really clearly now see the animation in the pixels. So let's just close the game and return back to Godot and go back to project settings and we'll just change this back to windowed and just close that. So now let's continue drawing the water tiles. We'll just cover our viewport. Now let's add another child node and create another tile map layer. We'll call this grass and we'll assign the game tile set. Now let's drag the grass PNG into our tile set. And again, we won't click to add all of the tiles. We'll choose them ourselves. So with the grass tile set loaded, in the tile set, we'll now add these to the atlas by just clicking them. So in setup, have that selected and then just start choosing your tiles. So we'll select the following tiles here. And then what we can then do is go to the select option and select a single tile. And under terrains, we will need to add it to a terrain set. So go to the tile set here And under terrain sets, let's add an element. Then we'll add another element here. And in this terrain here, we'll name this as grass terrain and just enter that. Then in the terrain set, we need to increase this to 0. And as we have only one terrain here, we'll also increase that to 0 as well. Now in Paint, we go to the Paint properties and select terrains. And we need to choose the terrain set 0. Then in terrain, we will choose grass terrain. Now let's then select all of our grass terrains until we reach the last one. Then we need to paint the bitmap. And keep painting the bitmaps through. Until you have something that looks like this. So just missing a little bit on there. Okay, and then save that. Now that we've created all of our bitmaps, we can then go to Tile Map, go to the Terrains option, and you can see that we now have a grass terrain, which we created in our tile set. So choose the square option and let's now start to create an island. So we can now draw some options on there. We can start creating some of our shapes. I'm just going to add a little bit more. And if we run the current scene, you can now see that we have an island floating in the water. If you then choose the water tile map layer, you can see that the grass tile map layer is disabled. So you can now draw on each of those layers. Now let's add a new tile map layer. So click Game Tile Map and add a child node and choose Tile Map Layer and click Create. Now let's name this as Tilde Dirt and enter. And then in the tile set, let's load the game tile set. Go back to tiles, and in the tile set, let's add the Tilde Dirt Wide PNG. Click No again for automatically creating the tiles. And with setup selected, let's choose our tiles. Then click Select and pick the first tile. Let's just move this up a little bit more. And then click Tile Set and open it. And we want to add another terrain. So let's add an element here. And in this terrain, let's call this Tilde Dirt Terrain. Let's just choose a different color. Then in the terrain set here, just let's add that terrain. And it will be number 1 because the first element is at array 0 under terrain. So it's 0 and then 1. And then go to Paint. But on this one, we want to choose the same terrain set, but Tilde Dirt. And then let's paint those. So we'll choose them all, and then let's paint that bit mask in. And we're creating the same bit mask as we have done for the grass layer. Now let's head over to Tile Map and choose terrains as the option, but choose Tilde Dirt. And we'll just use the pen, and then let's zoom in and let's start to draw some terrain. And then we'll go draw a little bit more terrain here. So this will be the Tilde Dirt where we start to add our crops later. Now let's create another tile map layer to add flowers and other nature elements. So we'll go Add Child Node, choose Tile Map Layer, and then rename this to Nature. Once that's been renamed, we can then load a tile set. So go to Quick Load and load the game tile set, then click Tile Set, and in the Assets Game Objects folder, we want the basic grass biome thing. So let's just click and drag that into the tile set. But click No for automatically creating the tiles. With setup now selected in the tile set, we can now begin adding some of these sprites. So we'll click this tile for the mushrooms, these leaves and rocks, this log stump and log, the flowers, the rocks in the water, and these lily pads. As you can see, I've got a sunflower here which stretches over 2 tiles. So hold the shift key down before selecting the first tile, then click and drag, and it will select and create a larger tile. I'm now going to finish adding the other tiles. Now click on Tile Map, go to Tiles, let's zoom in, and let's begin adding these tiles to the scene. So we can now test that we are rendering these tiles correctly. Now, as you can see in the editor, some of our images are blurred. So what we need to do is to update the texture filter settings. So go to Project, Project Settings, and under Rendering and Textures, the default texture should be nearest because we're using pixel art. So then just click Close, and you can see that the pixels are now defined much better. Let's test the scene. And when the scene launches, we can see that our assets are now rendered correctly. Let's close the scene. And that brings us to the end of this tutorial on how to create a tile map with different tile map layers such as the grass, water and till dirt. We can also create a nature tile map layer which holds the different assets such as the mushrooms and the trees. I will show you how to create a player character with animations and a state machine. You will learn how to make the idle and walk states for the state machine and then transition between them using your keyboard inputs. So before we begin creating our player, let's head over to our scenes folder, and in the test folder, let's create another test scene for our player. Let's duplicate this scene, just call it scene default so that we can duplicate this scene in future. Now open up test scene default, and we will just delete the till dirt layer off and also the nature layer. So this test scene will always be used for other components such as a player and other NPCs, and we can just duplicate that. Let's just save test scene default and duplicate that scene again, and we'll call it test scene player. Click duplicate and open up the test scene player, and now we can create a new scene. So scene, new scene, a new 2D scene, and let's just change this type. So we'll use a character body 2D, and let's then rename this to player. And in the scenes folder, let's add a new folder, call this characters, click OK. In the characters folder, create a new folder and call this player, okay? And save our scene in the characters player folder. Click on player, add child node, search for animated sprite 2D, create, and in the sprite frames, let's create a new sprite frames and then open that. And in the add frames option, let's go to assets, game, characters, and choose the basic character sprite. Open that and choose the first two. So 0 and 1 here, add those two frames, and let's just zoom in on the player and just play that. Okay, pause that animation, and then let's rename this to idle front, and then set the animation to be default on play by clicking the default button here. So this is autoplay on load, and then add another animation. We'll call this idle back. Click add frames, choose basic character sprites again, and we'll choose the second two here. Add the two frames and just play that. Okay. Add another animation and call this idle left. Add the frames and choose the left one. Play that again. Zoom in a bit more. Add another animation and we'll call this idle right. Add frames. Open the basic character sprites once again and then add the last two frames. And we'll just play that. And for each of the animations, we'll keep looping on. Now, as we play the animation, it is a little quick, so let's just reduce that to 3 frames per second. And let's just set that for each of those animations. Now add a new animation and let's add the animations for each of the tools. Add a new animation and call this filling front, add frames, and we'll choose the character sprites this time. So we'll change the horizontal to be 2 and increase the vertical so that we've got 12. Choose the top 2 and add those frames. Let's just play that. Let's stop that and reduce the frames per second to 3. Then add frames again and rename this to filling art. Add the frames, choose the character sprites again, and then choose the next two. We'll change the frames per second to 3, add new animation, call this tilling left, add the frames, character sprites, open, and then we'll choose the next sequence of frames. Play that and just stop. And change the frames per second to 3. Add new animation, tilling right, add the frames, character sprites and open, and then choose the next frames in the sequence for tilling right. Change the frames per second to 3. And let's do the same for the axe tool. So add new animation and rename this to chopping front. Add frames, choose character sprites and open, and choose the chopping animations. So we just zoom in on there, you can just see those a little clearer, and add those 2 frames. Let's change the frames per second to 3 and add a new animation. Call this chopping back, add the frames, character sprite, and we'll choose those 2 animations. Change frames per second to 3 and add another animation. Call this chopping left, add the frames, character sprite, and choose the 2 animations. So add those frames and change the frames per second to 3. Add another animation, chopping right, add frames, character sprites and open, and we'll choose the chopping right animation and add those 2 frames. Change the frames per second to 3. So click add animation and rename this to watering front, add frames, choose character sprite, and then just zoom in and choose the watering front sprites, add the frames, and change the frames per second to 3. Add new animation and say watering back, add frames, character sprite, select the sprite and add the frames. And then just set this again to 3 frames per second, add animation, watering left, add frames, character sprite, open, and choose the watering left animation and add those 2 frames. And then choose 3 frames per second, and then add the last animation for watering, and we'll call this watering right. Add frames, character sprites, and then choose the last 2 frames in the set. Add the 2 frames, and then set 3 frames per second. Now for our last set of animations, we want the character to walk, so add animation again, and we'll say walk front, add frames, but choose the basic character sprites this time, and we want the top 2 sprites here. So we've got walk in front, back, left and right. So add those 2 frames, 3 frames per second, add new animation, walk back, add frames, basic character sprites and open, and then choose those 2 sprites. Change that 3 per second, 3 frames per second, and then add another animation. Walk left, choose the basic character sprites and open, and then choose the left walking animations. And then change that for 3 frames per second again. And then for the very last animation, we will use walk right, add frames, basic character sprites, and choose the last 2 frames in the set. Add frames, and then change this for 3 frames per second. Now that we've completed all the animations, we'll just select idle front just to reset the animation here. Then let's just click on animated sprite 2D, and then using the arrow keys, we can move the sprite so that it sits on the x-axis. So we'll just sit those feet there on the x-axis, and then here we have a message that informs us we need to add a collider. So we'll add a collision shape. So we'll use collision shape 2D, and in the shape option, just click this and choose new circle shape. And then we'll just click and move this up. Just drag that, you make it a little bit smaller, and then it just covers the player. So before we move on to creating the player state machine and all of the player states, let's just go to the test scene player and add our player to our test scene. So go to the scenes folder, and in the character player folder, just drag the player onto the scene. Then let's run the current scene here. And as you can see, the player is now on our test scene and the animation is now playing. Let's close that window. Now, before we create our state machine, let's add some of the keyboard input so we can allow the player to walk. So go to Project, Project Settings, Input Map, and add new action. So we'll say walk up, add, click the plus key here, and then click the W key, then add again, and click the up arrow key. Then add a new action and say walk down, add, click the add button here, click S, OK, add again, and the down arrow key. Add another action, walk left, add, and then add key to listen for the input, and click A, OK, add, and then the left key. And then for the final action, we'll say walk right, add, and then listen for the input. So we want D, OK, add again, and the right arrow key. OK, so this sets up our inputs. Let's just close that and then save all. Now that we have set up our inputs for our player, we can head over to the player scene and we can begin creating our player state machine. The state machine makes it easier to create the actions that the player requires, such as walking, tilling, watering, and other actions for the player. We could create all of these actions using a state machine in a single script. However, I'm going to show you how to create a state machine using nodes, and each action will have its own state node. And you will see that when we use the state machine, you'll have better control when you transition from each action to another action. I have covered state machines in previous tutorials, so I'm going to ask you to download 2 scripts from my GitHub. We can install those 2 scripts into this game, and then I'll explain the functions once more. So head over to my GitHub. I will leave the link in the description below, and download the node state GD file and the node state machine.gd file. And this can be found under tutorial components and scripts, and this state machine here. So let's begin downloading those. So just click on the file and then just click download file here. And then go to node state machine and just click and download the file again. Once you have downloaded the node state machine script files, go to the root folder and let's create a new folder and call this script. In the scripts folder, create another new folder and call this state_machine. And then drag and drop the files inside of the state machine folder, and this will copy the 2 scripts over so we can then view these. When we use the node state machine script, the initial node state will hold the very first node, and then the node states will hold all of the other state nodes. The current node state is which current node are we currently running, and we also hold the current node state name. When the game begins, the children of the state machine node will be held in this array here. So we hold the node state and we then connect the transition to method, which enables the node to transition from one node to the next. Then in the ready method, when the initial node starts, we will enter into that node. The process method is then called as the game runs, and we get the current node state, and then we go into the onProcess method of the current node. At the same time, on the next frames, the physicsProcess method will be called, and we will run the onPhysicsProcess method of the current node, and then we will go to process the transitions. So this is a new method in this state machine, so we can separate the input checking which allows us to then navigate to another state if those input conditions are met. The transition to function allows the node to transition from one state to the next. And as we get to here, we will exit state node and then we'll enter the next node. In the node state, this class is attached to each of the state nodes in the state machine. We have the onProcess, onPhysics, onNext transitions, onEnter, and onExit. However, these methods are overridden, so we will use this script class to then attach our own methods inside. And as you can see, the onPhysics process method here is what we call here. So we have this onProcess, onPhysics, onNext transitions, onExit, and onEnter are these methods which are being called on the actual state node. Once we have created the state machine and added the two nodes which is idle and walk, I will show you how to debug the state machine so that you can see how those methods are being called, and that will help you when you create your own state machine for future player characters or NPCs, and then you'll be able to adapt this state machine and create your own state. So I'll click on the player node, add child node, and just choose node itself. Let's rename this node and call this state machine, and then click and drag the script and drop it on the node. Then add another child node, choose node again and create, and we'll call this idle. Then add a script and we'll call this idle state. Now in the state machine script folder, open node state script and then just copy everything out of there and go into the idle state script and paste that in. We now have an error message where the class name is. And what we want to do is copy node state and just replace node with that, and then just remove the class name because we want to actually extend node state here, and then just remove these two items here because they are actually in the node state class. So if you press Control, hover over the class name and click it, you can see that it extends from that. Go back to idle state script and just save that. In the idle script, we now need to export two variables. So type @export for player and character body 2D. And another export variable, which is the animated sprite 2D, animated sprite 2D. Then on the state machine, let's assign the initial node. This will be idle. And on our idle node, let's assign our player and assign the animated sprite 2D. Then let's add another variable called voidDirection, which is a type vector2. And in the onPhysics process, we will say if input is action pressed walk left, then direction equals vector2.left, else if input dot is action pressed walk right, then direction equals vector right, else if input dot is action pressed walk up, direction equals vector2.up, else if input dot is action pressed walk down, direction equals vector2.down, and finally else direction equals vector2.0. Then we need to say if direction equals vector2.up, then animated sprite 2D dot play idle back, else if direction vector2.right, then animated sprite 2D play idle right, else if direction equals vector2.down, then animated sprite 2D idle front, else if direction equals vector2.left, animated sprite 2D play idle left, and finally else animated sprite 2D play idle front. So first we get the input action from the user, and the player will then turn the direction left, right, up or down, and then we'll take this direction and play the associated animation for that direction. Let's save that. Now let's click the test scene player or load this from your scenes test folder, and then let's run that test scene. And if you see the player here, let's now use the WASD on the keyboard, and if you hold the key down, you can see that the player now turns in the correct direction. So let's just close that window. It is also possible to debug your script if you just put a breakpoint on line 13 where it says input.isAction press walk left, then run the test scene again, and you can then use F10 on the keyboard, or you can use these options here to step over a step in. So I'm just using F10 on the keyboard and I can see what my options are on here. So it's currently going into direction 0 on here. But what I'm going to do now is I'm actually going to put the breakpoint on 18 so that when I do press the input is action up, I want it to land on this direction here. So press F12 to keep running. Now I'm holding the D key for right, and when I press the W key, it will instantly hit this breakpoint because this condition here is met. So you can debug your code by just popping breakpoints on here and then just running the test scene here. So let's press F12 again, and let's just close that window. Now before we move on to the walk state, we're going to refactor this code first because we're going to use this in multiple places. So we don't want to keep copying ourselves when we've got the same type of code. We can reuse that. So let's head over to our scripts folder and we'll create a new script here and we'll call this game input event and just create that script. Let's open it. Let's just remove this top part here and call this class name game input event. So we're going to create our own class for this, which will allow us to add these methods in there. Just remove the content here and we'll call this movement input. So we'll create a static function, movement input, and that will be a type of vector2 and we'll return the direction out of this method. Then go back to the idle state and copy the code from that method into here. Then add a variable static for direction, and that will be a type of vector2. And as you can see, that has rectified those error messages here. And we still have an error message here because it is expecting us to return a type of vector2 out of this function. So we just return here and then we can say return the direction. So this function has been strongly typed. We are defining what we would like to return as a type. And the direction here is vector2. So if you change this to string, as you can now see, direction isn't of type vector2. So you must return vector2. We'll add another method in here which will help. So it says static function, and we'll call it is movement input, which will return a bool. And we'll check if the direction is equal to 0. Let's return false, else return true. So the is movement input function will just determine if the player is actually moving. Now head back to the player and click on the idle state script, and we can now delete this bit of code here and just say direction equals game input event dot movement input. We can then go to test scene player and test the scene again and just hold the key down just to quickly test that that is working and just stop that. Now we are ready to create our next state, so head back over to the player. Let's add another child node to the state machine. So add child node, choose node and create, then rename that to walk and attach a script. We'll call this walk state and save that into the player folder. Let's open the script and then we'll go back to the node state script and we will copy all of the methods out of here like we did with the idle state. So go back to walk state and then just overwrite everything in there. Then copy node state and paste this over node and then just delete that class name and then just remove those two items at the top because we are extending the node state class. So let's begin by adding our export variables. So say var player character body 2D, at export again for animated sprite 2D, at export again for speed integer equals 50. Then in our onPhysicsProcess method, we'll say var direction vector2 equals game input events movement input. So we're using our game input events movement input function to get hold of the direction, and we're using it as a strongly typed variable for direction. Then we'll say if direction equals vector2.up, then animated sprite 2D play walk back. Then we'll say else if direction equals vector2 right, animated sprite 2D play the walk right animation. Else if direction equals vector2 down, animated sprite 2D dot play walk front. And then elif direction equals vector2 left, then the animated sprite play will walk left. As you can see, this code is the same as the idle code here, except we're going to use different animations. Now the last thing to apply is the velocity. So say player.velocity equals direction times by speed, and say player move and slide. This should then allow the player to move as we start to change the direction using the WASD key. Let's head back over to the idle script, and what we now need to do is to transition to the walk state when we are moving. So in the onNextTransitions method, we will start to make some changes here, because if we look back at the state machine, because after the onPhysicsProcess method, we also then check on the onNextTransitions to see if we have any inputs which we can check against and then transition from one state to the next. So go back to the idle state, and in the onNextTransitions method, first we'll check if there's any movement input. Then we will check if the is movement input is returning true or false. And then we can call the signal, which is inside node state here, which is registered in the state machine. And we can say transition and then use the walk state. Now click back onto the walk node, and on the player, just click assign and assign that player node to the player variable. And for the animated sprite 2D variable, just assign the animated sprite 2D. We are now ready to test the scene player. So click on test scene player and let's test the scene. And before we press any keys on the keyboard, the player is currently in the idle state. And if we just press a key, we can see that the current state is walk. But when we release the key, it doesn't go back to the idle state. So let's just stop that. So head back over to the player, and in the walk state, in the onNextTransitions function, we'd like to say game input event is movement input is returning false using the not operator. And if we're not moving by using this, then we want to transition back to idle. Just save that. But first of all, I just want to make a quick modification to the state machine. I'm just going to copy this print statement here, and I'm going to paste it in the PhysicsProcess method so that we're always pushing out the current state to the output window. Save that. Let's go back to test scene player. Let's run the test scene. Now hold the D key, and as you can see in the output window just below the game window here, you can see we're now in idle, and then we're in walk, idle again, up walk, we're walking left, release, back into idle. Okay, so let's just walk right one more time. Now when I release, the player faces forward. Let's go left, release, and the player is facing forward again. Let's fix that so that when you release, the player stays facing in the correct direction. So if we look at the walk state, we get our direction from the game input events movement input function. However, in the idle state, we also do something similar here. So what we need to do is to get the direction when we are in the walk state and then store that, so that when we then go back to the idle state, we only pull the last direction state which was saved at the time. So it is possible to do that by storing a variable on the actual player itself. So select the player node and let's create a new script. So attach a script and make sure the template is off because we want to just create an empty script, and then we'll create that. So just open the script, and inside of the script, let's create a new variable. So we'll say var player direction, and the type of that is vector2. Now head back over to the walk state script, and after the last else if, we can say if direction is not equal to vector2 0, then player dot player direction equals direction. However, if you notice, when you type player direction, it doesn't appear in the IntelliSense. And this is because we're using dynamic types. So if you go back over to your player script, this variable can't be found because we need to give this a class name. So we can say class name player, which derives from character body 2D, and the player will now have the variable player direction. So we go back to walk state now, just save everything first, and then save player.player direction. So it's still not there, and this is because we're still only using character body 2D. So let's use that class name as player. So you can now see that it's here, and it's got the same icon as a character body 2D, because if you go back to the player script, the class is a player, which still extends from character body 2D. So player has player direction and everything that character body 2D has as well. So let's go back to walk state now. We've changed this to player, and we see player.player direction equals direction. So we now have that IntelliSense. And that has been made possible by using class inheritance. Now that we are storing the player direction in its own variable and assigning this from within the walk state, we can now make a modification to the idle state. First, in the idle script, let's just change this player to say player here. Then remove this first line here, and then say player.player direction. And then just copy this over the direction items as such here. We can also remove the local variable as well, because we're getting the player direction from the player here. Now in the idle script, as we transition from idle to walk and then back from walk to idle, we just want to stop the animation. So we just copy the animated sprite 2D, and then when we exit this state, we just want to stop the idle animation, because as we go into the next state will handle its own animations. So on exit from the idle state, we'll stop that, and then we'll go to the walk state, and when we transition back to idle, we'll exit again. So we just want to stop the walk animation too. So head back over to the test scene player, just go back to the test folder, load test scene player, and then let's run that test scene. So let's hold the D key down so you can see that the current state is walk. But as you release the key, the idle state is in the correct direction. So let's go up, and the idle state is correct. So we're in walk, and then as we release, the character is facing left and then forward again. So we've now resolved how to store that player direction and use that in other states. Let's just stop that. Now that brings us to the end of this tutorial on how to create a player with a state machine and two states, which is idle and walk. In the oncoming tutorials, you'll be advancing on the state machine to create different states for chopping trees, tilling the land, and watering the crops. I will show you how to create the three different tools for the player. These are chopping, tilling, and watering. We will create the states and transitions for the state machine. In the previous tutorial, I showed you how to create a state machine for the player and the idle and walk state. In this tutorial, I will be showing you how to create the chopping, tilling, and watering states. In the state machine, let's add a new node. Choose node and click create, and rename this to chopping. Let's add a script, and we'll call this chopping state. And create that. Then in the scripts folder, in state machine, open up the node state script again, and select everything, just copy that, and then go back to the chopping state, and then just paste that in, and then copy node state, and then change that on the extends. So we'll extend node state and then just remove these two as they come from node state. Now if we go to test scene player, which is under the test folder, let's just run this scene. And what we need to do is to allow the player to move into the chopping state. So we need to create some tools and then allow the player to select the tool to then move into the chopping state. So let's just close that. Then head over to the scripts folder and create a new folder and call this globals. Inside the globals folder, create a new script and call this data type. And open up the data types script. Then we'll create an enum and call this tools. And the enumerations will go non, axe, wood, till, ground, water, crops, plant, corn, and plant, tomato. So throughout the game, we're going to use these different tools to perform these actions. So we'll just create the enum now up front. Then we wish to access the tools from anywhere within our script. So let's remove extends node and we'll call this class name data type. Then let's go to the player script and let's export a variable. So say at export for current tool is data types dot tools equals data types dot tools dot none. So we'll just default that to none for now. Now let's head back over to the idle state and in on next transitions, we can say if player dot current tool equals the data types tools dot axewood, then transition to chopping. Now let's test the scene. So go to test scene player. Let's just run the test scene. And as you can see, we've got the current state here. Let's just go to our player and open that scene. Let's just bring the window back. And let's just change the current tool here. So we just say axewood, and we can see that the current state has moved in from idle into chopping. Let's just stop that. Now that we can move into the chopping state, let's make some more modifications to the chopping state script. So when we reach the on enter, we want to animate the sprite based on the player's direction. And for each chopping animation, once the animation stops playing, we want to then exit the state and go back to idle. So let's begin writing the code for that. So let's export some variables. So say export for player and then export for animated sprite 2D and then the animated sprite 2D. Then in on enter, we say if player.player direction equals vector2 dot up, then the animated sprite play and then chopping back. So we can view our animations again from the animated sprite 2D and we want to run this animation here. So I'm just going to write the rest of this code. And as you can see, this code is very similar to the code which we've used previously in our idle and our walk state. However, we would like to just play the animation as we enter the state. So we're just going to leave the physics process empty. Then on our next transition, we need to check if the animated sprite is playing. So we can say if not animated sprite 2D is playing, then we can transition back to idle. And then once we transition, we can just say on exit animated sprite 2D dot stop animation. So this will stop this animation as we move back to our idle state. But it should have already stopped anyway, but this just makes sure. The next thing to do is to just go into your animations and for chopping back, make sure looping is now off. For chopping front, looping off, chopping left, looping off, chopping right, looping off. So we only want to play the animation one time. So as we go into on enter, the animation will play. Then we check if the animation has stopped playing, and if it has stopped playing, we transition back to idle. Let's go to the test scene player again, and let's just run that. Okay, so that's currently not working. What we need to do is just go back to player and click chopping, and just make sure we assign our player to those export variables. So we've got the player variable and the animated sprite 2D variable. Now go back to test scene player and let's just run that one more time. So as we can see, the animation is going between the idle state and the chopping state. Let's just go back to our player. Okay, so on the player, we've got it on Axwood. That's why it's switching between the two. So we go into the state, it plays the animation, and then comes back out. Let's just change that to none. So we're now in idle. Let's change that to Axwood, and it's now Axwood. Okay, let's stop that. If we go back to the idle script, the next thing we need to do is to only trigger transition into chopping when we actually press the mouse left button down, and this will act as the chopping action. So let's go to project settings, input map, add a new action called hit, add, and then add button here. And for the event, in the listening for input, just click the left mouse button down and click OK. And we'll just close that. Then head over to scripts, open up the game input event script, and let's add a new function called static function, call it use tool, and we'll return a type of bool. And we'll say var use tool value, which is a type of bool, and then use input dot is action just pressed, and then pass in hit, and that is the name of our action which we've just created. And then we'll return the variable use tool value. Then head back over to the idle script, and in the idle state script, we can just check for the player's current tool, and in the game input event, check if we're actually using the tool hit event. Now let's test the script, go back to test scene player, let's run the test scene, and then let's just press the left mouse button down. So remember on the player, we need to have Axwood set here, because if we just set that back to none, and then just view our game, if I click the mouse button down, I can still move left and right because that's the warp state, as you can see here in the current states under the window. Just move this up. So walking, then let's just activate the Axwood, bring the window in, and then if I click the mouse button, and I can move all the different directions and click in the mouse button. So if I'm walking and I click, it doesn't show the axe animation because that is what the state machine will do. We are making sure that we transition to the correct state when our conditions are met. So when we're walking, we don't want to be able to chop at the same time. And then chop, stop, and then chop. Okay, let's close that window. Now for our tilling state, let's create a new node on the state machine. We'll just create a node and then rename this to tilling. Let's attach a script and we'll call this tilling state. And let's create that. Then head over to the chopping script and just select everything in the file. Let's copy that, go back to the tilling script, and then just paste the content. So everything is the same for the tilling state and the chopping state. However, we need to change the animations here. Let's open up Animated Sprite 2D and let's just check the tilling animation. So tilling back, let's turn looping off for the tilling front, tilling left, turn it off, and tilling right, turn looping off for that. Then, instead of chopping, we just need to say tilling. Let's just copy and paste those values there. Now let's head back over to our idle script and let's just copy these two lines here. And we'll say if the player current tool, and instead of Axwood, use till ground, and we want to still keep our game input event as use tool, but this time we'll transition to tilling. We're now ready to test our scene, so go to test scene player, run the test scene, and let's just click on our player. Let's just view our current tool. So this is now on Axwood. So if we go left, we've got Axwood. Let's just change the tool now to till ground and open up the window. And we can see we still got another error here. And this is because we haven't assigned our variables again. So let's just stop the test scene, and on tilling, let's just assign player and assign animated sprite 2D. Go back to the test scene, and when we move left, we now have tilling. So you can see the current state change in the bottom, and that's everything working for our tilling state. Now for the watering state, this will allow the player to water crops and then they'll grow. So we'll go to our player, add child node, create a node and call this watering. Then attach a script and we'll call this watering state, and we'll get our tilling script, copy everything, go back to the watering script and then paste that in. We'll just save everything. Then on the watering node, let's just assign our player and assign our animated sprite 2D. Then let's choose the animated sprite 2D, and on our watering animations, let's just turn looping off for each of the animations. And then where we have tilling back, let's just update this as well. Now let's head back to the idle script, and we just need to copy these two lines once again. So we can say player.currentTool is equal to water crops, and we still want to use the tool. So once we have this tool, we can then go to our watering state. Let's go back to the test scene player and let's test that. So select the player again, and as we move left and press our left mouse button down, we're still tilling the ground. I'll just open the output window as well so we can see that. So tilling, idle, and then let's just choose water crops, and we can see that we are now using the water crops animation. So I'll just close that window. Now that brings us to the end of this tutorial on how to create the different tool states for the player. So we have chopping, tilling, and watering. It is possible to use tile maps to create variations of different scenes. You may have smaller tile maps which hold assets for creating houses, for example. In this tutorial, I'm going to show you how to use tile maps to create small scenes which can then be added to a scenes collection and then used in your game. I will also show you how to create a custom component which can be used as an interactable, which opens and closes the door to one of the houses. When you then test the scene, you will be able to walk through the door. And these are the various different houses, all created from the same tile map. So before we get started on creating our house tile map, I'm just going to show you a little technique on how we can change the folder colours so that we can better organise the project. If you right click the folder, there is an option here for setting the folder colour. So for the root folder for assets, I can make this orange. Then I can see that all these folders here are asset related folders. Then for scenes, I will change this for green. Scripts, I will change this to pink. And for tile sets, I can make that yellow. So feel free to choose any of the colours. You can also change the colour of a nested folder too. And this just makes it really easy to see what type of folders they are, what type of content is contained in those folders. And as your project grows, you may find it easier to use a colour scheme or colour code those folders. Let's head over to the scenes test folder and let's just make a copy of the test scene player. So for this scene, we'll say right click and then duplicate. And what we'll call this is test scene house tile map. Then just duplicate that. And let's just close the test scene player and then open up the test scene house tile map. Let's just click the test scene tile map node and let's just F2 that, and we will rename this test scene house tile map and then just save that. So to create the house scene, let's go back to the scenes folder, create a new folder, and we'll just name this houses and click OK. And then we go scene, new scene, 2D scene, and then we'll rename this to large house and just save that scene in the houses folder. So in the large house scene, we can create a new child, choose node 2D, and then rename this to house tile map. Then add a child node, and we'll search for tile map layer and rename this tile map layer to floor. Then in the tile set, let's create a new tile set. I'll just drag this up a little. Then right click and save as, and then in the tile sets folder, we'll save this to house tile set. Now click on the house tile set, and in the tile set menu here, let's then go to our assets folder, and in the tile sets folder, we have a wooden house walls asset. Let's just drag that into our tiles and just say no to the atlas. Then under setup, let's just click and activate the floor tile. Then click on tile map, choose the floor tile, and let's start to paint the floor. Once the floor has been painted, we can then go to the tile set, and then let's just start to set up the walls. So let's just choose these walls here, and then this window option here. The next step is to draw the walls for the house. So if we just zoom in on the walls, first of all, before we paint them, we should add some collision shapes so that the player can't walk through them. So just go back to the tile set, just activate it, and then click Physics Layers. And on the first collision layer, let's just rename this layer and call it ground. Now, I know these are walls, however, with it being a top-down 2D game, I'm going to consider walls and the ground to be the same thing, but however, feel free to call this layer walls, and then you can manage ground items and wall items as something completely different. So I'm just going to rename that. And to draw the collision shapes, just click select, choose the first cell, and then in physics, let's just begin adding our shapes. So we'll click the plus button here, and then we'll start to draw that. For snapping, let's turn on half pixel snap, and this will just help us to get a really good pixel snapping as we draw the shape. So as you can see, this is now covered. And then in paint, let's just choose that property. So we go paint, physics layer, and then you can paint that, and then choose on half pixel snap, and we'll just start to snap the markers to create our shape, and then paint that. We can leave that the same, then paint that again, move the markers again, and then click it, then paint and paint again, then choose this one and then just cover the full item. If you click it so that it highlights here and then press F, it will fully fill it, and then click it there. And then we can just paint that one as such. For these four, now that we've got this fully filled, you can just paint them. And for the window, we can also just paint that. So that completes the physics collision shapes. Just save that. Let me just drag this down. Then under house tile map, let's add a child node, create a tile map layer, and rename this to walls. Then in tile set, let's just load the house tile set, and in tile map, let's start to draw our walls. So we'll start with the left hand side and then just add these. And just add the corners in. And another corner here. And then we can just finish those walls there. So we can leave a space for the door. And then I'm going to add some windows. So one window here and two windows here. We could possibly put two at the back. So then that completes the house. And now we're ready to add some furniture. So under house tile map, add child node, new tile map layer, and just rename this to furniture. Then under tile set, quick load and choose the house tile set. Then in our game assets, we can go to object. So we should have an asset for basic furniture. So just choose tile sets here and then drag the basic furniture asset into there. Just say no for creating the atlas. Then on setup, let's just activate the tiles which we will paint. So holding shift down, we can create the bed assets and select multiple tiles. I'll just open this so we can zoom in a little bit more. And we've got two cells for each of the beds, single ones for the carpet, another double as such, and then we can activate the chairs and the blocks for the walls. We can now create the collision shapes for the furniture. So click on paint with the physics layer set to 0, which is, if you click on the tile set here, is the collision layer which we've already set to ground. So I'm going to just choose the asset here, and then holding control, I can zoom out a little bit on the asset to set up the physics layer here. And then I'm just going to turn on half pixel snap and then just start to bring in the markers just to cover the asset itself. Once I'm happy with this, I can then paint the beds. That's all the beds covered. And then let's repeat the process for the wooden furniture, which is the tables, the cabinet and the chairs, and these 6 flowers here. And that's finished setting up the furniture and the plants here. Now that we have set up the tile map, we can just reduce the size of this here and then click on furniture and start to draw some of the furniture in the house. So we'll go for press the Z key to rotate. And that completes setting up the furniture for the house. So as you can see, it is easier to create the house using a scene and then a tile map, which is just associated for the house assets. And then you can start to create different scenes with different house types. So for this one, I've created a large house. Now head over to test scene house tile map, and we would like to add the large house to this scene. However, what we can do, which is better, is to just add a child node to another tile map layer and call this houses. Then in the tile set, quick load and load the game tile set. And in the tile set option, we want to add and choose scenes collection here. And this will give us an empty scene collection. Then drag and drop the large house scene into here. And this will add the large house to the scenes collection. Then click on tile map and we can then paint this house here. So we can just pop that as such there. Once we've placed the house, we can do this multiple times. I'm just going to remove that and we can now test the scene. However, I'm just going to switch on the visible collision shapes in the debug menu. Just turn that on and then let's test our test scene. So we'll just run that and let's just see if the player can first walk through the wall, so that's okay. I think the collision shape on the player is probably going to be a little bit too big, so because we can't get through the door. So let's just then close the scene and then let's reduce the size of the collision shape. So select collision shape here and just reduce the size. And then we can just move that to the bottom of the player. Then head over to test scene again and run the test scene. So now when we move the player, we still can't go through walls, but we can now enter the house. And we can't walk through the furniture, the bed, but we can walk around the house as such. Okay, let's stop that. We are now going to create a door for the house for the player to walk through. And I'm going to show you how to create your own custom component, which will act as an interactable to allow the door to open and close. So go to scene, new scene, 2D scene, and then just change the type and choose static body 2D and just change that type. Then add a child node and search for animated sprite 2D and create that. Then with animated sprite 2D selected, choose animation from this option here. Then click in sprite frames, add new sprite frames and rename this to open door. Then choose the frames option here. Then go into assets, game, tile set and choose the doors tile set. Then let's zoom in, then change horizontal to 1 and choose the frames in this order. So it's the closed door first and then as it starts to open. So it's 0, 1, 2 and 3. So add those. Let's zoom in on the door in our scene. Let's turn looping off and then let's just play that animation. Let's add another animation and call this closed door. Click on the frames, choose doors again, let's zoom in, and then we'll choose the top one, 0, this one as number 1, number 2, and number 3. Add those frames, turn looping off, and then let's just play that animation. So we'll create a default animation for when these scenes start. So we'll actually put this back and call it default, and let's just turn looping off, open up the sprite frames, go to doors, open, and we just need the one frame, which is the door automatically closed. Then set this to auto load so that this always displays when the scene begins. Let's rename the scene, we'll just call this door, and then let's save the scene. We'll go to scenes, houses, and just save that scene in the houses folder. So we need to add a collision shape as this warning is telling us to do so. So we'll say add child node, collision shape, new rectangle shape, and then just resize this so that it fits over our sprite. Save the scene again, and then click on door again. And we want this collision shape to be on the layer ground. However, let's go back to the player and check what layer is the player on. So the player is currently on the collision layer of ground. So what we need to do is edit the layer names, and let's add a new layer called player. Then choose layer 2 to put the player on that layer, but we'll always collide with items that are currently on the ground. Let's go back to the door scene and let's add this scene to our house. So let's go back to large house scene, and on the walls tile map layer, let's go back to our tile set, and in tile set, let's add a scenes collection. Then drag the door scene into that scenes collection here. Then with walls selected, go to tile map, choose the door scene, and let's just paint it here. So as you can see, we now have a scene painted in the tile map. Now let's test the scene. So let's go back to debug, just make sure visible collision shapes is still on. Go to test scene house tile map, and let's just run the test scene. So we'll move the character and just make sure the character still can't get through the door. So that's correct. But what we want to do is when the player approaches the door opens, but the character then can go through the collision shape. So let's just stop the scene. So back on door, we need the player to approach the door and it to open. So I'm going to show you how to create your first extensible component. Sometimes it's better to use components if we're always going to do similar actions. So I'm going to create an interactable component which will always receive the player and can then do some actions on that. So let's just create a new folder in scenes, and we'll call this folder components, and just click OK. Inside the components folder, let's create a new scene, so a new 2D scene, and just change the type and search for area 2D. Then rename the scene and call it interactable component. Then save the scene into the components folder. Then attach a script and we'll call it interactable component. So just create that script. And then above the extends, we'll call this class name interactable component. Then we need two signals, which is interactable activated and signal interactable deactivated. Then select the interactable component and choose node, and then choose body entered and then connect. Then body exited and connect. Then in interactable activated, when we get an on-body entered event, we just want to emit that signal. And then in the body exited event, we just want to emit that signal as well. Then click back on interactable component and just go to the inspector. And we need to change the collision layer. So let's edit layer names. And for the third layer, call this interactable and just close that. And then just add layer 3, which is interactable. And we want to interact with the player layer. So turn off round and then just choose player layer. Okay, let's head back over to door and let's give the door a script. So create the door script, and that's saved in the houses folder. Then let's add the interactable component to the door. So go back to components and add the interactable here. Once the interactable component's added, then we can add the collision shape. So go back to 2D here and then create the collision shape. So we say add child node and add the collision shape. Then in the shape, we'll just add a rectangle. Then I'll just create the shape so that we have a space before the door and some collision shape after the door. So let's just change the colour so that it's a little bit easier to distinguish between the two collision shapes which we have. And we don't need to set any collision mask because we've already done this on the interactable component. This is already pre-configured for us. So let's save that and then go back to the door script and then choose all 3 items, click and drag, and then hold down the control key. And this will automatically create us our onReady variables. Now let's link up the interactable component signals. So first of all, we need the ready function. So say function ready. So interactable component, then get the interactable activated signal, and then use the connect function to connect the uninteractable activated. So we'll just create this function too. We'll just say pass for now. Then we say interactable component. When the interactable is deactivated, then connect. And we can say function on interactable deactivated. Just pass and then save and then place a method into the connect function. The next thing to do is to play the animation when the uninteractable is activated. So let's just say animated sprite 2D, play open door. And when the uninteractable is deactivated, then we'll play close door. Let's just put 2 print statements in here for debugging, and we'll just say activated and deactivated. Let's just save that. Okay, let's go to the test scene house tile map, and let's just test. So go to debug and make sure visible collision shapes on, and then run the test scene. Okay, let's just have a look at the print statements here, which is on the output. Now we are outputting messages from the state machine, so let's just stop that first. Let's just, while it's running, you can just go to scripts, state machine, inside the state machine, and just comment this line out. Comment this one as well. Let's just clear the output queue. Go back to the game. Let's just move the character so we're not getting any more output messages. And then let's just move the player into that area. So we can see that's activated. That's now calling that message, and we come out and it's deactivated. And you can see the door is opened, but we can't get through the door. And the reason is we still have another collision shape. Now that collision shape is to stop the player from just walking through the door. So there's 2 ways we can do this and solve this problem. We can either hide that collision shape, or we can change the collision layer temporarily. So let's just stop the scene. If we look at the door and go onto the collision shape here, you can see that the collision layer is on ground and the player is stopped by any items that are on the ground layer. However, what we can do is temporarily change the collision layer so that it's on the same layer as the player. So what we'll do is, because we're already on the static body 2D object, we can say when the scene loads, set the layer to 1. When the door opens, set the layer to the same layer as the player. So the player will walk through the collision shape. And then when it's deactivated, set the collision layer back to 1. So let's test the scene again. Let's go to test scene house tile map, go to 2D, and then let's test the scene. So now when the player goes into the area, the door opens and the player can walk through. So you can still see that the blue collision shape is still visible. However, it's now on the same layer as the player, and the player can just walk through. So that's a way to resolve collision shapes going through other collision shapes, is by modifying the mask temporarily. Let's just stop that. So this would be really useful if, for example, the player had a key and the key's in the inventory. As the player approaches the door, it activates. However, it requires the key, which changes the collision layer and then allows the player through the door. However, I just thought I'd show you an alternative technique on how to switch collision layers during the game, as this can be really useful in certain scenarios. So now you know how to create houses using tile maps. You can then create various different styles of houses and then paint these throughout the game. I'm going to create a medium-sized house and a small-sized house. Now I'm going to duplicate the medium house and call this small house. Just duplicate that scene. And then I'm going to repeat exactly what I've just done for the medium house. Now that brings us to the end of this tutorial on how to create scenes using tile maps. In this case, we have house tile map, and we want to create some variations of houses using a smaller tile map. We can create several different scenes, then add them to a scenes collection, and then paint them throughout the game. I will show you how to create trees you can chop down and then add them to your tile map scene collection for easy use in any scene. We will also cover hit and hurt components to apply damage when using the axe tool, and create reusable collectible components to gather logs and other interactable items. Let's begin by creating a new test scene. We'll just take the test scene default in the scenes and tests folder, and let's just duplicate this. Let's just call it test scene, objects and trees, and let's open the scene. So we'll use this test scene just to try out our trees once we've created them. And in the scenes folder, let's create a new folder and call this object. And then inside that folder, we'll create a new folder and call this trees. So go scene, new scene, other node, search for Sprite 2D, and then click create. We will rename this node to small tree, and then just save the scene. Go to the scenes folder, objects, trees, and then save the scene. So click on small tree, and in the texture, let's add a new atlas texture. Then go to assets, game and objects folder. And in that folder, you'll have a basic grass and biome thing. So let's just drop that asset onto the atlas. Then scroll down and choose edit region. And we'll just zoom in. So we want this tree here. Let's just choose grid snap, and we'll zoom in, and we want to just take this tree here. Let's just close that and then zoom in, and we have our asset here. Now let's reposition the asset. If we just click the up arrow, we can transform the Y position. So we can see that the Y axis is increasing on the transform. Let's add another child node to the small tree. So add child node, then search for static body 2D. Add another child node, and this time search for collision shape 2D. And in the shape parameter, let's just choose this circle parameter. Let's just reduce the size of that, and then just drag that and just position it over the base of the tree. So we would like our player to collide with the collision shape for the static body 2D, but not move through the shape. So this is why we're using a static body 2D, because the player shouldn't be able to move through that collision shape. So let's just check on static body 2D, and we will keep the layer on ground. So if we just look at the layer names once more, we have ground, player and interactable. Let's now add the small tree to our test scene. So in the test folder, open up the test scene objects trees scene, and then in the game tile map, let's add a new tile map layer. So say add child node and search for tile map layer, and then add that layer. In tile map layer, let's rename this to trees, and in the tile set, let's just load the game tile set and open that. Click on the tile set, and with the tile set option selected at the bottom, let's then go to our objects and trees folder, and let's add our scene. So we can click the plus button here and go scenes, objects, trees and small tree, or you can click and drag it. Once we've added that, go to tile map, and then on the trees layer, let's just click the small tree and let's just start to add those trees. Then let's add the player to the scene. So we can just grab the player, just add the player to the scene, and then just add child node and just quickly add a camera 2D. Then just make sure the player is below the tile map here. And with the player set up, let's test our scene. So go to debug and just switch on visible collision shapes and then test the scene. And as you can see, the player cannot walk through the collision shape because of the static body 2D. However, let's just try and walk behind the tree. And as you can see, the player just walks over the top of the tree, and this is because Y-sort is not enabled. However, I'm not going to cover Y-sort in this tutorial. I'm going to cover that in a future tutorial because I will show you how to perform Y-sort on many different objects at the same time, and why it is better to do it through a test scene because Y-sorting can be quite tricky. The next step is to create a hit component and a hurt component. The tree will have the hurt component, and when the player has the axe, that will be the hit component, and as it interacts with the hurt component, it will apply damage and then chop the tree down and produce logs. Let's go to scene, new scene, other node, and search for area 2D and create that. And then rename this to hurt component. Let's save the scene, and in the components folder under scenes, we'll save the hurt component here. Now attach a script and we'll save this as the hurt component GD script and just create that. Let's now give this a class name and call this hurt component. Then add an export variable, which is tool, and then we'll use the data types variables with tools and the enum tools.none. Let's create a signal called onHurt. Then back on the hurt component, just select that and then go to node and choose area entered and then just connect that. So click connect here. Now to create the hit component, go scene, new scene, other node, and we want another area 2D. So create that and then rename the node to hit component. Let's save the scene. And save that also in the components folder. Click save. And then let's attach a script. And we'll also call this hit component GD script and create that script. Then we'll use class name hit component and then export another variable, which is var current tool, and then we'll use the enum data types tools and then assign the tools none. Then add another export variable and call this var hit damage, and we'll give it a default value of 1. So as you can see, for the hit component, we derive from area 2D, and we also do the same for the hurt component. You'll see the error message here because it's asking us to configure a collision shape 2D. However, we are going to attach these components to other nodes and scenes, and then we'll attach the collision shape there. So we are deriving from area 2D and making something a little bit more customizable and reusable. So let's go to our player scene and open the player scene. And from the components folder, let's now attach the hit component. So if we just open this up here, let's add the hit component to the player. First, just make sure that the position in the transform is 0 and 0 for the X and Y. And then we can now attach a collision shape. So add another child node and search for collision shape. And we'll create a small circle. Let's change the color so it distinguishes the hit component shape from the player's alternative collision shape for interacting with the ground objects. Let's make this shape smaller and then choose the hit component and let's add a different collision layer. So if we just edit the collision layer names, in here right tool and click close, and then edit layer names again and right object, then click close. So the collision layer for the hit component should live on the tool layer. So the best place to do that is to actually go back to the hit component here, open the scene, and then add it here. If you add it on here, you can then attach that hit component and keep changing those layers, but we want it on the default actual scene component here. So we'll go in the collision layer, choose tool, and then turn off 1. And in the layer mask, we want it to interact with object layers. So that is layer 5. So if you attach the hit component to any other characters or any other NPCs, you wouldn't actually need to keep selecting the layer and the mask, because we've created our own custom version of the Area 2D and called it hit component. And this is one of the benefits of Godot and the node structure. You can create your own custom components which have predefined settings and are extensible from the original node types. So let's head back to the player scene. The next step is to reposition the collision shape based on the direction of the player when we are chopping. So when we are in this state, we need to now modify and move where the collision shape is. Let's open up Animated Sprite 2D, and then let's find chopping right, and then let's choose this animation here and just play that. So we need to move this collision shape so it sits on top of the axe. So let's just move that. And if we look at the collision shape value, we have an X value of 9 and the Y value is 0. So now that we know the transform position for the collision shape, let's now modify this through the script. So go to the state machine node, and in the chopping state node, choose the script, and let's export another variable. So say @export, and we'll call this variable hit component collision shape, which is of type collision shape 2D. Then create the ready function and say hit component collision shape dot disabled, and we'll set this to true by default. Then hit component collision shape dot position vector 2 with X and Y as 0, and scroll down to the onEnter method. And when the onEnter function is called, let's get the hit component collision shape and set disabled to false to activate the collision shape. When we then exit, we want to say hit component collision shape and then set disabled back to true. And then also in onEnter method, when the player direction is facing right, get the hit component collision shape and set the position to vector 2 X 9 and Y 0, which is the transform position here. Now we can then reset this back to 0 0, which is the starting position. And when the player direction is facing left, we can do the same thing except use -9 for the X variable. So hit component collision shape dot position equals vector 2 -9 and 0. And this inverts the X, so we've got 9 for right and -9 for left. So we just need to set the position for the player direction facing up and the player direction facing down. So go back to the player and change the animation again. So we'll go chopping front and then just play the animation and then just position the collision shape into the correct place. So we've got X is 0 and Y is 3. Do the same for facing up. So chopping back. And we can say that X is 0 and Y is -18. Let's just reset those. And once we've reset the values, let's go back to our chopping state script and then update these values. So chopping back. And that just updates the position for the hit collision shape. So now choose the hit component collision shape and just rename this as hit component collision shape 2D. Then choose the chopping state node, and we just need to assign this collision shape to our export variable in the hit component. Then head over to the test scene. We'll just check again that visible collision shapes are on. Go to the test scene, and on the player node, just make sure that we choose the axe as the current tool. And then let's click the test scene. And then as we click the mouse, we can see the collision shape move, and also as it turns red is active, and then we've got up and then down. So what we now need to do is when we go to the tree and click to activate the tool, it should then start to chop the tree. Let's just stop this. So go back to the hit component and let's just finish the onAreaEntered method. And we want to say var hit component equals area as a hit component. If tool equals, and then we can say hit component. And because we've made this as a custom component, we have access to its properties. So we've got current tool, then we can call the signal and emit hit component, and then the amount of damage that that hit component can emit. So head back over to small tree, and in this scene, let's add hurt component. So we'll go back to the components folder and then just add the hurt component as a node. And then this is where we can now add our collision shape. Let's add the child node, and then for collision shape 2D, let's just create that. But for this, we'll choose a rectangle shape and then change the color to distinguish it. Then let's just resize it for the tree and just save that. Let's just rename the collision shape to hurt component collision shape. And then we just need to check the physics layers. So we're not going to change them here because we've added that to the small tree. We'll actually go into the hurt component because this is the custom one. Click that, and then let's just set the layers. So we have ground layer. So this is object, and we're going to mask the tool. And you'll see that that is the inverse of the hit component. Let's create another reusable component which manages our damage. So I'll go scene, new scene, and we'll just use a standard 2D node for this. And we'll just call this damage component, save the scene, and choose the components folder, which is under scenes, save that, and then attach another script. And we'll just call that damage component script and then create that. So click the damage component script and then call this class name damage component. Add an export variable, which is maximum damage, and we'll just set this to 1. That's just the default. Add another export variable, and we'll call this current damage, which is just set to 0. Then let's add a signal, and we'll call this max damage reached, and create a function. We'll call this apply damage, and we'll pass in an integer of damage, and we'll just return it as a void. Then we want to set the current damage, and we do this by clamping the current damage with the damage value that's coming in, so that we don't end up with the current damage more than our max damage. Then we can say if current damage equals maximum damage, then let's emit our signal. Now head back over to small tree and add the damage component to our small tree. And let's set the variable. So the maximum damage for the small tree, let's set that to 3. Now we've almost finished the small tree scene. What we just need to do is link up the signals which we've got from our reusable components. So let's just go small tree, and then let's add a script. Let's save the script as small tree and then create that. So click the hurt component and damage component, so they're both selected, then hold Control down and then add them into the editor here. So we've got 2 onReady variables. Then add the ready function, and then we can get the hurt component and then connect the signal. So say function onHurt, and then it's hit damage with a return type of void. Then once we receive the hit damage, we just need to pass that into the damage component. So we can say damage component apply damage and just pass in the hit damage. So on the hurt signal, just need to add the connect method, and that will just connect that up. Then let's complete our damage component signal. So we say damage component, max damage reached, and then connect that. So we'll say on max damage reach, then create the function. And here we just want to print and then Q3 to remove the scene. I'm just going to go back to the hurt component and just update this method. So I'll just call it hurt and go back to damage component, and then go back to the small tree script, just modify that. And then just make one more check for the hurt component here. So let's just check the signal because I did update that, and then just also rename that back to hurt so that it's got the correct signal name. Now let's head back over to our small tree scene, and we've now completed the script. So let's go to our test scene, objects and trees, and let's just run our scene. We'll leave visible collision shapes on for the moment, and then let's just move the game window up, and then we'll just hit the axe, so 1, 2, 3. And you can see that max damage has reached. And we'll just do that one more time for one of the other trees. So we'll say 1, 2, 3. So now what we need to do is to instantiate a log when the tree has been chopped down. So to create the log scene, go to Scene, New Scene, Other Node, and search for Sprite 2D. Let's rename the node to be log and save the scene. Go to the Scenes folder, Objects, Trees, and save the log scene here. Then in the texture, choose Atlas texture and just open that. And then in the Atlas texture, let's just add a new texture. So go back to our game assets here and under Objects, bring over the basic grass biome things. Then in Edit Region, with Grid Snap selected, zoom in and then choose the grid round this log here. Just click Close. And then let's zoom in on our sprite. And now we're going to create another custom component which we can use to collect the log. So this can be then reusable. So go to Scene, New Scene, Other Node, and search for Area 2D again. And rename this to Collectible Component. Let's save that. We'll put this into the Components folder under Scenes and save. Then attach a script and save that as Collectible Component script and create. In the script, we want to call this class name Collectible Component. And because we may use this on multiple different objects, let's export a variable called collectible name and we'll use a type of string. Then select the collectible component node, choose node, and then select body entered. Let's connect that signal to our script. In the onBodyEntered method, we want to say if body is the player, then we'll print a debug statement. We'll say collected, and then we will get the parent and then free the parent scene. Now the reason why I'm using get parent is because the collectible will be added to another scene. So with the collectible component selected, go to the inspector and let's just check the collision layer. Now let's use edit layer names and we'll put this onto a collectible layer. So just write collectible and then just close that. So collectible is now layer 6, so let's choose that. And we want the collectible to be seen by the player. So let's then look for the mask, which is player, and that's number 2. Let's head back to the log scene and go to components and add the collectible component scene to the log. Then let's add a child node and search for collision shape 2D. For the shape, let's choose the circle shape and let's just make this a little bit smaller. I'll also make this green. And for the collectible component, I will call the collectible name log. So you can write the text log in here. So now that we've created the log scene, let's go back to small tree, go to small tree script, and then get the variable log scene, use preload method, and then load the log scene. Then in the onMaxDamageReach method, we want to load and add that log scene and then queue free. But if we do that straight away here, we'll get an error. So what we need to do is to use call deferred so that we instantiate and add the log scene on the next frame. So call deferred, and then we use add log scene. So say function add log scene, and then say var log instance equals log scene, then instantiate the log scene, and then we'll just cast that as a node 2D. Then we'll say log instance global position and set that to the global position of the tree node, and use get parent, add child, and then the log instance. So this will add the scene to the parent of the tree node. So now that we've finished the small tree script, let's test the scene. So with visible collision shapes on, let's just run the current scene. Let's go to test scene objects, trees, and run the current scene. So 1, 2, 3, and then the log appears. So you can see that the collectible component is attached, and then let's collect that, and then that disappears. So let's stop that. So now that we've finished the small tree scene, using reusable components, I can now make the large tree scene. I'm now going to develop this and speed up the video, so stay tuned and you can see the progress. So now we can test the scene, and we've got the large trees and small trees which are now added to our tile map, and then I can just start to axe the tree and collect the log. Now that brings us to the end of this tutorial on how to create tree scenes with reusable components so that you can apply damage and chop the tree down and then use a collectible to collect the logs. In the next tutorial I will show you how to make the tree shake using a shader when the player axes the tree. I will show you how to create a shader which uses the vertex function which manipulates the vertices of the pixels in the sprite. As you can see from the top, the shake is applied, and then at the bottom the trunk is a little more stationary. When the character approaches the tree and the player uses the axe tool, it will cause the tree to shake. First, head over to the scenes folder and in the test folder, open test scene objects trees. Then in the characters and player folder, just open up the player and click on the player node and just make sure the current tool is set to axe wood. Then go to test scene objects and open up the test scene. And then just start to axe the tree. And as you can see, the tree doesn't shake, and it would be good if every time the axe makes contact with the tree, we make the tree shake. So let me just show you how to do that. Go to Scenes, Objects and Trees folder and open up the small tree scene. Click on the small tree sprite here and then just scroll down to Material. And in the material, let's create a new material, and we want a new shader material. Then in the shader property, click empty here and then select new shader, and we'll use the type of shader here. Keep it on canvas item and then rename the shader to tree shake and then create that. Now double click the tree shake shader in the files and then just choose shader editor here, and you can see that in our shader we have a vertex function and the fragment function. We're going to modify the vertex function so that we shake the pixels from the top of the sprite moving down towards the bottom, and this will be better to produce a visual effect rather than using an animation, as we can manipulate the pixels in the sprite. In the shader code, let's remove these two functions. We are only going to use the vertex function because we are going to manipulate the vertex of each pixel starting from the top and then going to the bottom, which will create the shade effect. So let's start by creating a uniform float, shake intensity variable, and we'll set this to 1.0. Then another uniform float, shake speed, and set this to a default value of 20. So add the semicolons, and then we'll create a vector2, shake equals vector2, and then a default value of 0, and then just finish that statement. Then open an if statement and say vertex.y is less than 0, 0. So the reason why we're checking if vertex y is less than 0 is because if you look at the y-axis here for the sprite is sitting above the x-axis, and as we move up the y-axis, the values are negative for the y-axis in Godot. So we want to check if these pixels are less than 0, so we can apply shaking from the top down. So let's call the shake property, say .x equals, and then use the sine function, then time multiply by shake speed plus the vertex.y multiplied by shake intensity. Then let's apply the shake property to our vertex and then say plus equals shake. Now that the shader is complete, we can see that the tree is shaking from the top down. If you set the shake intensity to 0, you will see that it stops. So let's just go back to our small tree, and these two uniform parameters are our shader parameters here. So if we just apply that there and then just say 1, you can see that it's possible to modify the animation and the shaking effect from the script, which is what we will do next. So let's modify the material in our script. Let's first just reset the shake intensity property back to its default of 0, 0. And then in small tree, click the script. And in the onHurt method, once we've applied the damage, we can access the material property, which is this here. Use the function setShaderParameter, and then from the shader, access the shake intensity parameter, and we'll set this to 0.5. Then let's use a timer, so use an await. Then use getTree, create a temporary timer on there, a timeout of 1 second. Then we can get the material, set shader parameter again, and set the shake intensity back to 0, 0. So before we test the scene, just go to player, make sure player current tool is set to axe wood, but also on the tree, the hurt component is waiting to receive the axe wood tool. So just set this to axe wood as well. This can maybe reset in the test scenes. In a future tutorial, we will be creating a toolbar which allows the player to select which tool the character will have so that this is automatically selected. With that set, go to test scene object trees, and then let's test our scene. And then for the small tree, let's just axe the tree. And as you can see, the shaking effect is being applied per second. Now all the trees are currently shaking at the moment, so we can stop that. Let's just cancel that. Then go to small tree and back to the shader. And on the shader, for the resource, select local to scene and then save that. And then let's test the scene again. So let's hit the tree, and only the single tree is now shaking. We'll just do this one more time and then just stop that. I am now going to perform these changes for the large tree and apply the shaker. Now let's go to the test scene and let's test our scene. As you can see, the large tree now has the same shaking effect. So we can then just stop that window. I will just quickly explain some of the changes I've made. So I've copied the code for onHurt as I have in my small tree. And if you look at the large tree, what I've done is I've moved the sprite so that only a couple of pixels are below the x-axis. And this is because in the shader, we want to check if the vertex x is less than 0. So basically, all of these pixels will move above the x-axis, and I want these to be stationary, and it will stop the trunk from shaking left to right so that we just get a better effect from the top down. Then on the shader, I've remembered to click local to scene for the shader that's applied to the large tree, and then just check the hurt component is also set to axe wood. And that brings us to the end of this tutorial on how to use a shader and apply a shaking effect to pixels using the vertex function. I will show you how to create rocks you can mine and then add them to your tilemap scene collection for easy use in any scene. We will also cover hit and hurt components to apply damage when using the axe tool and create reusable collectible components to gather the stones. So before we create the rock scene, let's create a new test scene. So scenes, test scene, and then make a copy of the objects and trees scene. Just duplicate that, and we'll then call it object rocks, and then just click duplicate. Let's open the scene and then F2 on here, and we'll call it objects rocks. I'll just save that scene. Just go back to the test scene objects trees, just rename that and just save. Okay, let's close the test scene objects trees and just keep this one open, and we'll just remove this layer here. So just right click and then delete the layer. So we've now got a test scene ready for trying and testing our rock scenes out. So just click save all scenes. So let's just go to the trees folder and then let's just load the small tree scene. So we're going to create a rock scene which is going to be very similar to this, as we've made these reusable components. So please check out my previous tutorial on how to create the trees and how to chop the trees. Let's go to scene, new scene, other node, and then search for Sprite 2D. Then F2 and name this to rock. In the objects folder, let's create a new folder and we'll call this rocks. And then let's save our scene. And we'll just save that into our objects folder under rocks. So save. With the rock scene selected, in the texture property, let's create a new atlas texture and then open that. And in the atlas property, go to the assets folder and in game and objects, let's drag over the basic grass and biome things. Let's just scroll in, and what we want is this rock here, and this will be the stone which is generated once the rock is mined. So let's go to edit region. And with grid snap selected, let's just draw a grid around this rock and click close. And as you can see now, we have our rock here. So let's just move this a little bit up. Then on rock, add a new child node and search for a static body 2D. And then add another child node and search for collision shape 2D. For the shape, let's then pick the circle shape and then reduce the size. Then click on static body 2D and just check that the collision layer is on 1 for ground and the mask is also on 1 for ground. Now let's go to our components folder under scenes and then drag the hurt component onto the rock, and the tool which the hurt component receives will also be the axe. Then add another collision shape. So search for collision shape 2D and then create that collision shape. But for this shape, we'll just change the colour and make that a bit different. And for the shape, let's add a circle shape. So let's just make this a little bit larger. So the first collision shape is to stop the player from walking through the rock. And then the second collision shape is to receive the axe input. So just click the hurt component one more time. And then on the collision layer, we've already got the correct values set. So 5 is object and the mask is the tool, and this is because we have created it as a component with those values automatically set. So this saves us time and makes it a little bit more reusable. So the next thing is let's take another custom component and we want to use the damage component and drag that onto the rock. Then we will set the maximum damage to 5. This means that the axe will need to hit the rock 5 times before it will start to mine and create the stones. The final step will be to add a script to the rock itself, so attach the script. And we'll save this rock script in objects and rocks and just create that file. And we can actually just copy the code from small tree. So let's just highlight all of the code from the small tree script, go to the rock script, and then just copy and paste that. However, in the onHurt, we will take off the shake intensity and the timeout. Then in the on max damage reach, we need to just modify these variables here. So we'll take this print statement off as well. And instead of log scene, we will add a stone scene. And then let's just change this to be stone. And here it will be rocks. So we can see that this stone scene doesn't exist. So let's now create that scene. Let's go to scene, new scene, other node, and search for Sprite 2D. And then let's name this as stone and then save the scene in our scenes, objects, and rocks folder. Let's save that scene. And in the texture property, let's just create a new atlas texture and then open that resource. And in the atlas property, let's go to the objects folder in assets and game and just drag over the basic grass and biome things asset and just drop that into there. Then click edit region, and with grid snap selected, let's just zoom in and choose our stone. Now there's an alternative way to select assets because this one is slightly off-centered. So you can actually choose auto slice. And as you can see, the stone has been auto sliced and you can just select it so that it turns white. Once that's selected, click close and then go to the 2D view. And as you can see, we've now got our stone here. And when the player mines the rock, the stones will be created from the rock. So we need to make this stone collectible. In the previous tutorial, when we created our trees, I showed you how to create the collectible component. So go into components here and then choose collectible component and just drop this on to your stone scene. Now we can then attach a collision shape. In the shape property, let's change this to be a circle shape and we'll just reduce the size so that it fits around the sprite. And then let's just change the color to be green. Then click on the collectible component and for collectible name, just add the string stone. And if we just view the collision layer, we've already predefined this from inside of the collectible component scene. So just close that. And the reason why we are adding stone to the collectible name is because in a future tutorial, I'm going to show you how to collect objects such as the stones and the logs and then add them into your inventory. So by reusing this collectible component and then giving each collectible a different collectible name, this will enable us to create efficient code and reusability so that later the inventory panel will be easier to create. And then any objects that you wish to be collectibles will be much faster to create for your game and will be all consistent too. Now head back over to the rock scene and then just go into the rock script and we can see now that the log scene has been resolved here. But what we just need to do is update this to be stone scene. Then let's just modify our code here so that it's consistent with the stone. So now we use stone instance and we still set the global position and that's the same. And then put stone instance to add that as a child. So now let's go back to test scene objects and rocks. Let's create a new layer here. So say add child node and then search for tile map layer. Press F2 to rename the layer to rocks. Go to 2D and then on the rocks tile map layer, with the tile set, let's just use quick load and then load the game tile set. And in tile set menu here, let's just click scene collection and let's add our rock scene. So go scene, objects, rocks, and choose rock scene. And this should add it here into our collection. Then head over to tile map and then choose the rock object here. And let's just paint a couple of rocks. And now we are ready to test the scene. So let's just go back to test scene, objects and rocks, and then let's run the current scene. And then we'll say 1, 2, 3, 4, and 5. And then that produces the stone and we can then collect that stone. We can do this one more time. 2, 3, 4, and 5, and then collect that stone. So now we can close the window. In a previous tutorial in the series, I've shown how to create a shaking effect using a shader. I'm going to use the same effect on this rock, but change some of the parameters. So first, let's go to the shader, and this is in our trees folder. Let's just rename this shader and just call it shake. Then let's just move the shader. So click move and duplicate to, and then just move it into the objects folder because we'll share it between the rocks and the trees. So just move that. Then just turn off the two collision shapes so that we can see the rock, and then scroll down to material and let's create a new shader material and drag the shader into the shader property. Then in our shake intensity, let's just increase this to 0.3, and as the axe hits the rock, we'll just shake the rock slightly. So let's just reset that back to 0. And then just unhide the collision shapes. Now that we've applied the shader, we just need to remodify our onHurt component. To go back to small tree, and in the script, let's just copy and paste the code that's in the onHurt method. So copy that, go back to rock, and then just paste that information in. But for the shake intensity, let's reduce this to 0.3. And for the timeout, let's just reduce this to 0.5. Let's head back over to our test scene and then run our test scene. And when we hit the rock, you can see that the rocks are all shaking. So let's just make a couple more modifications. Let's stop the scene, go back to the rock, and then scroll back down to the material and inside the shader. Let's just, for the resource, switch on local to scene, and then head back to test scene, objects and rocks, and then just test the scene again. So we go 1, 2, 3, 4, and 5, and then close that. Now that brings us to the end of this tutorial on how to create rocks for the game which can be mined and produce stones. We have reused some of the components which we have created in previous tutorials in this series. I will show you how to configure wire sorting for tile map layers and other game assets. You will then be able to make the player and NPCs move in front of and behind those assets in your top-down game. So in previous tutorials we have created rocks, trees and tiles in our tile sets so that we can then add them to our tile map layers. To allow our player to move in front and behind the different assets in our scenes collection and tile sets, we need to configure wire sorting. Let's begin by going to our scenes folder and then the test folder, and let's make a copy of our test scene objects rock. So right click that and click duplicate, and then name the scene test scene tile map layer Y sort. Let's open that scene and we can just close this previous one here. I'm just going to rename the scene at the top and call that test scene tile map layer Y sort. Then for the rocks tile map layer, just right click this and we'll just delete that. Okay, then right click game tile map, add a child node and just search for tile map layer. I'm then just going to rename this to objects, and in the tile set property just quickly load our game tile set, and with tile map selected start to paint some of our new objects. So we've got small tree, large tree and our rock here. Let's now test the scene. So just run test scene, and as you can see the player can move over the tree, so let's just stop that. So now click on the player node and open this scene, and on the player character node at the top just scroll down and turn on Y sort. Save the scene and then go back to our test scene, and then on the object layer, this is the layer which we want to affect with Y sorting so that the player goes behind the tree. So then go down, find Y sort and just enable that. Then test the scene. So as you can see it still goes over, so I'll explain why. So when you have an object with Y sorting, the parent must also be Y sorted. So click game tile map and choose Y sort. Then test the scene again. And then close that. And because the player is Y sorted and the game tile map is Y sorted, then the root must also be Y sorted. So just click on the root node and then choose Y sort enabled. Now let's test the scene again. And as you can see now, the player goes behind the tree. So we'll test that with our large tree. And we can see that with our rock. Let's just close that scene. So now that we have Y sorted our objects here, we can always add them to this layer. If we just go back to the tile set and then click basic grass biome things, we can start to configure Y sort within a tile set itself. However, we have different tiles in here which could be considered Y sorted and other ones which we don't need to Y sort because the player can just walk over them. So things like small plants and foliage doesn't need to be Y sorted. So on the game tile map, let's just add another child node, choose tile map layer and rename this to undergrowth. And we'll just position this above grass. Then with the undergrowth tile map node selected in tile set, choose quick load and then game tile set. For this tile map layer, we don't need Y sort enabled, but inside our tile map, we need to decide which tiles we're going to use as undergrowth so the player can walk over anything that's on the undergrowth layer. So let's choose these following tiles. So we have this one and this one here, these small flowers, and then these 4 at the bottom are going to be in the water and the player will not be able to access the water. This small mushroom, and that should be everything for now. Once you've done that, let's just test the scene again. And then on game tile map, let's create another child node. Choose tile map layer node and click create and rename this to overgrowth. Then move this above the undergrowth tile map layer node and in tile set, quick load and choose game tile set. And then we'll add the larger sprites which the player can walk behind. So let's choose this one here and this one. And then the mushrooms and the flowers. Then on the overgrowth tile map layer node, let's scroll down and enable Y sort. Now we can test the scene, and if we move the player does go behind the larger sprite. So let's just try this again. We're going to walk in front of the sprite and the player is walking through the sprite. What we need to do is add a bit of a collision shape just around the bottom of the sprite. For this one, I'm not going to add a collision shape because the player could walk through the sunflower as it's a lot thinner. And for the small flowers and mushrooms, there will also be no collision shapes because the player can walk through them as they're still considered smaller. So just stop that. So back on the overgrowth tile map layer, let's now add a collision shape to our tree. Click the tile set. And we need to add a physics layer to our tile set, so just click add element here and leave it on the collision layer ground here and the collision mask also on ground. Then choose tile set and in the paint property let's just select our physics layer and then just click on the tile to paint it, and then what we'll do, we'll just move these markers here. So just let's click on half pixel snap. And you can zoom in, just hold control and zoom in, and we will start to move our markers. Let's just zoom in and then just move this up. And then once you've made the adjustments here, click on here to paint it. Let's go to debug, turn visible collision shapes on, and then let's test the scene. So as you can see the small collision shape here, and then when we use the player cannot go through the tree, but can go behind the tree. Now, if we just move the player up slowly, you can see that the tree only goes over the player, or the player only just goes behind the tree quite late. So what we need to do is to move the Y sort positioning. Let's just close this window. So back on the tile set, if we then go to select, go to rendering, and for this rendering, just click in the Y sort origin, and you can see that you get a blue marker here. And what we want to do is to just adjust that Y sort origin and move it slightly down. And I'm going to set this to about 8 so that when the player moves further up towards the tree, it should go behind the tree at the right point. So when the player's Y sort position is higher than the tree's Y sort position, it will go behind. So let's test the scene and go to debug, just turn these visible collision shapes back off and then run the test scene here. And then let's just move slowly towards the tree. And as you can see now, the player moves behind the tree at a better point. And that is because we've adjusted the Y sort positioning. Let's stop that. So I'll do the same thing for the sunflower. So just click on sunflower, just move that into view so we can see the blue marker. And I'll also change that Y-sort origin. So say about 8 for that as well. Then just quickly test the scene. And I can walk through the sunflower, but it just goes behind the player at the right point. Just close that. And now I'm going to modify the rest of the tile set, adding some collision shapes to some of the assets and modifying some of the Y-sort positionings. And now let's test the scene. So let's just run the scene again, and then let's just move behind some of our assets. So we can't go through the tree stump, and then the other tree stump, and we can go behind the log and walk up to the log, and then we've got our mushrooms, and then we can that, and with the flower as well. That's looking much better. Let's close this. When configuring Y-sort, it is best to use the test scene and then drop the asset from your tile set and also the scenes collection. As you configure the Y-sort, if you do get any issues, there is a lot less components here to diagnose if anything goes wrong. Also later, when we create the levels, if you find in the levels Y-sort is not working for a particular asset, you can always come back to the test scene and just check if it is working there. Now that brings us to the end of this tutorial on how to configure Y-sort for your different assets and scenes in the scenes collection. I will show you how to create a chicken NPC complete with animations and a state machine. For the state machine, there will be 2 states, which is idle and walk. There will be different walk cycles so that there is a little variation in the game between each of the chicken NPC characters. I will also cover how to use a navigation agent 2D with avoidance enabled, and then we will use a navigation region 2D so that your chicken can move within a specified area. In a previous tutorial, I've shown you how to create a tile map and use Y-sort layers. So before we create our chicken NPC, let's just create a duplication of this scene. So let's just click on Test Scene Tile Map Layer Y-sort, and you can find this in the Scenes folder under Test. Let's just right click and duplicate, and we'll call this test scene NPC Chicken, and then just click Duplicate. Then we'll close the Test Scene Tile Map Layer Y-sort and just open up the Test Scene NPC Chicken, and then F2, and we'll rename this as Test Scene NPC Chicken, and just save the scene. Now we've still got some remnants of our last test scene, however we want to keep these same tile map layers. So click on Undergrowth, go to Tile Map, click the Erase tool, and then choose the square, and then just click to remove those previous tiles. Click Overgrowth, and then just click and drag to remove those tiles, and then the last one is Objects, and just remove those trees. And then we can save the scene again. Now we are ready to create our non-playable character, Chicken, and create a new scene. So click Scene, New Scene, and then choose Other Node, and then search for Character Body 2D. Press F2 to rename, and call this Chicken. Then go to the Scenes and Characters, and create a new folder, and call this Chicken. Then let's save our scene. Click on Scenes, go to Characters, and in Chicken, just save the chicken scene here. So we've now got the chicken scene here, and we'll start to add our collision shape, animations, and state machine. So let's add a child node, and then search for Animated Sprite 2D, and then create that node. Inside of Sprite Frames, let's create a new Sprite Frames, and then just activate that, and then rename this animation from default to idle, and just set that to be default on load. Then click the Add Frames option and go to the Assets folder, and in the game, go to Characters and then choose Chicken Sprite. Click Open. Let's just zoom in. Just hold Control and mouse wheel to zoom, and then let's just say horizontal is 4, but the vertical is 2. then choose the first 2 sprites for our idle animation and click add frames. Then let's just zoom in and press play. Okay, this is now animating, and we'll leave the looping on for this, so just click stop. Then just click back on the animated sprite 2D node and then press the up arrow key to sit the chicken feet on the x-axis. So this is now just sat on the x-axis at 0. Then go chicken, add child node, and then choose collision shape. And in the shape option, choose the circle shape. And then let's just reduce the size of that and just move that up. Let's save the scene. Then click back on animated sprite 2D. And then let's add a new animation. Let's just double click that and rename this to walk. Click add sprite frames and then choose chicken sprite again. Open, let's zoom in and then choose these 4 sprite frames here and add 4 frames. We'll leave it on looping again and then let's just play that. Okay, let's start. In a previous tutorial, I have shown how to use a state machine for a player character. I will show you how to use a state machine for our NPC. So just click on chicken, add child, and then just choose node and create that. F2 and we'll rename this to state machine. Then let's go to our scripts folder, and in the state machine folder, let's just click and drag the node state machine script onto the state machine node. Then click on the state machine node and use add child node, choose node again, and we'll rename this node to idle, and then choose attach script. We will call this idle state, and we'll save this in the characters and chicken folder, so just create that. Then in the scripts folder and state machine folder, just open the node state script, use Ctrl A to select all and then copy this code, and go back to the idle script and we'll just paste that in. Copy node state and then replace this on the extends node and then just delete that class and then just remove these 2 items here, and this will set up our script to create the idle node state. Now let's use some export variables. So say at export variable character, and then we'll use this character body 2D, and then at export again variable animated sprite 2D, and then animated sprite 2D. Then click on state machine and then just set the initial node state to be idle. So when the game starts, the first state will be our idle state. Then click on idle and let's assign the export variables, and then animated sprite 2D and choose our animated sprite. Now the reason why we are exporting variables is because when we then do the cow NPC, you will be able to reuse these 2 states. So the idle and walk state are the same. And this is where we get to use reusable states, so that when you start to create many NPCs, it becomes faster because you can reuse lots of these nodes and components. So when we then enter the idle state, let's then begin our animation. So we can say animated sprite 2D, play, and then just write idle. And then for on exit, just stop the animation. Now we are ready to start testing our chicken NPC. So just go to scenes, test scenes, and open up the test scene NPC chicken. Then go to the 2D view and let's add our chicken to the scene. So go back to scenes and characters and chicken, and then just click and drag the chicken into our scene. Then to run the current scene, just click this button here, and we can now see that the chicken is on the scene and is currently in the idle state. Let's just stop the scene. And to confirm that our chicken is in the idle state, let's go back to our state machine script, load node state machine, and then in the physics process function, re-enable the print statement here, so that when the state machine is running, we print this state to our output console. Once that is done, just let's go back to our view and then run the current scene again. And as you can see, the current state doesn't have an output here. And this is because I've not set the current state node name as it's been initialized. So I'm just going to close the window, go back to the node state machine script, and copy this line here on line 48 and just paste that line on line 19. So when we set the current node state I also get the current node state name, and that is on the initialize of ready. Let's just test the scene again. And as you can see, it's got the correct state here. So we can now debug the state transitions. I'm just going to close the window. And in the test scene, I've put the chicken under the game tile map. So I'm just going to move that back out of there and put that under the test scene root node. That will just fix that. And then head back over to the chicken scene. And let's begin creating a transition to our walk state. So click on state machine, add child node, choose node, click create, and then F2 and call this walk. Let's right click and then attach a new script. And we'll save this as walk state. And we'll save this in characters and the chicken folder. Click create, open up the node state script again, and let's copy the code, go back to the walk state script and paste that in. We'll copy node state and change the node part here, remove the class name. So we extend the node state script and then just remove these two items at the top. And this will just set up the state script. Now to transition from idle to walk, let's just go to our idle script, and we need to modify our onNext transitions method here. However, we will leave the chicken idling for a time interval. Then when the time interval has elapsed, we will move from idle to the walk state. So in our idle state script, create an onReady variable, and we'll call this idle state timer. Use the timer, and then let's create a new instance of our timer, which you can do that by just saying timer.new, and create a new export variable called idle state time interval, which is of type float, and we'll set this to a default value of 5 seconds. The next step is to override the ready function and get the idle state timer, and then for the wait time parameter, just assign our idle state time interval. Then we need to create the timeout connection. So we'll say idle state timer dot timeout, and then connect that timeout signal. And we'll say on idle state timeout, and then create that function, return a void, and for now just write pass. And then because we've created the timer inside of our script, we need to make sure that we add this node to our scene. So we can do that by just saying add child and just pass in the idle state timer. Now create another variable, so we say var idle state timeout, which is a boolean, and we'll just set this to a default value of false. Then in the onIdle state timeout method, we can just set this value to true once the timeout interval has been reached. Then in our onNext transitions, we say if idle state timeout is true, then transition, emit, and transition to the walk state. Then in the onEnter method, the idle state timeout equals false. So every time we go into our idle state, we always reset the timer and then start the timer again. And when we exit the idle state, we can just say idle state timer, and then we'll stop the timer. Then on the chicken scene, let's go to our walk script, and we'll do some more export variables here. So we can copy and paste the two export variables for the character and the animated sprite 2D. So let's just copy and paste those in. Then click the walk node, and in the inspector, let's just assign chicken for the character and then the animated sprite 2D as well. And in onEnter, let's say animated sprite 2D, play, and then set the walk animation. And then when we exit the walk state, we just want to turn off the animation. Now let's head over to our test scene NPC chicken, and let's just test the scene. And as you can see in the output window, we've got current state idle, and we're going to wait until the chicken goes into the walk state. We can now see that current state is walk, but we're also picking up the debug message for our player, which is currently in the idle state. So let's head over to the state machine script, go back to chicken, and then go to our state machine script. And at the top of the node state machine script, let's add another variable or parent node name, which is a type of string. Then at the top of the ready function, say parent node name equals getParent.name. Then copy the parent node name variable, and inside the print statement, just paste this as the first parameter, comma, and then add a space. We can now clear the output log using this button here, and then let's test the scene once again. So we've currently got now player current state is idle, which is this node here, and then we've got chicken current state walk. So we now know that our chicken has transitioned from idle state to our walk state. Let's just close the window. Now back in our chicken and walk state script, we need to complete the ability for the chicken to walk between two different points in our game. So to achieve this, we're going to use a navigation region 2D. So back on test scene NPC chicken, let's add a child node, search for node 2D, and then rename this to chickens. And inside of here, just add another child node and search for navigation region 2D. Then in our view, in navigation region 2D, we have a property called navigation polygon. So just create a new navigation polygon and then start to draw a polygon shape. Once we've created the polygon shape, click Bake Navigation Polygon. This will then set up a region which will allow the chicken to move within. Then I'm just going to click and drag the chicken and pop that under chickens, and then go back to the chicken scene, right click chicken, add child node, and then add a navigation agent 2D as a child, so just create that. And we'll just move that above the state machine node. Then back on the NPC chicken test scene, click on navigation region 2D, click on the navigation polygon, and then for navigation layers, let's just edit layer names. For layer 1, we'll call this chicken navigation. Then head back to the chicken scene, and then just hover over navigation layer 1, and you can see that it's already set to the chicken navigation. Head to the chicken and go to navigation agent 2D and leave this already on 1, which is chicken navigation. And what we're saying is that the chicken is associated with the navigation layer, which is the chicken navigation. Now let's head back over to the walk state script, and let's begin by creating the ready function. So override ready, and then let's also create a character setup function. So say function character setup and return void. Then inside the character setup, we want to do an await, get tree, and await for the first physics frame. Now when we use navigation region, the navigation agent needs to wait after the first physics frame and then starts to process the next target. So we're going to create another function and call this set movement target, which will also return a void. Then back in the character setup, let's call set movement target. Then in the ready method, use call deferred, and we will call the character setup method. Call deferred is a useful method to allow you to call other functions after the current frame has finished processing. So call deferred will call character setup during idle time. Then, when character setup is called, we will wait until after the first physics frame. This will allow for a smoother setup of our navigation agent before we start to move between different targets. So at the top of the script, let's add another export variable, which is navigation agent 2D, and the type is navigation agent 2D. Then in the set movement target function, we will say var target position, which is of type vector2, equals navigation server 2D dot map get random point function, passing navigation agent 2D dot get navigation map. And the second parameter is navigation agent 2D dot navigation layers, and the third parameter is false. On the next line, let's say navigation agent 2D dot target position, equals our current target position. Then at the top of the script, add a new variable called speed with a type of float. Then export two new variables, and we need a minimum speed, which is a type of float, and we'll default this to 5. Then a maximum speed, which will also default to 10. Then back in the set movement target function, we can say speed equals, and then use the rand f range function and pass in the minimum speed, the maximum speed, and what this will do is it will set the default speed value, and it will choose a speed between 5 and 10, so that each chicken that we add to the scene will all get a different speed, and this will allow for some variation with each of the characters. Now in the onPhysics process method, let's write the code which actually moves the chicken character. So let's start with for target position, which is a type of vector2, equals the navigation agent 2D variable dot get next path position. Then say var target direction, which is also a type of vector2, equals our export variable character dot global position, and then direction to the target position. So this will get the facing direction that our character is facing towards. The next step is to get our animated sprite 2D and then use dot flip h equals the target direction dot x, which is the axis value, and if this is less than 0, then we want to flip the chicken. Then say character dot velocity equals our target direction multiplied by speed, then character dot move and slide to process the movement of our character. Now we are not using delta in our calculation because the character will use the delta time inside of the move and slide. So all we need to do is to calculate the target direction by speed and assign that to velocity. Internally, delta will be calculated for us. Then click on the walk state, and for navigation agent 2D, let's just assign our navigation agent 2D and click OK. Now we are ready to test the chicken, so click on test scene NPC chicken and then run our test scene. So the chicken is currently in idle, and now the chicken is starting to walk. But what we'll do is we'll enable some debugging so that we can see the line that the chicken is walking along. So in the chicken scene, click on navigation agent 2D, scroll down in the inspector until you see debug, and then just click enabled. Let's head back to the test scene and run again. And as you can see, we now have a debug line and the chicken is walking along. However, as you can see, there's a thick staircase effect, and this is making the chicken bounce quite a lot up and down. So let's just stop that. There is a way to make that line much more sharper. And what we can do, we can go to project settings, then go to window under display, scroll down, and for stretch mode, change this to canvas items, and for aspect mode, change this to keep. Then scroll down further, and in rendering, choose 2D, and in snap, turn on snap 2D transforms to pixels, and click close, and then test the scene again. As you can see, the line is much thinner and is reducing that staircase effect. Let's close the window. So I'll just run the scene one more time. So using canvas items in conjunction with a navigation agent 2D can help reduce or eliminate the staircase effect due to the fact that it does have improved interpolation features, so the movement can be smoothed out between the waypoints. The agent's movement can be interpolated to create smoother curves and transitions between those path points, and it just results in a more fluid motion, and that just reduces the staircase effect. Now, as you can see, the chicken, once it reaches the last waypoint, we need to generate a new waypoint. So let's do that. So head back to the chicken scene, click on the walk state script, and in the onPhysics process, we just want to check if the navigation agent 2D has finished moving. So we'll say if navigation agent 2D dot is navigation finished, then call set movement target again, and then return from the function. Now let's test the scene again. So just choose test scene, NPC chicken again, and then just run that test scene. So the chicken is now going to move to the first waypoint. Then the navigation finished and generated another waypoint. As the chicken approaches the second waypoint, a third one will also be created. But as you can see, the chicken keeps on walking and we are not going back to the idle state. So let's just solve that. Let's close the window. So go back to chicken and then the walk state script. And in our onNext transitions method, let's copy the if statement. So if navigation agent 2D is navigation finished, then set the velocity to 0 and transition to idle. Then let's just test the scene one more time. So the chicken is now walking to our first waypoint. Then the chicken current state is idle and we can see that in the output window. So the chicken again is walking to the second waypoint. It's currently walking and now the chicken is currently in idle. So that is currently working. Our next step is to consider many chickens in our navigation region all at the same time, and how will those agents avoid each other. So if we click on navigation agent 2D, there is a section under avoidance where we can turn this feature on. However, our script will need to be updated so that we do manage our avoidance when it is enabled and when it is not enabled. So first, head over to the test scene, and with the chicken scene, let's just right click and duplicate this scene. Let's just go to our 2D view and let's just move our chicken into a new position. Let's just duplicate our chicken again, and then let's move the chicken again, and let's just put a fourth one on there. Okay, now let's run and test the scene. And let's just wait for them to begin moving. Now, as you can see, this cluster of chickens here are all colliding with each other and they are not really performing any avoidance. So let's just stop the scene and let's just modify the script and then enable our avoidance. So back on our chicken scene and then on the walk state script, and in the ready method, let's say navigation agent 2D, velocity computed signal, and then connect, and we will create a function called onSafe velocity computed. So underneath the function onPhysicsProcess, create a function called onSafe velocity computed with a parameter called safe velocity, which is a type of vector2 and will return void. Then back in the onPhysicsProcess method, after animated sprite 2D.flip, let's just return here and create a variable velocity, which is a vector2, equals, and then just copy this code here. Then say if navigation agent 2D dot avoidance enabled, then say navigation agent 2D dot velocity equals our velocity variable here above. Else, assign velocity to our character's velocity. So just replace that bit of code here. Then just tab the character.move slide. So if the avoidance is enabled, we then set velocity to navigation agent 2D, and this will then cause the onSafe velocity computed signal to be called, and this function will be called here. So if we do enable the avoidance, then what we want to do is to assign velocity to safe velocity, which is calculated for us. And then in here, we will call character.move and slide. So if the avoidance is disabled, we just assign the velocity as normal, and then we also perform move and slide. So now that the script is complete, let's go back to our test scene and then run our test scene. So as you can see, the agents here have just tried to avoid each other. And again, you can see them avoiding here. And we can see the agents also avoiding again here too. Now, as you can see, the distance between the agents is possibly too large. So let's just close the scene, go back onto the chicken scene and on Navigation Agent 2D. And if we just look at the sprite here, we could probably reduce the radius to about 5. So back on Navigation Agent 2D, let's just reduce the radius to 5 and then let's test the scene again. So as we can see, the agents are avoiding each other, yet the distance is much better for the avoidance. Now to finish off our walk state script, let's introduce some walk cycles. We can auto-generate some walk cycles so that some chickens only move for 2 walk cycles then go to idle, and other chickens may move 3 or 4 or maybe 5 walk cycles and then go back to idle. It will just introduce some more randomization for the chickens in our game. So head over to our chicken scene, then go to Scenes and Characters folder, and in the root folder create a new script and call this non-playable character. Let's open that script, give the class name as non-playable character and just extend that from character body 2D. Then export a variable called min walk cycle, which is type int, and then export a variable max walk cycle of type int. Then declare another variable called walk cycles, and that is also type int. Now on our chicken scene node here, let's just attach a new script, and in the scenes, characters and chicken folder, let's just save our new chicken script. Just create that. Then on the extends, we will say non-playable character. Now let's hop over back to our non-playable character script, and in the min walk cycle, let's give this a default value of 2, and for the max walk cycle, a default value of 6. And then on the chicken script, let's override our ready function, and we'll say walk cycles equals rand I range, passing min walk cycles and max walk cycle. Now the rand I range function will return a value between 2 and 6. So if we just go back to the non-playable character script, we have set these default values here, and we also need a current walk cycle, which is also a type of int. Now let's head over to our walk state script, and where we export this variable here, let's just change this to be non-playable character, and this will give us access to these variables here. So in the walk state script, we can now go to the onPhysicsProcess method, say character dot current walk cycle plus equals 1. Then in the onNextTransitions method, instead of saying if Navigation Agent 2D is navigation finished, we can say character dot current walk cycle is equal to the character's walk cycles. So if the walk cycles is set to 3, as we go through each walk cycle, once current walk cycle equals 3, it will then go into idle. So let's set a breakpoint here on line 34. Let's set a breakpoint here on line 55. Let's go to our test scene and let's just remove these 3 chickens so that we've only got the 1 chicken in the scene. Now let's just test our scene. As you can see, the chicken is currently in the idle state. Then if we click remote here and choose our chicken scene, we have generated an automatic number for walk cycles, which is 4, and our current walk cycle is 0. So press F12, and we'll just remove the breakpoint here, and we'll just reset it on here. So now the chicken is moving, and the chicken is now hit its navigation is finished. So if we look again in the remote and then click on chicken, the current walk cycle has now been incremented to 1. So let's press F12 again. So the chicken has hit the second walk cycle, and the chicken is moving, and the chicken's hitting the next walk cycle. So we're in current walk cycle 3, and now the chicken is going to hit it again, and we've now got a current walk cycle of 4. So we just F12 that, and we can now see that on the next transition has been called, and we're going to now transition into idle. Just F12 that. So now the chicken is currently in the idle state. But what we need to do is to then reset the character current walk cycle back to 0. So let's just stop that. When we always enter the state let's make sure that our current walk cycle is 0. So in the onEnter method, we'll just say character.currentWalkCycle equals 0 here. Let's go back to our test scene NPC chicken, and then let's just duplicate our chicken. So I'm just going to put many on here for now. And then I'm going to go back to chicken, and on Navigation Agent 2D, I'm just going to turn off the debug for the navigation agent. And then go back to test scene NPC chicken, and then let's run that current test scene. So we've got a couple of chickens in idle here now. And some more in idle again here. And another chicken in idle here. And another one here. So we've created a randomized effect for our chickens. Let's stop the scene. And now for our final improvement for the walk state script, we are using target direction to flip the sprite based on which direction the character is moving in. However, when we use avoidance, when a character is avoiding another character, it may temporarily want to switch direction as it avoids and then switch back because it is going to the waypoint which is intended. So copy this line and then paste the line just under the if statement here, and then copy the velocity parameter and paste it over target direction. Then copy the line again, and in onSafe velocity computed, let's just paste that. And then copy safe velocity and paste it over the velocity parameter. And that will resolve flipping our sprite. Now that brings us to the end of this tutorial on how to create a non-playable character which can move freely using a navigation region and navigation agents. We have also looked at avoidance of other non-playable characters within our navigation region. Our non-playable character is also using a state machine and can move from the idle state into walk states and have walk cycles, which gives the characters just a little bit of variation on how they are moving around in your game. I will show you how to create a cow NPC with animations, a state machine, some states, and a navigation agent 2D so that the cow can move freely within a navigation region. So before we create the test scene for our cow NPC, I advise that you watch the tutorial previously on how we created the chicken NPC. I've gone into detail on how we created the chicken character, the state machine, and the different states. I've also covered how to add a navigation agent 2D and then allow the chicken to move within a navigation region. Now, creating the cow NPC is almost identical, so there will be parts of this video which I will speed up during development. This is because the cow NPC has been designed to be exactly like the chicken NPC. However, there will be some parts that are slightly different, so just stay tuned. What I am highlighting is how you can make reusable components so that it's easy to add new NPCs to your game. So let's begin by going to Scenes and Test and duplicate the chicken NPC scene. So right click and duplicate this scene and we'll call it NPC cow. Then load the scene and then let's just remove these chickens here and we'll rename this scene to be cows. Rename the test scene and just save that. Then on the navigation region 2D, let's just make some slight modifications. Just click Bake Navigation Polygon, and on the navigation layers, go to Edit Layers, and you can see layer 1 is for chicken navigation. So let's add a different layer for our cows. We'll call that cow navigation. And just close that, and then just set this to layer 2. Then go to Scene, New Scene, Other Node, and choose Character Body 2D. Let's rename this to cow, and then save the scene. So go to Scenes, Characters, create a new folder, call this cow, and then save the scene in that folder. I will now speed up some sections of this tutorial because creating the cow NPC is identical to creating the chicken NPC, which I've covered in the previous tutorial. However, there are some sections which will be normal, and I will talk you through those slight changes between the two NPC characters. So for the cow NPC, I have now created an animated sprite 2D, which has two animations, idle and walk. They are the same as the animations in the chicken NPC. This allows me to reuse our states which we created for the state machine. So I've moved the states from the chicken folder into a global NPC states folder. So when I've then created the state machine for the cow, if I then click on the idle state, I can use the same animations. This allows us to then create states and reuse them on other NPCs. Now let's add a navigation agent 2D. So go to add child node and search for navigation agent 2D and click create. Let's just move this above the state machine. And in navigation layers, choose the cow navigation layer. Then scroll down and turn on avoidance enabled. Let's go to the scene, and from the center point, let's just see how many pixels there are. So roughly there's about 10 to 12, so we can leave the radius for now at 10. I am now going to add some cows to my test scene. Now I need to actually update the cow script as we've done for the chicken script. So here we need to add these things here. So let me just copy this code and we'll create a cow script. We'll save that to the cow folder, then copy and paste that information here. And for the idle and walk states, make sure that we assign the correct nodes to those properties. So now the cow is visible. And then before we test the scene again, let me just check that we've assigned initial node state. So let's just set the state machine to first start with the idle state. So just check that all the export variables are now assigned to. And we have the script, so the extends non-playable character. This is why we are able to now assign the cow here. And now we are ready to test the scene again. So as you can see, the cows are now moving between idle and the walk cycles, and we have reused many of the components which we have created for the chicken NPC. I will show you how to create different navigation regions so that you can group different NPCs into different areas. Each of these NPCs have their own navigation agent with different parameters to enable them to have avoidance and to also move across the path and to reach the desired target. So I'll begin by creating a new test scene. So go to Scenes folder, test, and then duplicate test scene NPC chicken. Duplicate that and call it test scene NPC and navigation. Let's open that scene. Let's just rename the node to call that test scene NPC navigation. Just save that. Then I'm going to just remove the camera from the player just so that when we load the test scene, we can just see the full screen viewport. And under the chickens node, I'm just going to remove the navigation region 2D and all the chickens too. So let's now add our fences to our tile map. Let's click objects and then we'll use the game tile set. So click on game tile set so that it opens, and then first let's add a new terrain. Let's add an element and we'll call this fences, and we'll just save that with the default color here. Then click on tile set and go to assets, tile set, and find the fences PNG, and then just drag that into the tile set. So for this we will use all the tiles, so let's just click yes for that, and then we'll just zoom in, and then let's just select the first tile. Click on paint, and then the first thing we want to do is to set the terrain. So we'll say the terrain is set 0 and we want to choose fences. So choose the first option and then we'll start to paint. If the colour is difficult to see, you can always change the colour and make it a little bit easier. So I'll choose something a bit brighter and then I'll just paint these tiles here. So that completes connecting our terrain so that when we then draw the fences, we'll draw the pattern correctly, and we'll test this out on our test scene. So the next step is to paint the collision shapes onto the fence posts so that the NPCs and player can't walk through them. So in the paint properties, choose physics layer 0, which if we look at our tile set, the collision layer is already on ground. So the physics layer will look here, which is our first layer here, and it will choose the ground option for 1. Let's paint the first tile, then choose half pixel snap to allow us to easily set the markers. So we'll just start to pull the markers in. Then once you're happy, just click the tile to paint. Then follow the steps for all of the tiles. Now we can head over to tile map and just look at terrains, and there should be a fences terrain now. What we'll do is let's just zoom in on our tiles and let's just draw our first chicken pen. So I'll just click the line here, and with fences selected, I'll draw a line here, and then I'll just move the player to down here. So let's just view the collision shapes. So just click collision shapes on for debug, and then let's just test the scene. You can then tweak the collision shapes if you wish, but I'm just going to leave it for now. Now under the chickens node, let's add a child node and search for navigation region 2D. Then in navigation polygon, choose new navigation polygon. For navigation layers, choose chicken navigation, which is layer 1. Then open up navigation polygon and start to draw the points for the navigation. And then bake the navigation polygon. Let's test the scene again, but first go to the debug menu, make sure visible collision shapes is on, and also turn on visible navigation. Let's test the scene. As you can see, we've got our navigation region and the fences with collision shapes. However, we would like to subtract the collision shapes from our navigation region. Let's close the window. So in navigation region, with navigation polygon on, make sure the parse collision mask is selected for the first option, which is ground. For parse geometry type, we can leave this as meshes and static colliders. Then for the source geometry here, for this property, choose group explicit and then copy this group name here. Then click on objects, go to node, and we can add this name as a group, and then just turn on global. and click OK. So now this tile map layer belongs to this navigation polygon group. Then go back to navigation region and click Bake Navigation Polygon again. And as you can see, using Group Explicit, we've included those tiles and the polygon has rebaked and subtracted all of the collision shapes. Now let's start adding our chickens back to the scene. So we'll go Scenes, Characters and Chicken folder, and then drag the chicken scene into our game. Then right click and duplicate the chicken. And we'll keep duplicating until we've got many chickens in the scene. Now that we have many chickens in the scene, let's just test the scene again and let's just observe some of the results of the chickens moving around. Now as you can see, some of the chickens are starting to cluster around the edges and they're getting a little bit stuck here and this chicken is stuck here. So let's make some modifications to our Navigation Agent 2D to try and prevent some of this behaviour happening. So let's head over to the chicken scene and choose Navigation Agent 2D. And for the path desired distance, let's just reduce this down to 10. And this is the desired distance that the chicken will move away from the path. For the target desired distance, we can just reset this back to 10. And that is the threshold distance that the target is considered to be reached. So we'll just reduce that as well. Then for path post-processing, instead of corridor funnel, we'll choose edge centered. And for the meantime, we'll just keep the avoidance enabled. Then on the chicken, let's create a new collision layer and we'll call this NPC and just place the chicken on the NPC layer. And for now, we'll leave the mask to the ground. Now let's head over to the test scene and let's just run this again. So now that the NPCs are on their own collision layer, they can now move closer together. Also, the post-processing path is now set to edge centered, which means as the path is being generated with these red debug lines, instead of being on the edge of the navigation region, they're now in the center. So this is helping the NPCs to not stray too far away from the desired path. Therefore, we don't get them clustering on the edges and getting stuck against the fence's collision shape. Now we can create the pen for the cows. So I'll just close the window. So click on Objects, Tile Map and Fences. And add child node, choose Node 2D and rename to cows. Then add another child node, choose Navigation Region 2D and then create a navigation polygon. For the navigation layers, choose Cow Navigation and then draw the polygon. Once that's complete, we can then bake the polygon. And to subtract the collision shapes, go to Source Geometry Mod and then choose Group Explicit and then bake the navigation again. Now let's add our cow scenes. So just go to Scenes, Characters and Cow and then just drag the cow onto the scene. Let's open the cow scene, click on the character and then just scroll down and for collision layer, choose NPC and then turn off that ground layer here. Then click Navigation Agent 2D and just scroll down and turn debug enabled on. Then head over to the test scene and run the test scene. So as you can see, the path that's generated is not edge centered, so we need to just modify that. So back in the cow scene, on Navigation Agent 2D, change path post processing to be edge centered here. Now let's run the test scene once again. And as we can see, we now have edge centered here, which is much better. Let's close that. To go back to chicken, let's just turn off our debug off. Then in cow, for navigation agent, let's turn debug off again. And in debug here, let's just turn off visible collision shapes and visible navigation. And then we can run the test scene. Now that brings us to the end of this tutorial on how to create multiple NPCs and different navigation regions with adjustments to navigation agent settings so that the agents can move freely around those areas. I will show you how to create a Tools panel UI complete with a theme and how to style the different controls. The Tools panel will allow the player to select different tools such as the axe to chop trees, the tilling tool to till farmland, and the watering can to water crops. You can then advance on the Tools panel UI and add your own tools. In the Scenes folder, create a new folder and call this UI. Then go to Scene, New Scene, click User Interface, and then just F2 and call this Tools panel. And let's save the scene into our new UI folder. Then go to the Assets folder and create a new folder in here and call this UI. Now we will download the assets which we will require to create our Tools panel UI. Before we get started, we need to download the Sproutlands UI expansion pack, which can be found on itch.io by Cutnoodle. I will leave the link in the description below. So just click download now and then unzip the file to get the UI assets. Once you have downloaded and unzipped the Sproutlands UI pack, just go into the pack and under Sprite Sheets, just drag the Sprite Sheet for Basic pack into the Assets and UI folder. Then in the Mouse Sprites folder, copy triangle mouse icon 1 and drag that into the UI folder. And in the Dialog UI folder under Emotes folder, just copy the Tmore Basic Emote Animation Sprite Sheet. So we've just copied 3 sprite sheets over into our Assets in UI folder. Now that we have these 3 sprite sheets in our game, let's just format the names so that they are better for our project structure. So F2 the first one and call this Basic UI Sprites. For the next one, we'll just call it Emotes. And for the third one, we'll just call this mouse_icon. Now click on the Tools panel control, scroll down until we get to Theme. So click on New Theme, right click and Save As. And in the Scenes UI folder, let's call this game_UI_theme and just save that. Then click on the theme resource and it will load the theme panel. So now click this plus button here, and usually you would choose your control, which is a default control, and then style it. However, I'm going to show you how to create different styles for the same type of control. So we may have many buttons which will have different styles, and this is the same case for the panels. So in other software frameworks, these are known as style classes or style resources. So first of all, in here, we'll type dark wood panel and then just click add type. And as you can see, there's no control for this. So click this last option here, and in the base type, add and search for panel container. Select that option and then just set that as the base type. So what we are creating here is a dark wood panel style class, which is applied to the type of panel container. Then back in the Tools panel, there is an option called Type Variation. Just click Edit here and type Dark Wood Panel and just click the tick. So this will apply this style class to the Tools panel. And here, this is where we can have different styles for the same type of control and then just apply that type variation to it. So click back on the Tools panel node, right click and then change the type and search for panel container. So just change that type and make sure that it matches the type in our theme. So let's now style the panel. Click this button here to style it and then click empty and then new style box texture and then click the style box texture to load it in the inspector. For texture, click empty again and then choose new Atlas texture and open that. And for the Atlas property, bring over the basic UI sprites and then click edit region. And then for snap mode, click auto slice and zoom in and choose this sprite here. Click close, then just close that option and scroll down and you'll see an option called sub-region. Choose edit region and then from snap mode, choose pixel snap. And then with these black and white bars, just start to bring this in for the frame and you can see it will start to modify the panel in the scene. So bring that down to here and then we'll do it from the right hand side and then also from the bottom. So bring the bars in so that we frame this section here and then click close. And as you can see, we now have our panel styled. So just to quickly recap on the Stylebox texture, choose Atlas texture, and when you open the resource, you have an edit region inside of the Atlas texture resource. That will help you first pick the actual sprite, then collapse the resource, and to do the sub-region is the edit region here. Now to add the tool buttons, let's go to Tools panel, add child node, and search for margin container. This will help just put a margin around the buttons. Then add child node again, search for HBox container, create that. This will lay out the buttons horizontally. And then for the first button, add child node and search for button and just create that. Then click on button, press F2, and then let's rename this to Tool Axe. Then scroll down to custom minimum size and just set the X and Y to 26. So this will just change the size of the button. Then click on Tools panel, and for the anchor preset, choose top left. Let's just zoom in on this. And as you can see, our button now is just fitting inside of the panel. So now let's modify the style for margin container. And because we have the theme assigned to our theme property at the root node, we don't have to assign theme to every single child node. So click on Tools panel to access the theme. And then in the theme, click the plus button here again and search for margin container. And we're going to apply it to all the margin containers without using a style class. So this is the default style. So click add type, then choose this option here, click plus, and then write 10, plus again, and then 10 again, and then 10 for the last option. And now we can style the button. So with the game UI theme open, click the plus button here, and then write tool button, and then click add type. Click this option here at the end, and then the plus button, and then search for button, and then add that as the base type. Then click on Tool Axe button, and we'll scroll down, and under theme, for the type variation, click the edit icon here, and then write tool button for the style type, and then just click the tick box. Let's just go back to theme by clicking on the tools panel, and then click this option here to add the style boxes. So for normal, click the plus button here, and then click on empty, and then choose new style box texture. Click on the resource, and for the texture, click the empty option and choose new Atlas texture. Open up the Atlas texture resource, and then drag the basic UI sprite into the Atlas property. Then we can choose edit region and choose auto slice, and then zoom in here. And we want to choose these buttons here, but we'll choose this one for normal. So zoom in and then click close. Just close the Atlas texture resource and then scroll down to sub-region. Click edit region and then choose pixel snap, and then just start to bring in the bars so that we frame the button. And once we've got this frame here so that we can frame the outside of the button edges, then we'll have this content in the middle. So just click close here once you've finished. Now for the next style, right click, choose copy to copy the normal style. Let's scroll up until we find hover. Click the plus button, then right click on empty and then choose paste. But then right click again and say make unique recursive. Then what we need to do is to make all of these styles unique, otherwise they are shared, which means when we modify it in one place, it will then modify it in the other place. So make these resources unique, click OK, and then click the Stylebox texture again. And as you can see, it's already pre-configured. However, because we've made it unique, the texture resource here is also unique. So let's now just click the Atlas texture here, and let's click edit region again, zoom out and choose auto slice, but then pick this option here for the hover style. So close that and then just close the resource and then click edit sub-region. And as you can see, the sub-region is already created for us, so it saves us from having to create sub-regions again. So just click close there. Now let's test the scene to just see the effect of those two styles. So just run the current scene and then just hover over the button so we can see the style is starting to change. So I'm now going to just head back over to the theme, and then I'm going to copy the style from the hover option and then scroll down until you see press. Click the plus button and right click and choose paste. Then right click again and choose make unique. Then say OK. Then open up the press style. Then for the texture, open up the Atlas texture and then choose edit region. Then zoom out, and with auto size selected still, let's choose this lighter coloured option and then choose close and then just save all scenes. Then we should just be able to run this scene again. So hover, and then when you click the mouse, you can see that it's highlighting, but we now have a bar around it. So this is the focus style, so let's just stop that. So click back on theme, then copy the press style, scroll to focus, just create a new style and right click and paste that style. Then right click again and make unique and click OK. Then let's run the test scene again. So we've got hover, pressed and focused. As you can see, once it's been pressed, it has focus and it keeps that pressed look. Let's close that scene again. So go back to Tools panel and then open the theme again. Let's just copy the focus style. And then for disabled, click a new style, right click, choose paste, then right click, make unique recursive and click OK. Then choose the disabled style and open up the Atlas resource, choose edit region, and for the disabled button, choose this last option, which is the grey coloured option, and then click close. And to test the disabled style for our button, choose the Tool Axe button, and then in filter properties, write disabled, and then for this option, just temporarily switch it on. And as you can see, the disabled style is applied, so we can just revert that, and that just tests the disabled style box texture for us. Now we're ready to apply an icon to the button. So click on Tool Axe button, and in icon, for the texture, choose new Atlas texture, and then just open that. Then go to Assets, Game Folder and Objects, and then drag on basic tools and materials to the Atlas. Then choose Edit Region, and this time choose Grid Snap, and then just drag the grid over the Axe tool and then just click Close. And this completes the Axe button. So right click and duplicate the Axe button, then F2, and we'll call this Tool Tilling. And now we've duplicated the button. But what we do need is a new icon. So right click on the icon Atlas texture and then say make unique recursive. Click OK. Then open the resource. Go back to edit region and this time drag the grid over the tilling tool and then click close. So I'm going to modify the margin container that's around these buttons. Now if I look at the style, I have the default style set to 10. So I'm actually going to leave that as it is. What I'd like to do is override this on just this control here. So I'm just going to click margin container and then scroll down, go to theme overrides, and we can override the margin values here. So let's turn these all on and then set a value of 4 for each of the options. And as you can see, that margin is much better. Now let's add the next tool. So right click Tool Tilling, duplicate it, F2 to rename and call this watering can. Right click the icon resource and say make unique recursive. Open the resource, edit region, and then choose the watering can option. Right click the tool watering can button and then duplicate that again. F2 and call this tool corn. But for the icon, let's just create a new Atlas texture. Open that. And in the Assets Game Objects folder, bring over the basic plants and just put that into the Atlas. Then click Edit Region, use Grid Snap for the snap mode, and then choose this seed bag here. Close. Then duplicate the Tool Corn button again, F2, and call this Tool Tomato. Then right click the resource for the icon, and we can just make this unique and recursive. Open that, edit region, and then just choose the tomato seeds and click close here, and then we can save all the scenes. And as you can see, the icons, some of them are just off center. So starting at the top with tool X, scroll down until you get icon behavior, and for icon alignment, choose center for each of the tool buttons. Then finally, for the tomato icon, I'll just choose center for that too. So now that we've created the Tools panel UI, let's create a game screen which will overlay the game. So go back to our UI folder, let's go Scene, New Scene, and choose Other Node, and search for Canvas Layer, and create that. And rename this and call it Game Screen. Then save the scene, and go to Scenes folder, UI, and save it as the game screen. Then drag the Tools panel into the game screen. Then click on Game Screen and add a child node and search for Margin Container. Then nest the Tools panel inside of the margin container. Then click on Margin Container and scroll down. And for the theme, just click and choose Quick Load, and then select Game UI Theme. And as you can see, it's automatically added that 10 pixel margin from our theme. So that's correct. Then for the anchor preset, choose Full Rect. And now let's position the Tools panel inside of the margin container. So click on Tools panel and choose Shrink Center, and then Vertical Alignment, Shrink End. And that will position the tools in the bottom of our game screen. Our next step is to create a test UI. So we'll go to Scenes and Test, and let's just create another test scene, which we'll then overlay the game screen onto, and we can start to test the UI. So I'll click on Test Scene Player, and then just duplicate this test scene, and we'll call this test scene Game Screen UI, and just duplicate that. Let's open the test scene game screen UI, then go to Scenes and UI folder, and then just drag the game screen onto our test scene. And as you can see, the tools are now overlaid onto our game. So now that our game screen is ready, let's go to Tools panel and let's connect the buttons up so that we can use the axe tool for the player, then the player can use the tilling tool, watering, and then plant the seeds. So in Tools panel, right click Tools panel and then attach a script. And we'll save our script in the Scenes UI folder. So click Create here. Then click and highlight all of the tool buttons, and holding Control, click and drag them into our script. This will then create us 5 onReady variables. So we'll have the Tool Axe button, Tool Tilling button, the Watering Can, Corn and Tomato button as well. And now let's link up the pressed events from each of the buttons. So click on Tool Axe, go to Node, and then click Press, click Connect, and then click Connect here, and it will add as a signal connection to the pressed action. So when the player presses the Tool Axe button, we want to then set that tool on our player. And to do this, we'll need a global script. So go to the Scripts folder, and in Globals, let's right click and create a new script. Call this Tool Manager, and then click Create, and open the Tool Manager script. Then head over to Project Settings, and in Globals, click the Open folder and open the Tool Manager, and then click Add. Leave this as enabled, and then just click Close. So now that we've added the Tool Manager as a global script, this will act as a singleton which will appear for our game scenes, and then we can access this from anywhere. Let's just start to add some parameters. So we'll say var selected tool, which is a type datatypes.tool, and then we'll assign it the non-variable as a default. Then let's create a signal, and we'll call this tool selected, and we'll pass in the data types tools. So in a previous tutorial, I've shown you how to create this enum type, and we've created some values in our enum, which is none, then it's for axing the wood, tilling the ground, watering crops, planting corn, and planting tomatoes. Then back on our tool manager script, let's create another function and we'll just call this select tool. We'll pass in the tool and we'll return void. And then what we need to do is just call the signal and emit the selected tool, and then just set selected tool to be the tool which is passed into the select tool function. So now our tools manager script is complete. Let's just head over to tools panel script. Then let's get hold of the tool manager, then choose the select tool function. Then from our enum, we can just say tools and then pass in the axwood parameter. So when we select this tool, let's now assign that tool to the player. Let's just go to our characters folder under scenes, go to the player folder and open the player scene. Open the player script, and as you can see, we have a current tool which uses the data types enum. Let's override the ready function and then say tool manager dot tool selected. So this is the signal, and then connect our signal and then just say on tool selected. Then let's create that function. So we can just copy this and then just say tool data types dot tools and then return void. Then set current tool, the tool that is being passed into our method. And then let's also set the current tool on our hit component. So click the hit component, hold Control down and drag that into the script. Then copy hit component and just say hit component dot current tool equals tool. Then on the hit component, let's just reset our current tool so that it's always none to begin with. Let's go back to tools panel, and in the script, let's just connect the tool tilling. So go to node, press, click connect, and then click connect here. Let's copy our code from the previous tool axpress method and just paste that here. And then for tools.axwood, change that to be till ground. Then go back to player, choose the player node, and then just reset the current tool here also to be none. Now before we test the scene, let's just print a debug statement. So we'll say tool and then pass the tool value in. So we'll get an integer for the tool. So for our axe, it'll be number 1, and for till ground, it'll be number 2. Now let's head over to our test scene game UI, and then let's just run that scene. Let's just face right and then click the axe tool. And then when we click it, the axe animation is present. And then let's just check the output. So this is tool 1. Let's just choose the next tool. So it's now switched to tool 2. And let's just click, and we can see that we have the tilling animation. So we've now successfully linked up these two buttons. I'm now just going to clean up that debug script from here. And then back on the tools panel, I'm just going to link up the other buttons here. So now I've completed adding the other pressed signals and then updated the tool manager select tool to pass in the correct data type tool. So now that we've added all of the extra pressed events, let's go to the test scene and let's just run this again. Let's choose the axe. That's the axe animation, tilling. Now there's no way to unselect the tool, so let's just pop in some code which will allow us to deselect the tool so we go back to the non-state. Go ahead to tools panel and then the tools panel script, and then add a new action to the input map. So we'll go to project settings, and in input map for add new action, we'll call this release tool and just add that. Then click the plus button here and then just press the right mouse button down and then click OK and close that. Then back in the tools panel script, let's override the unhandled input event and then say if event.isActionPressed release tool, then get the tool manager, select tool, and then pass in data types .tools.none to release the tool. Then call tool axe.release focus. And then we'll do that for the rest of the buttons. This will allow us to release the button focus when we've clicked the right mouse button. So let's just add a breakpoint here And then let's run the test scene, choose the axe tool, and then click the left mouse button to perform the action. And then we want to release the tool. So just click the right mouse button, and that is now hitting the breakpoint, which will then choose the non-tool and release focus. So press F12, let's close the window, let's remove the breakpoint and test the scene again. So we can choose the axe tool, watering cam, and then right click and it releases. Let's choose the tilling tool, and we can now till, the axe tool, and then release. So that brings us to the end of this tutorial on how to create a toolbar with many different tools in it. In the future tutorial, I will show you how to till the land, then plant corn and tomatoes, and then water those crops so that they begin to grow. I will show you how to create many different collectible types using reusable components. You will then be able to easily add more collectibles to your game. So let's begin creating some more collectibles. In a previous tutorial, I've shown you how to create the log collectible, and this collectible component is reusable. So I will reiterate how I've created that, and then we will attach the collectible component onto some new collectible items, and that will prepare us for the next tutorial where I will create the inventory panel and show you how to update the inventory panel when the player collects those items. So go to Scene, New Scene, Other Node, and search for Sprite 2D. Then rename this to Egg, and then go to Game, Objects, and we have an egg item, so just drag that into our texture, and then let's zoom in. Then in the Scenes folder, go to the Components folder, and for the collectible component scene, just drag that onto our egg item. So let's just have a look at the script that we've created for the collectible component. Now, the collectible component, if we just open that scene, this is a type of Area 2D. So we can just check that item. So we created this Area 2D and then attached a script. And the collectible component has a class name called collectible component, which then derives from our Area 2D. I've then added an export variable for the collectible name so that every time we add this collectible component to a different type of collectible, we can just modify that collectible name, and this makes this component reusable. Then in the node, I've connected the body entered signal, and I check if the body which collides is the player, and then I do a print statement just for some debugging, and then we can free this item from our game. Let me just modify this print statement because we're going to do some more collectibles. When the player collects them, we just want to see which ones have been picked up. So we can just say collected and then collectible name. Then head back to the egg scene and let's just save that scene. So go to Scenes folder, Objects, and then just save it as egg scene. Let's go back to the 2D view and then click collectible component, add child, and look for collision shape 2D. Then for the shape, let's just choose the circle shape and then just reduce the size so that it covers our sprite. Then back on collectible component, let's just call this egg. Then go to Scenes folder, test scene, let's create a test scene for our collectibles. Let's choose the test scene player, right click and duplicate. And call this test scene collectibles and just duplicate that scene. Let's open the scene and then zoom in. Let's go to our objects folder. Let's first drop the egg onto the scene, then go to rocks because we created in a previous tutorial our stone collectible. So as you can see, it's set up in exactly the same way as the egg collectible, except we assign the name stone for the stone collectible, and if we just look in our trees folder, we've done the same for log, and that collectible is called log. So let's go to our test scene again and just drop these collectibles onto our scene. So we've got our log and then our stone. Let's just rename this test scene here and call that test scene collectibles and just save the scene. Now let's run our current scene and then let's just check the output here. So let's just pick up the egg. So we say collected egg, log, and stone. Let's create another collectible for milk. So go to scene, new scene, other node, search for Sprite 2D, create that, F2 and rename this to milk. And in the texture, let's just go back to our game and objects and drag in the simple milk and grass item. Let's just zoom in on this. Now for this sprite, we only want this item here. So let's just pull this up. And because this item is the second frame, so frame 0, 1 and 2, we need to set the frame here. However, the first thing is to say how many horizontal frames do we have. So we've got 4. Then in the frame option, choose 2. And this will then set our sprite. Now we can add our reusable components. So go back to components folder and then drag the collectible component onto our milk sprite. For the collectible name, let's just set this to be milk and then add a child node and search for collision 2D. Then for the collision shape 2D, for the shape, let's just choose a circle shape and then just resize that. We can now save that scene and we want to save the scene in the scenes and objects folder. So click save, head back over to the test scene and in the objects folder under scenes, let's just drag our milk onto our scene. Then we can test the scene again. Let's just look at the output again. So let's go to the milk item first. So we've got milk, egg, log, and stone. So for the corn harvest collectible, go to scene, new scene, other node, search for Sprite 2D, and rename this to corn harvest. Then go to objects under game folder, and then choose basic plants. And if we zoom in, we want to choose this sprite here. So for our horizontal frames, we have 6 frames, so choose 6. And for the vertical frames, there is 2. Then we can just move the frames until we get our corn harvest frame. Then head back over to components and attach the collectible component. And for the collectible name, we'll call this corn and right click and add another child node and search for collision shape 2D. Click create. And for the shape, we'll choose new circle shape and just resize this. Then let's save our scene. And in the scenes and objects folder, right click, choose new folder and call this plants. Then save the scene as corn harvest. And then for our final collectible, let's go to scene, new scene, other node, search for Sprite 2D, create that, and then F2 and call this tomato harvest. Then in texture, go to assets, game, objects, and then choose basic plants. And let's just zoom in on our sprite. Let's go to the horizontal frames and let's just set this to 6. And then the vertical frames is just 2. And then let's just increment frame until we find the tomato. And that now sets up our sprite. Then on the tomato harvest, let's go to components and then drag over the collectible component. And then for the collectible name, let's just call this tomato. Then right click and add a child and search for collision shape 2D. And for the shape, choose circle shape and just resize that. Now let's save the scene. And we'll save it in the same folder as corn harvest, so under scenes, objects and plants, and save that scene. Let's head back over to the test scene collectibles and go to the scenes folder under objects and plants. And let's add the corn harvest collectible and the tomato collectible. Then let's run and test the scene. Now, as you can see, as we move to the egg, we have Y-sort enabled on our player. So the player is sitting behind the collectible. So let's first just collect these. Make sure that we've got everything correct. So we've got egg, stone, tomato, corn, and milk. And let's fix that Y sorting. In a previous tutorial, I have explained Y sorting in detail. So you may wish to view that from the playlist. However, I'm going to go through and let's adjust the Y sorting on our collectibles to fix this issue. So to fix the Y sort issue, let's just look at our test scene. I will just organize these. Then let's open first the egg scene and scroll down on the sprite node until you see ordering and just turn on Y sort enabled and save that scene. Then open the log And on the sprite 2D again, go back down into ordering and turn on Y-sort. Then stone, scroll down and make sure Y-sort enabled is on. Back to test scene, open up the milk scene, ordering, turn on sort enabled, back to test scene, then to coin harvest, click sprite 2D, ordering, turn on Y-sort, and then finally for the tomato harvest, let's just open that scene too, and let's just enable Y-sort on this. So once you've enabled Y-sort on all of the collectibles, what we then need to make sure we have is the parent node must also be Y-sortable as well. And to check the player is also Y-sort enabled, and the Z-index is the same for everything. So let's just go to testing collectibles and enable Y-sort on that parent node. Now let's test the scene, and let's just move towards the egg. And as you can see, the player is now in front of the collectibles, and that's the desired effect that we need. So that completes everything for the collectibles. Now that brings us to the end of this tutorial on how to create many different collectibles and use reusable components. In the next tutorial, I'm going to show you how to create an inventory panel, and when you collect the collectibles, we will then update the inventory. I will show you how to create this inventory panel UI, complete with theming and styling. An inventory manager will manage the collectibles which have been picked up by the player and then displayed in the inventory items. Now to create the inventory panel, go to Scene, New Scene, choose Other Node and search for Panel Container and create that. And we'll just rename this to be Inventory Panel, and let's just save that scene. So go to Scenes, the UI folder, and we'll save it as the inventory panel. Select the node, and in the inspector let's just scroll down to Theme. Click on Empty and then just choose Quick Load and choose the Game UI theme which we covered in a previous tutorial. Open that, select the theme file, and we still have our dartwood panel. So in the type variation for the inventory panel, as you can see we have a base type of panel container. In the type variation, click the edit button here and type dark wood panel and then just select the tick box. On the inventory panel, let's go add child, search for margin container and then add child again and search for VBox container. And to create the inventory items, let's add another child, search for panel container again and then rename this to logs. Then click back onto inventory panel and in our theme, let's add a new item. Write the word inventory item panel and just click add type to add a custom type. And then in this option here, let's just add a base type. And the base type will be our panel container. Then let's just choose this option here and then we'll add a new style. So click on empty and choose new style box texture and then click it to activate the style box texture. Then on our texture property, choose new atlas texture and then just activate that. And then go to game, UI, and then just drag the basic UI sprites into our atlas texture. Then scroll down to edit region and then choose auto slice and then zoom in and select this option here. Click close, then edit subregion and just choose pixel snap and then just drag the bars in and then click close. And then once we've set up the texture, click back on logs and then scroll down, and for the type variation, just click edit and write inventory item panel and then just click tick. And as you can see, it's just starting to apply the panel here. So click on logs, add child node and search for texture rec. Then for our texture here, choose new atlas texture and open that. And then go to assets, game and objects and bring over the basic tools and material sprites. Open that and then choose edit region and then choose grid snap and choose this log item here. Just draw the grid square and then click close and that will create us our log icon. Then add another child node and search for label and rename this as log label and just put a 0 in the text field. Now we need to fit the icon and label in this panel space. So click on logs, and for custom minimum size, let's give a width of 26 and a height of 32. Now we need to position the icon so that it's at the top of the panel. So click texture rect and choose center, and then choose vertical alignment, shrink begin, and that will just reposition that icon. Then for log label, we want horizontal alignment center and then vertical alignment bottom. The next step is to configure a font so that it renders better under the icon and is more pixelated for this game. So head over to the assets folder, and in the UI folder, create a new folder called fonts. And now we will download a font which is more pixelated and will render better for our inventory counter. So head over to damiang.com and download the ZX Palm font. You can do that by just clicking this download link here, and I will leave the link for this font in the description below. Once you have downloaded and unzipped the ZX Palm file, go into the folder and then into PC folder, and then take the zxpalm.ttf file, then drag that into the fonts folder which we have created under our assets folder. Now I'm just going to rename this file so that it's organized in our project. I'm just going to say lowercase zx_palm. Then I'm going to right click and add a new resource. Then search for font, and what we want to create is a font variation. So create that font variation file, and we'll call this ZX Palm and leave variation on the end. So just save that. Then open this file and drag in the original TTF file. So drag the ZX Palm file over into the base font here. So the font variation resource will allow us to make some slight modifications to our original font. So we are going to use that for our label, and then I'll come back to this resource and make some slight changes. So let's click back on the inventory panel, click Game UI theme, and then in the theme, let's add another item type. Type inventory label, and then just click add type. On this option here, let's just choose label as our base type and set that. Then choose this option and then click add here to override our fonts file. Then choose the ZX Palm variation and drag that into our fonts file here. Then on the option next to this, we want to just reduce this to 8, but first let's just go back to log label here, scroll down, and in type variation click the edit button, and then type inventory label, which is that item type which we've just created in our theme. Click the tick box, and as you can see, this is now updated to reflect that new font file. Go back to the inventory panel, and the font is currently at 16. And then let's just modify the font size. So choose that option to edit the font, and then just reduce this down to 8. So as you can see, 8 has better clarity. If we go to 10, it starts to look blurred. So we go 8, 16, then 24. So it's in multiples of 8, and the pixel font has been designed to be an 8x8 pixel font. So what we're going to do is just use the size for 8 pixels. Now that we have set up the inventory label style, let's just click back on log label and let's just test a few numbers. So we'll try 100, and as you can see, that now makes our item panel stretch. So let's go back to our ZX Palm variation and let's make some modifications to our base font. So for extra spacing in the glyph, we can reduce that and bring in those values. So I'm going to put that at -3. And then I'd like the text to sit actually in this red box, or bring it up a little. So in the top, let's just increase that, and we'll leave it at value 2. So as you can see, the variation font resource allows us just to make those little tweaks that we need to make for our font, and that can be really useful. Let's now just adjust the margin container so that we have a nicer border around our inventory item. So click on margin container, and the default margin will be set to 10 because that's already on our theme, but we don't want to modify it there. Let's just do it on the theme overrides here. So let's just turn on margin left, top, right and bottom, and then just set the value for each of those fields. Click back on log label, and let's just reset this to 0. And now we can begin duplicating this panel item. So right click on logs and click duplicate, and rename this to stone, then rename the label to stone label, and then for texture rect, let's just reset that. Click empty, new atlas texture and open it, then go to game, under assets, objects, and bring over basic tools and materials. Click edit region, and then with grid snap already selected, just draw a grid around the stone item and then click close, and then save the scene. So click stone and then duplicate that scene. Let's rename it to corn. Let's rename the stone label to corn label, and on texture rect, let's reset that. New atlas texture, and then for the atlas texture, go to assets, game, objects, and bring over the basic plants. Then edit region, and for grid snap selected, let's then just choose this corn icon here. Let's close that. Then for the tomato, let's just duplicate that again, rename this to tomato, and then the corn label to tomato label. Then choose texture rect, reset the texture, choose new atlas texture, and then bring over the basic plants from the game objects folder under assets. Just set that onto the atlas property. Edit region again, and then choose the tomato here under using grid snap mode. Close that. So just bring this up a little and duplicate the tomato scene. Rename this to egg, and for tomato label, we'll rename this as egg label. For texture rect, reset that, choose new atlas texture, and then for the atlas texture, just bring over the egg item. And for the final inventory item, choose egg, duplicate the scene, and rename this to milk. Then for egg label, we'll call this milk label. Choose texture rect, reset the atlas texture, choose new atlas texture again, open that, and then bring simple milk and grass item into the atlas property here. Choose edit region, and using grid snap, choose this sprite here and click close, and then just save the scene. So now that we have completed our inventory panel UI, let's head over to our game screen, open up the game screen, and then drag the inventory panel into the game screen. Then to position the panel, choose anchor preset and then center left. We can now create an inventory manager so that when the player collects the collectibles, we can then update our inventory items and this value here. So first, let's head over back to scenes, then to the test scene folder, and duplicate the test scene collectibles scene. So duplicate that, and we'll call it inventory management, and just duplicate that scene. And before we open the test scene, I'm just going to move the inventory panel inside the margin container. So now we've got the correct margin around the panel. But now we need to adjust the positioning of the panel. So for horizontal alignment, choose this option here for shrink begin. And then we need to vertically align the panel as well. And that will just fix the layout. Now head back over to the test scene folder and open up the inventory manager test scene. Let's just rename this scene here and call that test scene inventory management. Then go to the UI folder and just drag on the game screen. Then go to the scripts folder and in globals, right click, create a new script and call this inventory manager. To create that script, open the script and then in project settings, go to globals and then open up that global script. So just add the inventory manager, open that and then just add that as a global script and then close the window. And in the script, let's create a new variable and call this inventory, which is a type of dictionary, and then we can just instantiate the dictionary. Then create a new signal and call this inventory changed. Then add a function called add collectible and pass in collectible name, which is a type of string, and we'll return a void. Then we can say inventory dot get or add and then pass in the collectible name. So what we are doing is adding the collectible name to our inventory dictionary. Then we can say if inventory collectible name equals null, then inventory collectible name equals 1. So if we have nothing in the inventory which matches our collectible name, then we're going to instantiate the item and then just add the value 1. Then we'll say else inventory collectible name plus equals 1. So then we're going to keep incrementing that value once we already have something in the inventory with our collectible name in it. And then after that, we can call our signal. Now let's start to add our collectibles to the inventory. So go back over to components, and we've got a reusable component for the collectible item. So open up the collectible component, and then in the onBody entered method, what we want to do is call our inventory manager and call add collectible. Then we can pass in the collectible name. So before we test the scene, just go back to scripts and globals and open up the inventory manager and put a breakpoint here where inventory.get or add. Then let's head over to the test scene and let's just run our test scene. Now we can get the player to pick up one of the items. So we'll just pick up this stone here. And as you can see, the breakpoint now gets called in our inventory manager script. So first, let's just check and hover over our inventory. So at the moment, there is nothing in the inventory. So let's just add our collectible name, which is stone. And as you can see, stone has null for the counter. So let's just check what happens here. So if we're checking for null, then what we want to do is add 1 to the collectibles. So inventory now has stone and has a value of 1. So this is working as expected. So let's just stop that. And now this method is being called. Let's link up our signal here. So go back to the inventory panel, and for our inventory panel UI scene, choose the inventory panel and attach script. We can save the inventory panel script under scenes UI and click create. And let's first override the ready function. So go ready void and then get our inventory manager, then connect the inventory change signal and call this on inventory changed. Let's create another function on inventory changed and we'll return a void. And when the inventory changes, let's then get the dictionary from the inventory and then check if we've got any items in there. So the first thing we'll do is check for logs. So just open up the logs panel, choose log label and hold control, and then just drag the log panel into your script so that we get an onReady variable. Then in on inventory changed, we can say for inventory dictionary equals our inventory manager dot inventory. Then once we get the inventory from our inventory manager, we can say if inventory dot has, and then we look for that collectible name. And if we have a log in the inventory, then we just need to say log label dot text equals string inventory and then the array item from the dictionary, which will get the value, and just pass in log. So before we finish this function, let's just test picking up multiple logs. So go to test scene, objects, trees, and then the log scene. We'll add 2 more of these items to our scene. Then let's run the scene, and then we'll move the player. And as you can see, we've just incremented that value. That's the first scene and first collectible that's been added to the inventory. Let's just check if this now increases to 2, and that increases to 2 and then 3. But now if I pick up the egg, we haven't completed the code for that method. So let's just close the window and finish the rest of that method. So head back to inventory panel and then the inventory panel script, and I'll just finish off this method. So I have now added the rest of the labels from the inventory panel. So we have log, stone, corn, tomato, egg and milk. And in the inventory change function, we now check the inventory for each of those items, and that just completes the rest of that method. We can now test the scene and test each of those collectibles. So just run the test scene. And now we go to egg. So we have one item here, milk, one item, corn is one item, tomato and stone, and our 3 logs. Let's close that window. And that brings us to the end of this tutorial on how to create an inventory panel UI and then allow your player to pick up collectibles which are then added to your inventory. I will show you how to create a day and night effect for your game, complete with a time manager and a UI for the player to interact with. So let's start by creating a new day and night UI panel. So we'll go scene, new scene, and then choose the user interface option, and then just press F2 to rename that, and we'll call it day and night panel. And then let's save that scene. So go to scenes, and in the UI folder, we'll just save the panel here. Click save. And then on the day and night panel, scroll down, and on the theme option here, just go and click load, and then load the game UI theme resource. Click open, and then just hop over to our 2D view. Then in the theme option, just click to open the theme. And then let's add a new style type. So we'll click the plus button here and call this day and night counter panel and click add type. And then we'll choose this option here and then just change the base type, and then search for panel container and then set that base type. Now that we've set our theme on the root node, let's add another child node and search for panel container. Choose this option and then click create. And then in the panel container, just scroll down, and for type variation, let's just set that. So click the edit button here and type day and night counter panel, and that will set the style. We click the tick. Then let's head back to the theme by clicking the root node and then choose the theme option here. Then what we want to do is to update the panel. And then for the panel option, click the plus button and then click empty, and we want a new style box texture and click that. And then for the texture, say new atlas texture and then open that resource. Then go to the game assets folder, and in the UI folder, bring over the basic UI sprites and just drop that into the atlas property, and then click edit region and zoom in on the asset, and we want to take this selection here. So let's just choose pixel snap and just draw a box around this asset here. So we just want this top half here, and then click close. We'll just close the atlas texture down, and then we have another edit region under sub-region. So just click edit that region. And then with pixel snap selected, just bring in these bars here. And as you can see, it starts to update our UI control. So bring the next bar in until we frame our panel, and then click close. We just zoom in, we can now see we've got our panel here. So for panel container, let's just rename that panel and call it day panel. And then let's add another child node and search for margin container. Add another child node and search for label. In the label, just type day 0 for now. And this just puts in some text for us for the meantime. Now let's just adjust the margin container a little bit more, because it's taking the 10 pixels automatically from our theme, which we've defined earlier here. So back on margin container, let's override those margins. So we say margin left, top, right and bottom, and then set 3 pixels for each. This just improves the margin around our text for this particular panel. Let's just head back to the theme and let's now style our label. So click the plus button here to add a new style type, and we'll call this day and night label. For the base type, let's just click the plus button again and choose label as our base type, and then just set that base type. Then click the option here for our fonts file, and then let's add a different font. So let's just override that item, and then let's set the fonts file here. So if you go back to our game folder under assets, and then just into the UI folder, we've already set some fonts in there. So now let's add a new font. So head back over to the Sproutlands UI pack, and in the basic pack, there is a fonts folder which contains a pixel font in there. So we're going to use this font for our day and night label. So just click and drag that over, and I'll be leaving the link in the description for the UI pack. Once we have the font, we can then drag and drop that into our font on our theme. So just click and drag the font into our theme here, and then click back on label and just scroll down until you get to theme. And for the theme variation, let's just edit that and type day and night label, and let's just accept that. So as you can see, the font has now been updated on our label. Let's just make an adjustment to our font size. So just click back on the root node and then get to the theme and choose this option with our day and night label chosen here, and then just change the font size. So let's just click the plus button, and then just let's up the font size until we get better clarity. So if we keep going further, you'll see that it goes blurred, and this is because the font has a specific size. Now let's just adjust the size of the day panel, scroll down till we get to transform and size, and just change the Y to 26, and this will just adjust it to make it fit a little bit better with our text. Then click the day panel, and let's just duplicate this panel, F2, and rename this to be time panel. Then click the down arrow key just to adjust the new position of our time panel. Then in the label, just write a time in there. So we'll use 12 o'clock. And then let's adjust the width of the panel as well. So let's just go back to day panel, and let's make the size on our X axis 80. And we'll do the same for our time panel as well. Then let's align the text in our label. So click label, and then just click shrink center, and then just do vertical center as well. And then for the label in the time panel, let's just do the same. So we'll just click this option here, and then horizontal alignment shrink center and vertical alignment shrink center as well. We are going to add 3 buttons to our day and night panel, which will allow the player to artificially speed up the time. So we'll add a normal speed, a faster speed, and a cheetah speed. So click on the day and night panel and add a child node and search for control and add a control node. Add another child node and search for button and add a button node. Let's just rename the button node and call this normal speed button. Then click on the control and let's just reposition this control. So under transform position and Y, let's just click in there and then just modify this. So I'm just using the arrow key to move that down and just going to position the button underneath the time panel. Then let's go to our theme and let's just add a new style type in our theme. So click the plus button and call this day and night button and just add this new type. And then just click this option here to set the base type and search for button and then just set that base type. So before we style the button, let's just now go back to the normal speed button option here and scroll down until we get to our theme, and then type variation, just let's edit that. And let's just write day and night button, and that's the style, and just accept that. Then head back to the theme and choose the styles option, and then scroll down to the normal style and click the plus button, then click empty and choose new style box texture. Click on the style box texture, and in the texture, let's create a new Atlas texture and open that. And then back in the assets and UI folder, let's bring over the basic UI sprites and just open that. And then when we get to region, choose edit region, just zoom out, and we are going to choose this section of sprites here. So choose auto slice and pick this option here and choose close. And scroll up and just collapse the Atlas texture and scroll back down to sub-region and choose edit region. Let's just scroll in and then change snap mode back to pixel snap and just bring in the bars to frame the button. Once the button is framed, then just click close. And as you can see, we now have the button style here. Now click the button and let's just resize this button. So if we go to the transform and size, for X, use the value 26, and for Y, use the value 18. Then click back on our theme, and let's now style the other properties here. So for normal, right click the style box texture and click copy here, and then paste this into the hover style. So just click the plus button to enable hover style, but right click and paste, then right click again and make unique recursive. And with all the options selected, click OK. Now click the style box texture, and this will create new instances of all of our textures. So open up the Atlas texture, and in edit region, let's zoom out. And for snap mode, choose auto slice, and then choose this option here and click close. Then scroll down to sub-region, and as you can see, this is already now set up for us, so we can just click close on that. Go back to our style and just right click and copy the hover style. Then scroll down to pressed and just activate that, and then just right click and paste that style in. But right click again and also make that unique and click OK. Then activate the style, so we load it here, and then open the Atlas texture and choose edit region again and scroll out, and with auto slice still selected, just choose this option here and click close. And then we can just collapse the Atlas texture. Then copy the press style, then find the focus option, and then just let's add and override that option. Right click on empty, paste, right click again and choose make unique and click OK for that. Then activate the focus style, open the Atlas texture, scroll back down to region once more, and then zoom in and choose the same tile. So focused and pressed will use the same thing, so we can actually just say close as it's already selected. And for the final property, right click focus, copy the style, and for disable, let's activate that. Right click the empty option, paste, right click again and make that unique, and then click OK. Let's open that style, activate the Atlas texture, and then go to edit region, let's scroll out, and we'll choose this option here. So with auto slice already selected, just choose that tile here and click close. And that will set up the disabled style. So for buttons, it's always good practice to create styles for pressed, normal, hover, focus, and disabled. So now let's test this panel UI. So with the day and night panel selected, just click run current scene to test it. And we've got the day panel, time panel, and let's just check that our button is activating so I can see the hover state. And then let's click it and it highlights, so I'm holding the mouse button down and that's pressed. And then when I move the mouse away, I've still got my focus style, which is the same as pressed. Now let's overlay a texture on this button. So click normal speed button and add a child and search for texture rect. And then in the texture, choose new Atlas texture and open that. And then bring over the basic UI sprites from our assets in UI folder and just drop that into the Atlas. Then edit region and zoom out, and with auto slice selected, choose this sprite here and just click close. And now let's resize the texture. So click texture rect, scroll down, and in size for X, choose 7, and for Y, choose 12. Let's just zoom in, and then in the anchor preset, choose the center option. Now the normal speed button is complete, so let's just duplicate that button and rename it to fast speed button. Then on the fast speed button, let's scroll down to transform, and in the X position, let's just reposition that button, and we'll leave the value at 27. Then for texture rect, the X is 9.5, so let's just change that to an integer value of 10. And then let's just go to texture rect back on the normal speed button and just check that. So we'll just make that 10 as well. Then for texture rect here, let's just duplicate that. And then let's reposition the arrow. So just scroll down on texture rect 2. And in the X position, let's just reposition that. And then click on texture rect and just reposition that as well. So that then centers those icons for us. Then click the fast speed button and duplicate this button again. Let's rename it and call it cheetah speed button. And let's then duplicate texture rect 2 and let's adjust the position on that. So for texture rect 2, let's just scroll down until we get to our transform. And in position, let's just move that down a little. For texture rect, let's just increase that. And then keep increasing the positions until we get them relatively center. Then, once you've centered and adjusted the positions of the textures, what we need to do is then just reposition the button. So click back on the cheetah speed button, go back to transform, and in position, let's just move that. Now click on the control which contains the buttons and just resize this. So let's just increase the X parameter until we get to 80 and then reduce this down. And that will just wrap our buttons. This now completes the UI for the day and night cycle. So let's now create a test scene so that we can then add this UI to our game screen. So I'll head over to the scenes folder and in test folder, let's create a copy of our game screen test scene. So right click, duplicate, and call this day and night cycle, and just click duplicate for that. Let's open that test scene, and then let's just rename the scene here, and call it test scene day and night cycle. And now we can add the day and night panel to our game screen. So just open the scene, and then just go to scenes and UI folder, and then just drag the day and night panel into the margin container. So we just need to reposition this. So let's just go to the anchor points and choose horizontal shrink end and vertical shrink begin. Now let's just zoom in on our UI, and as you can see, the panel is just cut off from the right hand side of the viewport. So let's just head back over to the day and night panel and then just click the root node and just make sure the anchor point is the top left so that we have this anchor point here. Then click on the day panel and go to position, and on the X axis, let's just reduce the position so that it moves into the negative X axis. And we'll do that at -80. So we'll just zoom in and we just line up this pixel line here and do the same for the time panel. So position on the X axis will be -80. And then for the control option here, which contains the buttons, let's just go to the transform, and for X axis, do -80 on here. So we've just set that. Let's save that and then go back to game screen. And you can see now that the day and night panel is correctly positioned and the anchor point is in the right place. Then head over to test scene day and night cycle and we'll have our panel here. So let's just run the test scene. And this has now set up our UI correctly here. We're now ready to create a global script for the day and night cycle manager. So go to scripts and globals, right click and create a new script and call this day and night cycle manager and click create. Open the script and then go to project settings, and under globals, let's just add that global script. So open the scripts folder in globals and then choose day and night cycle manager and open that, and then add that script and just close that. And in our script, let's begin creating some constant variables. So say minutes per day, which is an integer value, say 24 multiplied by 60. Do another constant variable, minutes per hour, type of integer, and equals 60. Right, another constant variable, which is game minute duration, which is a type of float, equals tau, and that is short for 2 multiplied by pi, divided by minutes per day. Then we'll do some default parameters, so we'll have a var game speed, which is also a float, and we'll just set that to 5. And say var initial day, which is a type of integer, and set that to 1. Then variable initial hour, integer equals 12. Variable initial minute, integer equals 30. We will like another variable called time, which is float. We'll just set that to 0. Another variable, current minute, which is an integer, and set that to -1. Or current day, which is an integer, and set that to 0. Then we'll create some signals. So we'll say signal game time and then pass in time. Our next signal is called time tick, and we'll pass in day, which is int, hour, which is integer, and the minute as well. And for another signal, we'll call it time tick, day, and pass in day as well. And create a function called set initial time and return void. Then say var initial total minutes equals initial day multiplied by minutes per day plus initial hour multiplied by minutes per hour plus initial minute. And that will set up the initial total minutes. Now let's calculate the initial time. So say time equals initial total minutes multiplied by the constant game minute duration. Then just above this method, write function and override the ready method, and then just call set initial time. Then override the process method, so function process, then say time plus equals delta multiplied by game speed multiplied by game minute duration. Then let's get our signal, game time, and emit time, and then we can subscribe to this signal. Then in our process method, we need to recalculate the time. So create a new function and call this recalculate time, and say for total minutes, which is int, equals integer time divided by game minute duration. Then for current day minutes, which is an integer, say total minutes modulus minutes per day. And for our integer equals current day minutes divided by minutes per hour. And for minute, which is type integer, current day minutes modulus minutes per hour. Now that we are recalculating the time, we can now emit some of our helper signals. So say if current minute is not equal to minute, then current minute equals minute, time tick, emit, day, hour, and minute. Then say if current day is not equal to day, and just modify this here, then current day equals day, time tick day, dot emit, and then pass in day. That finishes the recalculate time function. So back in the process method, let's just call that method here. Now that our script is complete, let's go back to the day and night panel and update the labels for our day and our time here. Let's just go back to the time panel and just reset the time to midnight. And then for the day and night panel, let's attach a script and we'll save that in the Scenes UI folder. So for the first label, select label and just rename that and call it day label. And for time label, we'll just rename that as well. So click and drag the label and hold Control and create an onReady variable for the day label and do the same for the time label. Then override the ready function and let's get our day and night cycle manager and connect the signal. And we'll create a function called onTimeTick. We'll say function onTimeTick and pass in day, which is an integer, hour, which is an integer, and minute, which is an integer as well. And then just return void. Then get our day label and say text equals day space plus, and then use the string function and pass in our day. Then get the time label, text equals open quotes, and use 0 to D for the format, percentage 0 to D, and just add the percentage on the front of this. So this is a string formatter which will convert the integers to string, and then use percentage and then pass in our two variables. Then let's create some export variables. So we'll set export for normal speed, which is an integer, and set this to 5. Then at export for fast speed, which is an int, and set this to 100. And then export for cheetah speed and set this to 200. And click on normal speed button, and in Node, let's choose the pressed signal and just connect that. Just click connect, then say day and night cycle manager dot game speed equals normal speed. Then click the fast speed button, choose the press signal and connect that too. Click connect and copy this line and set this to fast speed. And for the cheetah speed button, choose pressed, connect the signal, click connect, and copy this line once more. So now that the script is complete, let's head over to test scene day and night cycle and just run the current scene. As you can see, the day and night cycle manager is now updating the time in the UI. So let's just speed this up. We're using the fast speed and the time is now incrementing, and we should get a change in the day. So we've just gone to day 2, and then we can make this even faster. So as you can see, we've now linked up those buttons, and with those export variables, you can change those speeds. Let's just close that. Our next stage is to create a day and night cycle component which will modulate the canvas to give a transition of colour between day and night. So let's go to scene, new scene, choose other node, and search for canvas modulate, and just create that. Rename the node to day night cycle component. Then save that component and place it into the scenes and components folder, and we'll just call it day night cycle component and save that. So just go to the components folder, then right click and attach script, and just save the day night cycle GD script in that same folder. Let's open the script and let's give this a class name. So we're going to make a custom component for this, and we'll derive from canvas modulate. So we'll give the class name day night cycle component, then create an export variable called initial day, which is of type int and a default value of 1. Now we're going to make this a setter, so I'll call set, and then I'll use initial day and just shorten this to ID. Then say initial day equals and the value that's passed into the setter. Then I'll call the day and night cycle manager and set the initial day to the value passed into the setter. And I'll call the manager again and set initial time. I'll do another export variable and call this initial hour and set the integer to 12. Then set and pass in the value IH for initial hour. Then say initial hour equals and then the value. Then I can say day and night cycle manager dot initial hour equals and the IH value. Then we can set the initial time. Then I'll export another variable, which is initial minute, integer and default value of 30. Then set and pass in the variable IM. Then say initial minute equals IM. Then call the day and night cycle manager, set initial minute to IM, and then call set initial time again. Then export another variable and call this day night gradient texture, and we'll use a gradient texture 1D. Then override the ready function and call day and night cycle manager dot initial day equals the initial day. Then day and night cycle manager dot initial hour equals initial hour. Day and night cycle manager again dot initial minute equals initial minute. Then finally day and night cycle manager dot and then set the initial time function. Then let's register to the game time signal and just connect that. And we'll call the function on game time. Let's create a new function. We'll call it on game time, passing time, which is float. Then we want a variable called sample value equals 0.5 multiplied by, then say sin time minus pi multiplied by 0.5 plus 1.0. Then we want to set the color variable inside of the canvas modulate. So this is a property of this component. So say color equals, then get the day night gradient texture, access the gradient property, and then there's a method on there to sample the gradient and pass in the sample value. So the on-game time function will use the time from the day and night cycle manager and then use a sine wave function to oscillate the value between 0 and 1. Then the sample value will be used to sample the colour from the gradient texture, which will give the effect of a day and night cycle. So let's head back to the day and night cycle component, and in the day and night gradient texture, let's just create a new gradient texture 1D. And for now, I'll just leave that to black and white. Go back to the test scene day and night cycle, and then let's add our day and night cycle component to our test scene. So we'll just drag that component onto our scene, Let's go to the 2D view and then let's test the scene. Let's just speed it up. And as you can see, the time is affecting the gradient and we are getting a day and night cycle. So let's just stop that. So go back to the day and night cycle component and modify the gradient here. So open up the day and night gradient texture, then just put a colour marker here and we'll set that to white. So we'll say this is the night and this is our day. So if we adjust this more to the left, we'll get less of night time. So I'm just going to put it roughly about here and then I'm going to go and select some colours. So I've finished adding the colours and you can modify them. Let's go back to the test scene and then let's just run the test scene again and let's just speed it up. And as you can see, as we get later in the night, we've gone to night time, then back in the morning and we've got dawn. We'll just slow it down roughly in the night. So as you can see, it's darker and then it's coming back into dawn and we can just close that. So back in the day and night cycle component, you can make adjustments to the colour bars to get the desired effect for the time of day. And one last thing to test on the day-night cycle component is let's just modify the day. So we'll set this to 6, the initial hour to be 2 PM in the afternoon, and then 18 minutes past the hour. Let's go back to the test scene and then let's run that. And as you can see, we have changed the day and we've got different time as well. So you can customize this for your game. And that brings us to the end of this tutorial on how to create a day and night effect for your game. I will show you how to create crops and grow them using the day and night cycle. As each day passes, the crop will grow and then you'll be able to harvest them. So let's begin by creating our first crop scene. To go to scene, new scene, and add a 2D scene. Then rename this to corn. Then add a child and search for Sprite 2D. Then head over to our assets folder and in the game and objects folder, we want the basic plant. So we just double click that and we're going to use these crop assets here. So back on Sprite 2D, just drag the basic plant into here and then just zoom in onto our sprite. And then for horizontal frames, set 6. And for vertical frames, set 2. Then for frame, just increment this value to 1. Then head over to the scenes and components folder and grab the hurt component and just drag that onto our corn scene. Then for the option on the tool, choose water crops. Then add a child node and search for collision shape 2D. In the shape, choose rectangle shape. And then we'll zoom in on the sprite and just make an adjustment on here. And that will set the collision area. So we are using the hurt component to receive the hit from the player's tool. And by setting the water crops tool, when the player goes to water the crop, we can receive that event and then start to process the growth cycle. So back on corn, say add child and search for GPU particles 2D and rename this to watering particles. I'll just move the particles to here. And in the inspector, under process material, let's create a new particle process material. Then open the material and scroll down to angle, and for the minimum value, choose -180 and then the max value 180. Then for angular velocity, choose -300 for the minimum value, and then for the maximum value, 300. Then for orbital velocity, we'll have -1 and 1. And in accelerations, let's have -10 on the y-axis so that the particles are moving upwards. And then we've added some angular velocity so that the particles turn and spin. Then scroll down to colour and let's just modify this. And just choose blue colour just for the water. Then scroll back up to the process material particle. Let's just close that. And then in the amount property, let's increase that to 16. Then click on the sprite and let's just move the position of this sprite. So scroll down to transform position, and on the y-axis, let's just increase that and position that here, and then do the same for the hurt component. So we'll just go back to transform position Y and just move that as well. So now save the scene and go to the scenes folder, objects, plants, and save the scene as corn. Then click the watering particles and drag that into the scenes, objects, and plants folder, and save the watering particles as a component in there. Then just delete it from the scene and then just re-add that. And then just save the scene again. Then go to corn again, add child node, and search for GPU particles, and then create another particles child node. Then rename this node to flowering particles, and then just drag that above the hurt component. And to view the particles better, just turn off the hurt component for now, just so we can see the colours a little bit better. Then click on flowering particles, and then in process material, let's create a new material and choose new process material here, and then just open that. Let's also just turn off the watering particles, so we're just focusing now on our flowering particles. Then scroll down to angular velocity and choose -180 by 180. Orbital velocity is -1 and 1. In gravity for the Y, choose -100. And for colour, we'll just keep this white for now. Let's just scroll up and just collapse the particle process material. And in lifetime, change this to 0.6. We just move this into a better position for viewing. And speed scale will change to 0.4. Explosiveness to 0.5. And randomness to 0.5. Then reduce the amount of particles to 6. Now that we've finished the flowering particles, let's also just drag that into our scenes, objects, and plants folder, and then save the scene in there. Just delete the flowering particles from the scene, and then just drag it back on to the corn scene and just reposition it. Now we can turn back on the watering particles and the hurt component. Now let's create a test scene for our crops. Go to Scene and Test folder and make a copy of the test scene day and night cycle. So let's just duplicate that and we'll call it Test Scene Crops and just duplicate. Then open the scene and the day and night cycle component, let's just disable that for now. Zoom in on the scene and then go to Objects and Plants and just drag the corn item onto our scene. Then let's just run the current scene and that just tests our scene item there. So we can just close that. Then head back to corn and we'll create a growth cycle component which will manage transitioning the sprite and manage the growth of the crop. So we'll go Scene, New Scene, Other Node, and just choose Node and Create. And just rename this to Growth Cycle Component. And then save the growth cycle component into the Objects and Plants folder. Then let's attach a script, and you can save that also in that folder too. And in the growth cycle script, type class name, growth cycle component, add an export variable for our current growth state, which will be a new data type. So let's create that data type first. So head over to scripts and globals, and then just open the data type script. And in this script, let's create a new enum called growth state. The first enum is seed, and germination, vegetative, reproduction, maturity, and harvesting. Now the reason why I've chosen these enums is if we go back to the objects folder in the asset and just open the basic plants, if we just scroll in on the asset, each enumeration will match the sprite frame. So we've got seed, germination, vegetative, reproduction, maturity, and then the harvest at the end. Now let's head back over to the growth cycle component, and inside the script we can now say current growth state is of type data types dot growth states equals data types dot growth states, and then we'll use seed as the default value. For the next parameter, use export range with a value of between 5 and 365 for the days, and use variable days until harvest and use a default value of 7. Then we'll create some signals. So we'll have a signal for crop maturity and a signal for crop harvesting. Then some more parameters. So far is watered, which is a type bool, a variable for starting day type int, and another for current day, which is also type int. Then let's override the ready function, and let's get the day and night cycle manager, and then get the signal time tick day, and then connect that signal. Let's create another function called onTime tick day, pass in the day and return void, and then say if is watered, then if our starting day is equal to 0, and set the starting day to the day that's being passed by the signal. Then let's create another function and call this growth state, and pass in the starting day, which is an int, and current day, which is also an int, if current growth state equals our data types dot growth states dot maturity, then return. So what we're doing here is when the growth states are being traversed, once we get to the maturity state, we just want to come back out of this method. Then variable number of states, and just set this to 5. Then variable growth days passed equals current day minus the starting day modulus number of states. So if we go back to the data types, the number of states are these. So that's 1, 2, 3, 4, and 5. Go back to growth cycle component script, then create another variable state index, and say growth days passed modulus number of states plus 1. Then set current growth state equals the state index. So the current growth state is of type data types growth state, and the index value will set that enum value. Then let's get the current growth state from the data types keys and just print that as a debug statement. And we can say current growth state is name, and then state index, and pass in that state index as well. Then say if current growth state equals data types growth states and maturity, then call the crop maturity signal and emit that. That completes the growth states function. So just scroll back up to onTime tick day, and let's just add this method, and then just pass in starting day and day. Then let's scroll back down and add another method, and we'll call this function harvest state, and then just pass in again the starting day and current day. So we'll just do that, and then say if current growth state equals data types growth states and harvesting, then return from this method, and say var days passed equals current day minus the starting day and modulus days until harvest, which we've defined in our export range. Then say if days passed equals days until harvest minus 1, then current growth state equals data types dot growth states dot harvesting. Then we can call the cropped harvesting signal and emit that. Then we can go back to the onTime tick day method, and after the growth state method, just call the harvest state method and pass in starting day and day. Let's scroll back down. We've got one more method to complete. So create a new function called get current growth state, but return from this function a growth states from the data type. So we will return the current growth state, and this is what we set in our growth state method. So that completes the growth cycle component script. And then head back over to the corn scene, and in the scene objects and plants folder, just add the growth cycle component to this scene. And I'll just position that above the hurt component. Now click on the corn scene right click and attach a script, and we'll keep it named as corn and just create that in the objects and plants folder. And the first variable will be var corn harvest scene equals, and then preload the corn harvest scene here. And we've created this corn harvest scene as a collectible in a previous tutorial. Then select Sprite 2D and just drag that into our script, and then hold Control to create the onReady variable. And do the same for watering particles, flowering particles, the growth cycle component, and our hurt component. Then create another variable called growth state, which is type growth state, and then just set the default value to be growth states and seed. Then override the ready function, and then just say watering particles emitting equals false, flowering particles emitting also equals false. Then grab the hurt component and then connect the hurt signal. So create the function on hurt, and inside that method we can say if not growth cycle component is watered, then watering particles emitting equals true. Then use an await and call getTree, create a timer of 5 seconds, and then just register that timeout signal. Then after the timer has elapsed, we just want to then set the particles back to false to stop emitting. And then for the growth cycle component, just set is watered equals true. Then back in the ready method, get the growth cycle component, and for crop maturity, connect that signal and create a function called onCropMaturity. So after the hurt method, we can say onCropMaturity, get the flowering particles, and just set emitting to true. And this will just activate those particles to show that the maturity has happened in the growth cycle. Then just scroll up, and after the ready method, let's override the process method. And let's get the growth state and grab the growth cycle component and get the current growth state from that component. Then get our Sprite 2D and set the frame to be the growth state. Then say if growth state equals data types dot growth states dot maturity. Then grab our flowering particles and set emitting to true. So now that we have completed the corn script, I would just explain a little how the corn script and the growth cycle component work together. So as you can see, in the ready method, we are registering to the hurt component signal and the growth cycles component signal. When the player is using the watering can and approaches the crop, as they water the crop, the hurt component will first be called. In the onHurt component, we then tell the growth cycle that the crop is currently watered, and then we emit watering particles so we can show the player that the crop has been activated. Then in the growth cycle component, the day and night cycle manager will always constantly be communicating with the growth component to give it the current time of day. When the crop is watered, then the growth cycle component will start to go through the growth state. So until the crop has been watered, nothing will happen. And as you can see, we first go through the growth state, we calculate the growth days that have currently passed, and then set the state index, which we then get later to modify the frame on the sprite. So the growth states have been separated from the last state, which is the harvest state, because you can set a different number of days for the harvest state. Now the growth state is fixed because of the number of frames on the sprite. However, the harvest state can be several days later. So I've separated that to give a little bit of variation, because you may have crops with different harvest days. Then you get the current growth state here, and that just enables to update the frame. I've just noticed that the current growth state on default is set to seed. However, that should be the first frame, and we should really set that to germination. So just update that. Now let's test the scene again. But first go to debug settings and just turn visible collision shapes on, and then go to test scene, crops, and then 2D, and then just run this current scene. And just click the watering can and just use the left mouse button. So at the moment, this white collision shape is stationary. So let's use the axe, and we've only configured the hit part for the axe. So let's configure it for our watering can. So let's head over to the player scene. To go to scenes player, open up the player scene here, and then select the chopping state script and just scroll to the top. So we'll need to take the hit component collision shape. Let's copy this line here and then head to the watering script. And at the top, just paste that in. Then back to chopping and just take the ready function as well and back onto watering. Then scroll down and copy these lines here. Then back in the chopping script, in the onExit method, just copy that last line there. Now that we've completed the script, just select the watering state and assign the hit component collision shape. So just choose this option here and click OK. Then head over to test scene, select 2D and just run the current scene. Choose the watering can and then just hit with the left mouse button. And we can see now we've got that working. We've got down, up, right and left. And then let's go to the crop. And as you can see, that's now activated the water particles. Let's just stop that. Let's turn off the visible collision shapes. And then let's run the scene again. Turn on the watering can. And then let's water the crops. Now let's speed this up. So watering is now stopped. And we're now transitioning through the days. So we've gone to the next state. And as you can see in the output window, we've got the germination, vegetative, reproduction, and then the next state is maturity, and we're now showing the flowering particles. And now the crop is in harvest, so we can pick up that collectible. And as you can see, the inventory panel has now been updated, and we've collected the corn. So just stop that. Now that we've finished the corn scene, let's just rename this scene here and call it test scene crops. Just save that. And now let's begin to do the same for our tomato scene. So go scene, a new 2D scene, and rename this to tomato, and then save that scene. And just save it under scenes, objects and plants. And now I'm going to do the exact same thing as I've done for corn. So I will speed up the development and then stop it at points where there will be slight differences. So once you've set the horizontal and vertical frames, just increase this until we get to the seeds for the tomato. Then set the water crops for the hurt component, and then add child and attach a collision shape. And now that we've got the correct frame here, just increment that 1 so we get the germination sprite. Then for collision shape, create a new rectangle collision and just reposition the sprite. Then click on the tomato node and attach a script. And just save that script in the objects and plants folder. Then head back over to the corn scene, open up the corn script, and then just copy everything from inside this script. Go back to the tomato script and paste that in. Then let's change the variable here to be tomato, and then choose the tomato harvest scene. Then scroll down and then change that, and then just write tomato here and just paste it over the instance. And that will complete the script for the tomato, so everything has been reused here. So I'm just going to head back over to the assets folder, and in the objects folder just open up that basic plant sprite. And the frames will go 0, 1, 2, 3, 4, 5, 6, and 7. So we need to make a slight modification to the Tomato script because the growth state will not start at 1, 2, 3, and 4. We need to add an offset for the Tomato sprites. So in the Tomato script, add another variable under the growth state and call this start tomato frame offset and set this to 6. And then after growth state in the process method, just add the offset and that will finish the script. Head back over to the test scene crops and then in the plants folder, let's just drag the tomato onto our scene. Let's test the scene. Let's turn on the watering can and let's just speed the time up. First, I will water the corn and then I'll just wait for the first sprite to appear. And then let's water the tomatoes. Now we have the corn, let's collect that. And the inventory is updated. And then now let's collect the tomato. And the tomato is updated also in the inventory. Let's close that. So now that we've finished the corn and the tomato crop, there is one final thing to check because these are new scenes added to our game. We need to just check that Y sorting is correct and configured for these two new scenes. So we're not going to test this in this scene because this is just going to test the crops and the transition between the growth states. However, let's go back to our test scenes folder and let's just open the test scene tile map layer for Y sorting. And this is where we can test those scenes so that we're only testing Y sorting against all assets in the game. And this is one of the benefits of having test scenes is that we are testing everything in isolation. So add a new child, search for node 2D and just create that and just rename this to be crop. Then go to scenes objects plants folder and just add crop to our scene. So I've added the corn and then I'm just going to nest that under the crops node. And then I'll add another one and then let's add 2 tomato scenes as well. And this is as if we have just laid them out on top of the tilled dirt and we're going to cover that in the next tutorial. However, let's just resolve any Y sorting issues. And also on the test scene tile map layer Y sort, go to the UI folder and just drag on the game screen. And then we can interact with the day and night cycle. Let's run the test scene. Let's choose the watering can and just water this crop here. And then let's just speed up the clock. Now let's just walk over the sprite. So as we go from the top down, we're just walking straight over the corn. So we do need to fix Y sorting on here. So I'll just stop the scene. So head back over to the corn scene. And for corn, just scroll down and enable Y sort. Save that. Head back to the test scene tile map layer Y sort and just run that scene again. Let's just water the crop and then speed this up. And then let's see the effect of the player walking over the crop. So we still have an issue with Y sort. So just stop that and make sure the parent Y sort is already set for the scene. So just scroll down to that and then enable Y sort on here and run the test scene again. So water the crop, speed it up. Let's see the effect again on the player. And as you can see, Y sorting is now starting to work. Let's see what it's like here. And as you can see, when the sprite is in germination, it's slightly over the player. So we need to just make another adjustment on the player for Y sorting to fix this. We'll close that. So open the player scene. And if we just select animated sprite 2D, the position of the Y sort is here. And in the properties, there is no Y sort position, not like you have in the tile set. So if we just go back to the basic grass biome things in our tile set, and then just select the sunflower. If you look at rendering, there is a Y sort origin parameter. Now for sprites, this works slightly different. So on animated sprite 2D, the Y sort position is here. Let's just go to the inspector and in the offset, let's make an adjustment. I'll zoom in a little bit more and I'm going to adjust it so that it sits 3 pixels from the feet. Then in Animated Sprite 2D position, let's just reposition the sprite so that it sits back on the X-axis. Let's head back to the test scene tile map layer where I saw it and just run that scene. And then let's use the watering can and speed up the scene. And now let's just walk over the sprite so we can see that we've got an improvement there on our Y sort. And it's also better for the germination sprite as well. Let's just check our other sprites. So that's looking okay. And the flower and the mushrooms. So the adjustment to the player offset position on the Animated Sprite 2D has fixed that problem. So we just probably need to modify the small tree and the large tree. I'll make those adjustments and speed up the video. Close this. Then head back over to test scene tile map layer and just test this one more time. I'm now happy with the adjustments there on the large and small tree, and that's fixed Y sorting for our new crop assets. So this is a benefit of those test scenes. We've been able to make those adjustments across all the assets without affecting any other systems. Now that brings us to the end of this tutorial on how to grow crops using the day and night cycle. In the next tutorial, I will show you how to plant the crops on the tilled dirt tile map. I will show you how to use the player's tools to create various crop fields in your game. You will then be able to plant different crop types and, if you wish, to remove the crop fields and plant them in other places. So before we begin, just scroll down to the tile sets folder here and double click Game Tile Set, and this will load up the tile set here in this tab. And in a previous tutorial, we've loaded in the tilled dirt terrain. However, for our crop field, I'm going to use a different tilled dirt tile map, because if we click on this one and just zoom in, there is extra pixel space in between the edge and the actual tilled dirt. So head over to the Sproutlands Sprite Basic Pack, and in the Tile Sets folder, we want to choose the Tilled Dirt Wide version 2. So back in Assets, Game and Tile Sets, just drag the Tilled Dirt Wide version 2 and drop that into that folder. Then let's rename this and format it. And I'll call it Tilled Dirt Wide Crop Field. Now let's bring over the crop field into our tile set and just click No here. And as you can see, the distance between the tilled dirt and the edge of the pixels is slightly smaller. Then just drag the inspector up and just scroll down in our terrain set. So we've still got tilled dirt terrain here, but I'll leave that in there for now anyway. And we'll just add another one. And I'll call this Tilled Dirt Terrain Crop Field. And I'll just change this colour. Then let's set up these tiles. So let's just activate these tiles here and then click the first tile here. Then choose Select, choose First Tile, and in Terrains, choose Terrain Set 0 and then Terrain 3. So it's 0, 1, 2 and 3 for the tilled dirt terrain crop field. Then let's choose Paint, then choose Terrain Set 0 and then tilled dirt terrain crop field. And then let's just paint those terrains. So now the terrain has been painted, let's just head over to Scenes, Test, and open up the Test Scene Tile Map scene and select Tilled Dirt and then select in Terrains Tilled Dirt Terrain Crop Field, and then let's just paint that terrain to test it. and that's working okay. So we can begin creating our crop field component. So let's begin by creating another test scene. Go to Scenes, Test, and duplicate the test scene cropped scene. Just right click and click duplicate. And we'll call this test scene crop fields tilde dirt and just duplicate that. Let's open the scene and let's just rename the scene here. So we'll call that test scene crop fields tilde dirt as well and just save that. Then what we need to do is just to select the previous corn and tomato objects and just remove those. And we can just say OK to that and then just save the scene again. Then in the test scene, add another child node, search for node 2D and create that. Let's rename the node and call this crop fields. Then open the game tile map and add a child node and search for tile map layer and rename this to tilde soil. Then add another child node to the test scene and search for node, create and rename this to field cursor component. Then open the components folder under scenes and just drag this component into there and then save that scene. Then right click, attach a script and just save this as field cursor component. So just create that. Then let's just reposition our crop fields node and just move that above the player and then do the same with the field cursor component. Then in the field cursor component script, let's call class name field cursor component. Let's add some variables. So we'll do an export variable for grass tile map layer, which is type tile map layer. Add export for tilde soil tile map layer, which is also a tile map layer. And this will be our tile map layer grass and tilde soil here. Then export another variable, which is our terrain set, and set this to a default value of 0. Then export another variable, which is terrain type int with a default value of 1. Then create a non-ready variable, which is our player, and then use getTree, get first node in group, and then just use the string player. So let's open the player scene, and on the player node, go to the node option here, and then let's add a new group. Just click the plus button here, write player, and make this global, and then just click OK. Then head back over to the field cursor component script and let's add some more variables. So variable mouse position, which is vector2, for cell position, which is vector2i, then variable cell source ID, which is of type int, for local cell position, which is type vector2, and for distance, which is a float. Let's override the unhandled input event method and we'll say if event.isAction pressed and then check for the hit. So when the player uses the tilde tool, this event will be called and we'll check the tool manager. So tool manager dot selected tool, if that is equal to the tilde ground tool, then we'll call some other methods. So create another method called get cell under mouse and then get the mouse position and then use grass tile map layer and then the function get local mouse position. Then we'll set the cell position and then we'll get the grass tile map layer and use the dot local to map function and pass in the mouse position. Then we need to set the cell source ID. So with the grass tile map layer, we'll call get cell source ID and pass in the cell position. Then we'll set the local cell position. So using the grass tile map layer, use map to local function and again pass in the cell position. Then we'll set the distance and we'll get the player. And on global position, use the distance to function and use the local cell position. Then once we've set these variables, let's call another function to connect the terrain and call this add tilde soil cell. And we'll say if distance is less than 20 pixels and the cell source ID is not equal to -1, then get the tilde soil tile map layer and then set cells terrain connect and open square brackets and pass in the cell position. Then the second variable is terrain set, the third variable is terrain, and the fourth variable is true. And then back in the unhandled input method, just call the add tilled soil cell underneath get cell under mouse. So for debugging, I'm going to print some of these statements. So we'll print the mouse position, the cell position, and cell source ID. And then after that, let's also print the distance. So let's now connect the export variable. So click field cursor component and go back to the inspector. And we need to set the grass tile map layer. So we'll just click assign and choose grass here. And then choose the tilled soil layer here. And then for terrain set, this is 0 and the terrain is set to 1. So let's just open our tile set and then click the tilled soil and just open the game tile set resource and just scroll down. So the terrain set 0 has 4 terrains in it. That's 0, 1, 2, and 3. So we are currently targeting the tilled dirt terrain, which I added in an earlier tutorial. So what I'm going to do, I'll leave it on there for now. And as you can see, there is a gap between the edge and the pixels, as I mentioned earlier. So head back to the field cursor component and just leave these values. And let's test the scene. So just move the screen up and then choose the tilled tool. And let's just click on a water tile. I'll just bring this down a little bit more. And I've clicked the water tile and we can see the mouse position is here, the cell position, and the cell source ID is -1, which means we've not interacted with the grass tile. And the distance between the player and the mouse click is 237. So I'm just going to click here in the grass area and we have the mouse position, cell position, but the cell source ID is greater than -1, which means we've interacted with the grass tile. So we can check for that value and we have our distance here. So now I'm going to click at the player about here to generate our tilled dirt. So let's just do that. And then I can move the player around and start to create the tilled dirt map. And as you can see, I'm outputting the cell positions here. Now the original tilled dirt terrain has a large gap in it. So when we add the crops later, they don't sit very well. So what I'm going to show you is how we can just switch that terrain and then you can reuse this component in future to overlay many different terrains in your game. So let's close this window and it's very easy. We can just update the terrain here as long as the terrain set is still 0. We can always modify the terrain set if you wish, but I only have the 1. So go back to tilled soil and we need to set it to 3. So 0, 1, 2 and 3 again. So go back to field cursor component and just update this to be 3. And then I'm going to test the scene again. And this time, as you can see, the terrain is slightly bigger. And this is the terrain I want to actually position and plant my crops in. So let's close that. I'll reset this because I've only got the 1 terrain. So I'm just going to set the default to 3 here. And it's always set. Then when I use this component in other levels, the terrain's already set for me. I'm just going to remove those debug statements from the field cursor component. So let's allow the player to remove or delete a dirt tile. Go to Project, Project Settings, and we'll add a new input map, which allows that action. To add a new action, and call it Remove Dirt, and then Add, and then click the plus button here. And for listening for the input, hold the Control key down and then click with the left mouse button. So we get Control plus left mouse button and we should have a tick box here and click OK and then click Close and save that. Then back in the field cursor component script, before the isActionPressHit event, we'll say if event dot isActionPressRemoveDirt, then check if the tool manager selected tool is till ground. Then call get cell under mouse again, and then change this to be elif. Now we need to create a new function. So underneath add tile, let's create a new function and call this remove tilled soil cell and say if distance is less than 20, then tilled soil tile map layer dot set cells terrain connect, pass in the cell position in brackets, and then set terrain set to 0 terrain to -1 and true. Let's just copy that and just scroll back up to the event is action pressed, remove dirt, and then after get cell under mouse, we'll just call that method here. You may have noticed that I'm actually checking for the remove dirt action press first, and I've done this on purpose because in the input maps we are using the left mouse button in both remove dirt and hit. However, in remove dirt we have a dual key combo. We are checking for control and the left mouse button. If hit was checked first, it would always get called because it's only ever checking for left mouse button, and that action will always be picked up. So because I need to check for two inputs, it's better to check for them first, and then if control and left mouse button isn't pressed at the same time, then I'm only listening for the left mouse button. So if you have many input map combinations which all use a common key, you have to make sure you are checking the input order correctly. Let's now test the scene. So run the current scene, choose the till tool, and then let's just create some till dirt. Then hold down Control and click with the left mouse button, and as you can see, that's now deleting the terrain. Now we can start placing crops on our field. So add another child node and choose node and create that, and rename this to crops cursor component and drag that into our components folder and just save that. Then create and attach a script, and we'll just save it as crops cursor component into the components folder and create that. Then give it the class name crops cursor component. Then just reposition the node below field cursor component. Then create an export variable and get the tilled soil tile map layer, which is type tile map layer, and then create an onReady variable and call this player, which is type player, and then get the player from the first node in the group. So the next variable will be corn plant scene, and then preload the corn scene from the scenes objects and plants folder. And we'll do the same with the tomato plant scene. So just preload the tomato scene again from scenes, objects and plants folder. Then for the next variables, we want to get the mouse position, which is vector 2, the cell position, vector 2i, cell source ID, which is type int, local cell position, which is vector 2, and distance, which is float. And we've used these same variables in our field cursor component. Now head over to the field cursor component and copy the unhandled input code. Go back to cropped cursor component and just paste that underneath. Then go back to field cursor component and copy get cell under mouse and paste that underneath the unhandled input. However, now copy tilled soil tile map layer and paste that over the grass tile map layer, because this time we want to detect if we're clicking the tilled soil tile map layer, which will get us the correct cell source ID, and then we know we're interacting with that type of tile. Then we can apply and add our crop scene to that tile. So we're going to create two new methods here to replace remove tilled soil cell and the add tilled soil cell. So the first function we'll create is add crop. Then let's just create a new function called add crop and return void. Then in here, we just want to check if distance is less than 20. Then check the tool manager selected tool is equal to the plant corn tool. And then we'll get the corn plant scene and instantiate an instance of our corn scene. Then get the corn instance and set the global position to be the local cell position which we get from the tilled soil tile map layer. Then call getParent, find child, and we want to find the crop fields node and add the corn instance to the crop fields node. So this is the crops cursor component, and the parent will be the test scene node, and then we just search and find this crop fields node here, and then we can add the child. Then let's do another if statement and we want to save tool manager selected tool, and the tools is plant tomato. Then let's make an instance of our tomato scene. Then set the tomatoes instance global position to the local cell position, and then we can get the parent, find the child, and then add the child to the crop fields node here. Let's create another function, and we'll call this function remove crop, and again we'll just check if the distance is less than 20, and then we'll get all of the crop nodes from this field here, and then we'll use a for loop to search for a node inside of the crop nodes. And what we want to check if the node global position equals the local cell position which we've just detected. And if we find a node, then let's remove it from the scene. Now copy this function name and just paste it over the remove tilde soil cell. Now select the crops cursor component here, and let's assign the tile map to tilde soil. So click the assign button and then just choose tilde soil and click OK. And back in the crops cursor component, go back to the unhandled input method, and for event is action press hit, we want to check that the selected tool on hit is first either plant corn or is tool manager selected tool is tools plant tomato. So on hit, we're going to check if we've got either the plant corn or plant tomato tool selected, but when we want to remove the corn, we're actually just going to check if the till ground tool is selected. Now let's test the scene, and first choose the till tool, and let's just till the land. Then choose the plant corn crops tool, and then just plant the corn. And then let's choose the plant tomatoes and just plant the tomato crops. Now let's choose the watering can, and let's just water our crops. Then we can speed the game up. And now I can collect the harvest. And then if I click the till tool and hold Control down, I can now remove the crops field and plant a new field somewhere else. Now that brings us to the end of this tutorial on how to till the land and plant your crops. In the next tutorial, I will show you how to save the game so that you can save the state of the tilled land and the crops and other various elements in your game. I will show you how to create a save data component which can take different types of resources so that you can save your game. You can then reload those resources and then restore your game state. In a previous tutorial, I've shown you how to create crop fields and then plant your crops. However, when we close the scene and reload it, the crop fields are not persisted. So I will show you how to save that data to a game file. So let's begin by going to Scenes, Test Folder, and open the Test Scene Crop Fields till Dirt Test Scene. Then go to Scene, New Scene, and Other Node, and search for Node, and create that. And rename this node to Save Data Component. Then save this component in Scenes, Components, and then click Save. Then right click and attach a script. And we'll just call it Save Data Component Script and just save that in the Scenes and Components folder and click Create. And use class name Save Data Component. Then create an onReady variable called parent node, which is type node2d equals get parent as node2d. Then create an export variable called save data resource, which is type resource. And in this function, use add to group with the string save data component. The add group to function is the same as using the groups collection here. However, if we use add to group here, we can then use these components in other games and we don't have to keep remembering to add them to the group. So I'm just going to add it to the group here. Then click the root folder for your game and add a new folder and call it resources. Then set the folder color and we'll choose purple. Then in the resources folder, right click and choose New Resource and search for a resource and then create that and call this Node Data Resource. Then select Node Data Resource here and go to the inspector and click New GD Script, then right click Save As, and in the Resources folder call this Node Data Resource and save that, and this will just set the script for our resource. Open the script and then use class name Node Data Resource and say extends resource. Then for our first export variable, use global position, which is type vector2, then export variable node path, which is type node path, then at export variable parent node path, which is also type node path. Then for our first function, use underscore save data, pass in node, which is type node2d, and then we'll return a void. Then say global position equals node.global position, node path equals node.getPath, then void parent node equals node.getParent. Then check if parent node is not equal to null. Then we can say parent node path equals the parent node.getPath. And for the next function, call this load data and pass in window and just write pass for this. So the reason why I've underscored these methods at the beginning is just to show that I'm going to override them later, because we will derive from this class name and resource. Now head over to the scenes folder and in objects and plants, just open the corn scene, and then in the components folder, just drag the save data component into here. And as you can see, we need to set the resource. Now this resource here is a base resource. So I'm going to derive from this resource and then set that resource on this save data component. So back in the resources folder, right click, create a new resource, and then create that resource and call this scene data resource and just save that. Then just double click it to load it in here in the inspector, right click and choose new GD script, and then right click and save as, and then name the script scene data resource and click save. Then open the scene data resource script and use class name scene data resource, which extends node data resource. Then let's add an export variable called node name, which is type of string. Add another export variable, which is scene file path and is type of string. Then we'll create our first function, which is underscore save data and pass in node, which is type node2d, and return a void. And then we'll call the save data method and pass in node, which is the base class save data method, which is this, and say node name equals node.name and scene file path equals node.scene file path. Then for the next function, we can use load data and pass in window, returning void, and say void parent node, which is type node, or scene node, which is also type node. Then say if parent node path is not equal to null, then parent node equals window, get node or null, and then pass in that parent's path. Then say if node path is not equal to null, then variable scene file resource, which is of type resource, equals and then load, and pass in the scene file path. And scene node equals scene file resource dot instantiate as node2d. Then say if parent node not equal to null and scene node not equal to null, then the scene node dot global position equals global position. Then parent node dot add child, and then add the scene node, and just update these two nodes to be node2d. So we'll use this resource on the save data component where the scene node is of type 2d and is attached to a parent node, which is also of type 2d. Now back on the corn scene, choose save data component and then choose scene data TRES file and just drag that resource into the save data resource to set that. Then back in scenes objects plants, open up the tomato scene, then in the components folder, drag the save data resource onto the tomato scene, then head back to the resources folder and then choose the save data resource and just drag that onto that property here. Now head back to the test scene crop fields till date, and we need to create a component in here that will go through and save all of our nodes which have a save data component, and it will save the level in its own file. So on the test scene crop fields till date, right click and add a child node, and we'll just choose node option and create that. Then rename the node and call it save level data component. Then go to the components folder and just drag that into our components folder and then save that as its own scene. Then right click and attach a script and also save that script in the same folder. Then use class name save level data component. And for our first variable, write level scene name, which is type of string, then for save game data path, which is type of string, equals, and then use this exact string here. So we're going to create a game data folder, then save file name, which is another type of string, and use this exact string here as well. And there's a format operator in there. Then override the ready function, and then use add to group with the name save level data component. Then call getParent.name. So when the ready method is called, we will get this name from the parent. And this will allow us to use the scene level name to be part of the name for the data file. Now, before we continue writing this script, we need to create a new resource which will act as a container and contain all of the small resources from each of the nodes which contain a save data component. So head back to the resources folder and create a new resource and just create that and call this save game data resource and save that. Then double click it to open it here and then say new GD script and save as, and call the script save game data resource as well and click save. Then open the save game data resource script and use class name save game data resource, which extends resource, and then use an export variable which is save data nodes, which is an array of node data resource, and this is the base class resource which we are deriving from. So that completes that script. Now head back to save level data component script and let's continue with this. Create a new function called save node data and return void, and use nodes getTree.get nodes in group, and then pass in the string save data component. Then declare another variable at the top called game data resource, which is type of save game data resource. And back in the save node data method, we'll say game data resource equals save game data resource again, and then just new that resource. Then we can say if nodes is not equal to null, then for node in nodes, and if node is a save data component, then create a variable save data resource, which is of type node data resource equals node dot save data. And we can just say node is of type save data component here. Then create another variable and call this save final resource equals save data resource, and then duplicate that. Then get the game data resource dot save data nodes and append it with the save final resource. Now let's create another function, and we'll call this save game and return a type of void and say if not directory access dot directory exists absolute, and pass in the save game data path. Then get the directory access class and use make directory absolute, and then pass in the save game data path again. So we are just checking if the directory exists, and if it doesn't, we'll make the game data directory. Then say var level save file name equals save file name and then level scene name. So it will use this format, get the level scene name, and then format and create us the correct file name. Then after this, call save node data and say variable result, which is of type int, equals, then use the resource saver class dot save, and then pass in the game data resource, the save game data path, plus the level save file name. Then use a print debug statement and we'll just output that save result. Then for the next method, call this function load game, which is also a return type of void. Let's declare a variable level save file name equals save file name and then the level C name. Then variable save game path equals save game data path plus level save file name. Then say if not file access dot file exists and pass in the save game path, then we can return. We can also just make these strings as well, and then back in save game make that type of string. Then back in load game, we'll say game data resource equals resource loader and dot load, and then pass in save game path. Then say if game data resource equals null, then return again. Then say var root node, which is a type of window, equals get tree and dot root. Then say var resource in game data resource dot save data nodes. Then if resource is of type resource, and if resource is node data resource, then resource.load data and pass in root node. This script is now complete, so let's head over to our scripts folder and inside globals, create a new script and call this save game manager and create that. And then open the script, then go to project settings, and in globals, let's add our save game manager script. To go to scripts, globals, choose save game manager and open that, and then add the script and then close. And then back in project and project settings, go to input map and add a new action and call this save game. Let's add that action and click the plus button, and for the input, use the P key for persist and then click OK. Then click close. Then back in our save game manager script, let's create some functions, and the first one will be save game, which is a type of void, or save level data component, which is type of save level data component, equals get tree dot get first node in group, and then use the string save level data component. Then say if save level data component is not equal to null, then save level data component dot save game. Then for the next function, call this load game, then copy everything from save game, but on line 15, we'll change this to be load game. Then, just above save game, let's override the unhandled input event and say if event.isAction pressed and then use the save game input event, then call our save game function. The next step is to create a special test scene save data node so that for test scenes, we save data slightly different than for the main game. And this will allow us to now test the save level data components and the individual save data components for the nodes as well. So back on test scene crop fields till date scene, right click and add another child node and just choose node and create that and rename this to be test scene save data manager component. And then back in the scenes and components folder, let's just drag that scene into that folder and then save that scene as a component. Then let's open the scene and right click and attach a script and save that as test scene save data manager component script and then create that. And in this script, use class name test scene save data manager component. Then for the first function, override the ready method and just use pass for now. And for the second method, use function load test scene. Then use the save game manager and call the function load game. Then back in the ready method, use call deferred and pass in the string load test scene. So we are using call deferred because we just need to make sure the save level data component and the save data components have been loaded in the scene tree first. Now head back to the test scene and just move these to the top, just to organise that a little bit better. Then back in the Scenes and Components folder, just open the Save Data component script, and let's add another function here. So we'll say function underscore save data, and we'll return a type of resource. Then say if parent node equals null, then return null. Then if save data resource equals null, then push error and output the save data resource and the parent node.name, which is causing the error. And this will just check if we set up a save data component correctly with the parent node and the resource, so we can catch that here. Then use save data resource dot save data and pass in parent node. Then return save data resource. So that completes the script. So go back to the test scene, and in the 2D view, let's just go to Scenes, Objects and Plants, and just drop the corn scene onto our test scene. So before we test the scene, just head back over to the save level data component, and for save game data path, I'm using the user path. So just check the Godot documentation for file paths, and just check which directory your user path will be. I'll leave this link in the description below. So we can now go and test the scene. Run the current scene. I'll just move this window up so we can view the output window. Then press the P key on the keyboard, and in the output window we have a save result of 0. So this has successfully saved the game data. Then head over to your game data location. So in the app data folder here under roaming and Godot, in the app user data folder, I have a game folder for my game, and then this contains my game files. I've created my own game data folder, so I'll go into there. I've got the save game data file, and that's the name of the test scene which I'm saving. So I'll open that, and I can see in that file, I've got my corn scene, and it's been added to the save data nodes array. So now that we're saving the corn scene and the plant scene, let's actually now save the till-dirt tile map to the file as well, so that when we load this scene, we get something similar to this. So back on test scene crop fields, just remove that corn scene, because we create our scenes dynamically with the till-dirt. Head to the resources folder and create a new resource. Just select that and create that, and call it tile map layer data resource, and just click save. Then back in the resources folder, right click, create a new script, and create a GD script which is tile map underscore layer data resource, and create that. Then double click the tile map layer data resource file, and in the TRES file when it loads, just drag and drop the tile map layer data resource script onto the script property. Then double click the script, and let's use class name tile map layer data resource, and then extend node data resource. And for the first export variable, use tile map layer uCells, which is an array of vector2i. Then the next export variable is the terrain set, and we'll set that to a default value of 0. Then another export variable, which is the terrain, and we'll use a default value of 3. Then for the first function, let's use underscore save data and pass in node and return void. Then say super underscore save data and pass in the node. So this will call the save data method of node data resource. Then for the next variable, say tile map layer, which is of type tile map layer, and then we'll cast the node as a tile map layer. For the next variable, we'll say cells, which is an array type of vector2i, and we'll get the tile map layer and the used cells. Then we'll set tile map layer uCells equals cells equals cells. And for the next function, we will use underscore load data and pass in window and return void. Then for scene node equals window dot get node or null, and then pass in node path. Then say if scene node is not equal to null, then for tile map layer equals scene node as tile map layer. Then tile map layer dot set cells terrain connect, and then pass in tile map layer uCells terrain set our terrain and the last parameter is true. Now that completes the script. So go back into test scene crop fields, and under game tile map and tilled soil, let's then grab our save data component and get that scene and drop it onto tilled soil. Then go back to the resources folder and get the tile map layer data resource TRES file and drop that onto the save data resource property. So let's go to the test scene, and back in the app data folder, under the game and the game data, just remove the old file as we've made some changes, and then let's run the test scene. Now let's just create a crop field, and let's then plant the corn and plant some tomatoes. Then I'll press the P key. Then back in the game data folder, let's open that file. And as you can see, it's creating these resources here. So we've got the node data resource, the tile map layer data resource, the scene data resource, and the save game data resource. And it's got all of the properties from each of the resources. The scene data resource and the tile map layer data resource derive from node data resource. And that's why we've still got global position, node path, and parent node path in all of the resources. So we are reusing certain properties, which makes it more efficient when creating the resources to save data. If we scroll down, all of the save data component nodes and the resources are saved in an array, which we call back later, and that's the save data nodes. Now I'll just close the test scene and let's run it again. And as you can see, it's persisted that crop field. I will now set up the test scene again and create a new crop field, and then add some breakpoints in the code and explain how the save level data component and save data components work. I am now ready to press the P key on the keyboard to save the data file, and I will step through the breakpoints to explain the code in a little more detail. When the save game action is pressed, we'll go into save game, and then we check if our scene has a save level data component. Then we grab the save level data component, and then we just go into there and save the game from there. Then using directory access, we check if the directory exists first, and the game path will be the user path, which is defined in Godot. Then we create the level save file name, which is save underscore the level name underscore game and data. Then we go and save the node data itself. So from the scene tree, we get all of the nodes which have the group save data component, and then we bring those nodes into a collection and then create a new instance of the save game data resource, which is an array of resources. We then go into the save data component method and then get the resource from the save data component. And then inside the resource, which is attached to the save data component, we then call save data on the resource. So in this instance, we've got this save data component here, which is the tile map layer data resource. And what we can do is then set those variables and get the cells from the tile map layer and then set them on the resource. Once they've been set on the resource, we can return from the resource and then add it to the game data resource save data nodes collection. Then as we go through the next save data component, we can go into the save data there and then go into the resource of that component. And this one is the scene data resource. So we can actually check what the name of that is. And this is one of the corn scenes. So we get the scene file path, and if we just check the resource, which is here, so if we just drag this on, you can then click this object to inspect it further, and we can see the information which is now inside of this parameter here. And just open this up and we can see that the node name is corn. It's automatically set the scene file path, and in the node data resource, which is the base class, the global position node path and parent node path has been set. So if we look at this, you can see that the parent node path is crop fields. Let's just collapse this a little bit more and we'll just return from that. So I can just keep cycling through those nodes and return them. And it's going to save all of the data nodes in the level scene. And as you can see, it's just going through the collection. And then when it's come out of there, we then save the game data resource, which is the array of all the resources which have now got properties set. And then we check the result and it's 0. So it successfully saves the game file. Now I will step through how the load mechanism works. So I'll close the scene and just run the test scene again. This time round, we are going through the load test scene method of the test scene save data manager. Now this is a special component just for test scenes to allow loading game data that was saved only for test scenes. In a future tutorial, I will show you how to load using the save game manager from a main menu. So just step into that method and then we do the same thing here. We just get the save level data component and then we load the game. So we build up that level save file name and then we see if that file exists. If the file exists, we have some information in there to help us load those resources again. So we load the game data resource, which is the array collection of all the resources. Then we get the trees root node and start to go through the resources inside of the game data resource collection. Then in the resource, we can then call the load data function. So if we just step through that load data function, we can see that the first resource it's found is the tile map layer. And the load data will then find the tile map layer that's associated with it and then start to rebuild and attach the properties for that specific node. So for tile map layer, we need the tile map layer use cells and the terrain set and the terrain. So what it does is that it grabs the tile map layer and then sets the terrains again. Then we go back through the collection again. So let's see what the next resource is. So if we just step into load data, the next resource is the scene data resource. So we just check the properties. So yeah, we do have a parent node path. So let's set that. And then we do have a node path. So what we can then do is load the scene from that path. So we grab the coin scene and then we create the coin scene by using instantiate. And then what we need to do is to then attach the scene to the parent. So the parent node path is crop fields. And then we get the position that we saved and then reset the position of the new scene we've just created. And then we can just reattach it to the parent node, which is crop fields. Then we can go through again. So the scene data resource is responsible for just creating those scenes on load. And then we can just go through that method. So in this instance, it's a crop fields node and it will just create those. So let's just keep stepping through and then F12 to continue. I'll close this window. And that is how we are saving and loading data using the save data component and resources. Now that brings us to the end of this tutorial on how to create save data components with custom resources to allow you to dynamically save data for your game. As you can see, those reusable components can be attached to different scene types, and if you derive from the resources, you can save different variables. I will show you how to make your player interact with another character in your game and also create a shader so that you can replace the colours in the sprite and make modifications without having to repaint your sprites. You will also create an interactable component so that you can reuse this in other areas of your game. So let's begin. Just head to the scenes folder, in characters folder, add a new folder and call this guide, click OK. And then go new 2D scene and rename this to guide and just save that scene in scenes, characters and guide folder and then just save that. And for the guide, we won't use a character body 2D because the player will just interact with the guide so that we can show the dialogue balloon. So I'll add another child node to guide and search for animated sprite 2D, create that. And then in the 2D view, go to sprite frames and new sprite frames, click that. And for the default animation, let's rename that to idle and set this to be auto load. Then open the sprite frames and choose basic character sprites and click open. Let's zoom in and choose the top two here. The horizontal parameter and vertical parameter is already set. For this, click add two frames and let's just play that and leave looping on and just turn frames per second down to 3. So I'm using the same character sprite for the player as I'm using for the guide. So let's replace some of the colours in the sprite for the guide so that you can differentiate between the player character and the guide character. So on Animated Sprite 2D in the inspector, let's scroll down until we get to material, create a new shader material, and then for shader, click the empty option and choose new shader and leave type as shader, mode as canvas item, and we'll call this replace color.gd shader and create that. Then open the shader and we can delete this part here because we don't need that method and we don't need the vertex method. We will only use the fragment method because we're just going to modify the color. So let's begin writing some shader code to replace these two colors in our sprite. So this part here and this outline here. So after shader type canvas item, use uniform, vector 4, original color 0, and source color. And for the second color, use uniform vector 4, original 1, and this is also a source color. For the third parameter, use uniform vector 4, replace 0, and source color. And for the fourth parameter, use uniform vector 4, replace 1, and source color as well. Then back in the shader material, let's just set these shader parameters. So for the original 0, just click that, and then click the color dropper here, and zoom in and just click the outline. And then for the next color, choose the character color here in the middle. Then for the outline, let's replace that color. So we'll just choose something different for now. And then for the color to replace original 1, we'll just pop this color in for now as well. Then in the fragment function, use vector 4, color equals texture, pass in texture, and then the UV. And then say if distance, which is the color at that UV, original 0, is less than or equal to 0.1, then replace the color. If it's not, then just assign the color from the texture back. So we say color equals and then color here, and just put our semicolons in. And as you can see, for the original color 0, we are now replacing it with the replace 0. Let's just improve this script a little bit more. Use a constant float and say precision equals 0.1 and just replace that there. Now we need to handle the second color. So we'll modify this a little further so we can handle an array of colors. So I'm going to create a new function and call it vec or replace underscore color and pass in the color. Then I'll use vector 4 original colors equals vector 4 again, and then pass in original 0 and then original 1. Then create an array to hold the replace colors, array size 2 with replace 0 and replace 1. Then create a for loop and say integer I equals 0, and if I is less than array size, which is 2, I plus plus. Then copy this if statement and just paste that in there. Then copy original colors and just put I in there, and then copy replace colors and just put I in there as well, and just make that. Then after the for loop, just return color, and then back in the fragment function, we can just say color is the function replace color, texture, and then pass texture and UV. And then if we look at our sprite, we can see that we are now replacing both of those colors. So it's now possible to modify the shader further and add more original colors and more replace colors. so that if you want to use the same sprite but add more modifications, it will be possible using this type of shader. So now that the shader is complete, head over to the Scenes and Components folder and just scroll down until you see the interactable component and just drag that onto our guide. Then on the interactable component, just right click, add a child node and search for collision shape 2D. And then for the shape, just click new circle shape and just make this a lot wider so that the player can enter this area here. We have made the interactable component in a previous tutorial, so we've already configured the collision layers to interact with the player and fire the signals. When the player walks in the area, we want to show a sprite here with the letter E in it to show the player that they need to press that key on the keyboard to begin the dialogue. So go to Scene, New Scene, and then choose User Interface Scene. And then for the control, call this Interactable Label Component. Then save that scene and go to Scenes, Components, and save it as Interactable Label Component Scene. Add another child node and search for Texture Rect. Then in the texture property, choose New Atlas Texture and open that. Then head back up to Assets, UI, and Basic UI Sprites and drag that into the Atlas property. Then click Edit Region, and with Auto Slice selected, in this area here, just zoom in and choose this option here. Then click Close. Then add another child node and search for Label. In the text, use capital E, and then scroll down until we have fonts here. Then quick load and choose ZX Palm variation here and just open that. Let's zoom in, and for our font size, choose 8. Then click back on Texture Rect and let's just resize this. So scroll back up, and for transform size, resize this to be 18 by 18. Then click back on the interactable label component control and just zoom out. And then for the anchor points, just choose top left and then zoom in. Then for size, choose 18 by 18. Then click on label and scroll down to size and make the width 18. And then just make Y 18 as well. And then scroll up. And for horizontal alignment, choose center. Then scroll back down. And for size, let's just reduce the size. And then for position on the Y axis, let's just reposition that here. And that finishes our interactable label. Now head over to the guide and then go to Scenes, Components folder and drag the interactable label component onto our scene. So I'm just going to reposition the animated sprite 2D and then reposition the interactable component as well. And then the interactable label component will just put about here. And that's complete. So click the guide scene and let's right click and attach a script, and we'll just save the guide script in the characters and guide folder. So I'll create that. In the guide script, let's just create our first interactable component on ready variable, and then we'll do the same for the interactable label component too. Then override the ready method and then get the interactable component and register the interactable activated signal and connect that. Then we will create a function called onInteractableActivated, which is a return type of void, and then we can get the interactable label component and then just display the label when the player is in the area. Then back in the ready method, get the interactable component and register the interactable deactivated signal and connect that. Then create another function called onInteractableDeactivated, return type void, then get the interactable label component and hide it. Then back in the ready method, call interactable component and hide that by default as the guide enters the scene tree. Now head over to Scenes and Test folder and duplicate the test scene game screen UI. So I'll duplicate that, but call it test scene guide dialog, and then just duplicate that. Then open the test scene and then rename this to be test scene guide dialog and then save that. And then back in the guide script, just copy interactable label component and paste that over interactable component hide. Then go to 2D scene and then let's run this current scene. And as you can see, we've got our player here and the guide here. So let's just move towards the guide and we can see that we've now interacted with the guide and we have now an indicator here so that the player knows to press the E key. And that brings us to the end of this tutorial on how to create a shader to replace colours inside of other sprites. We have also created an interactable component so the player can interact with other characters and show information on how to respond. In the next tutorial, I will show you how to create a dialogue balloon so that you can communicate with the character. I will show you how to create your own custom dialogue balloon, complete with dialogue scripts. You can interact with other characters so that you can then show the dialogue to your player and also take some actions. So to create our dialogue balloon and scripts, I'm going to use a plugin by Nathan Horde. So head over to the asset library and search for Dialogue Manager and just open up this manager here and we will download and install that into our project. So click download and then install the add-on and then just click OK. Then in the root folder, create a new folder and call this dialogue and then click OK. Then right click the folder and set the folder color to teal. Then head over to project settings, plugins, and just enable the dialogue manager and click close. And now let's head back over to the add-ons folder and just expand the dialogue manager. And in example balloon, copy the example balloon script and the scene and just say move and duplicate to, and then just choose your dialogue folder and then choose copy. Then rename this scene to game dialogue balloon and rename this script to base game dialogue balloon. Then open the base game dialogue balloon script and rename the class to base game dialogue balloon. Then open the game dialogue balloon scene and on the example balloon rename this to game dialogue balloon and then open the script and just detach that. Then create a new script on the game dialogue balloon and just call it game dialogue balloon.gd and create that. Then open that script and extend from base game dialogue balloon. And that sets up the game dialogue balloon with the right script. Now let's head over to the 2D view. And before we style this balloon, let's go back to our dialogue folder and create a conversational script. So create a new folder and call this conversations and click OK. So open the conversations folder, then choose the dialogue option here and click new and then call this file guide, OK, and it will create you a guide.dialog script. Now just rename this to say start and that's the entry point of the script. And then to start again, we just copy that and just paste that here. Now we will use this default script to help style the dialogue and then we will modify this script for our own custom conversation. So head back over to scenes and in characters and the guide folder, open the guide scene and then just open that script here. Then we need to add a new input map. So go to project settings and in input map, add a new action called show dialogue and add that. And then for the plus button, press the E key and then OK and click close. Then in the guide script at the top, save our balloon scene equals and then use preload and then choose dialogue, game dialogue balloon scene. And then let's create a new function and override the unhandled input event and then say if event dot is action pressed show dialogue, then var balloon, which is type base game dialogue balloon, equals the balloon scene, then instantiate. Then use getTree dot current scene, add child, and then add the balloon. And say balloon dot start, and then load, and then use the guide dot dialog script, then comma and the string start. So we head back to the dialogue. We are going to start this script here and pass in the start function. So we start at this point here. Let's go back to the guide script. Now let's pop a breakpoint on line 24, and this is where we create the balloon scene. Then go to Scenes, Test folder, and just open the Test Scene Guide dialog, and then let's run this scene. Now press the E key on the keyboard, and we can see that this event is now called, and we are going to create the balloon scene and load the guide dialog. So let's just F12 that to run, and we can see that the dialog has now loaded in the balloon. Press the spacebar, and we can start again. And if you go back to dialog, the start again calls the beginning of the dialog script. Let's go back to our game, press the spacebar again, and then let's just end that conversation. As you can see though, you can press the E key at any point, but you should only be allowed to show the dialog balloon once we are in range of the guide. So let's just solve that. So at the top of the guide script, add another variable called inRange, which is a type of bool, and then on interactable activated, set this to true, and on interactable deactivated, set this back to false. Then in the unhandled method, say if inRange, then let's check if the action is pressed. Just remove that breakpoint here. So now let's test the scene again, just run the current scene and press the E on the keyboard, and no balloon is showing. So let's move towards the guide. Now the on interactable is activated, and press the E key, and now we get the dialog. So head back to game dialog balloon scene, and we will now style our dialog balloon. Go to the dialog folder and right click and create new resource and search for theme and create that and call it dialog balloon theme and click save. And then click on balloon, scroll down to theme and just remove that. Then click quick load and choose dialog balloon theme and open that. Then double click the dialog balloon theme to load it. And let's now add a new style type. So let's click the plus button here and we'll style the panel to begin with. So search for panel and choose add type, and then choose this option here and click the plus button. This will just override the style, so click a new empty style and then choose new style box texture. Then open the style box texture, and then for the texture property, click and then create a new atlas texture. Open that, then go back to assets and UI folder and just bring in the basic UI sprites. Then edit region, then with auto slice selected, just zoom in and choose this option here. Click close. Then just collapse the atlas texture and scroll down to sub-region and click edit region. Then zoom in and choose pixel snap and just bring in the bars to frame our panel. Click close, and then the next thing to style is the dialog, and this derives from margin container. So back on our theme, let's add a new style type and search for margin container, and then add that type. Choose this option here, and then add for each of the items and use a margin of 10. And now let's resize the panel. Just scroll to the top, and for custom minimum size, choose 400 for X and 70 for Y, and then choose anchor center bottom. Then click on dialog node and then choose the anchor preset and choose full rep. Then click back on panel, and for transform and size, put 70 for Y and then anchor again to the bottom. And for position, choose 270 for Y. Then click on the responses node and scroll down to size and just reset that, and that will position it here. Then go to anchor preset and choose center. Then click on character label node and open the theme, and then let's add another type here and write character name text and then click add type. Then choose this option here, click the plus button and search for a rich text label and set that base type here. Then click back on the label here, just scroll down, and in type variation, let's edit that and write character name text and just accept that. Then back on the theme, for character name text, let's just zoom in And for normal font size, let's just click the plus button and change that to be 14 and enter. Then let's add another style type and write dialog text and then click add type. Choose this option here and add another base type and search for rich text label and then set that base type. Then choose dialog label node here and scroll down, and then for theme and type variation, just edit that and write dialog text and just accept that. Then back on the theme, for dialog text, click this option here and override the normal font size style and write 12. Now choose the response example node and then open the theme again and click add for a new style type and search for button and choose the button option and add that type. And choose this option here and scroll down to normal and click the plus button to override the style. Click empty and new style box texture, then open the texture, and for the texture property, choose new atlas texture and open that. And for the atlas, go back to assets and UI folder and bring over the basic UI sprites. Then click edit region, zoom out and choose auto slice, then zoom in and pick this option here. Select that and click close. Then collapse atlas texture and scroll down to sub-region and choose edit region. Then for snap mode, choose pixel snap, zoom in and just bring in the bars to frame the button. And once that's framed, click close. Then right click normal style, click copy, and then for press style, override the item, right click and paste. This will then paste the style from normal, but right click and say make unique recursive and click OK. Then open the press style and open the atlas texture and click edit region. Then choose auto slice and scroll in and choose this option here. Then click close. And then for sub-region, we don't need to configure it again because we've copied from the previous style. So click close. So right click the style for pressed, click copy, and then scroll to hover and override that item. Right click and paste, right click again and make unique recursive. Click OK, and then open the hover style. For texture, open the atlas texture and scroll down to edit region. Then for hover style, just scroll in and choose this option here. Then click close, and we don't need to edit sub-region again as that is now pre-configured. So right click the hover style, click copy, and for focus, override that style. Right click empty, paste the style, right click again, and make unique recursive, and OK. Now we don't need to do anything with the focus style, we'll just make a whole copy of hover. So right click the focus style and click copy, and then scroll up to disabled, override the item, right click empty and paste, right click again and choose make unique recursive and click OK. Now open the disable style and open the atlas texture and click edit region. With auto slice selected, choose this sprite here and click close. Now we have finished styling the custom balloon. Let's go back to test scene guide dialog and run that current scene and head over to our guide and press the E key. And you can see the dialog balloon has now been styled. Let's enter and we can now choose our options. I'll just end the conversation and close that window. And to create the emotes panel, which will contain the sprite of the character with the talking animation, let's create a new scene. So go scene, new scene, and then user interface. Right click, change type, and search for panel, and just change that type. Let's right click again and call this emotes panel. Then save the emotes panel and go to scenes, UI, and save the emotes panel scene in this folder. Then go to scenes, UI folder, and open the game UI theme. And we will use this dark wood panel on the emotes panel. So click on emotes panel and scroll down to theme, click empty, then quick load and choose game UI theme. Then for type variation, edit this and type dark wood panel and just accept that. Then add another child node and search for control, and then create that node, and rename this to emote. Then for custom minimum size, choose 40 and 40. Then click back on the emotes panel and choose top left. And for custom minimum size, choose 50 and 50. And then we'll scroll in. Then click on control and add another child node and search for animated sprite 2D. Then click new sprite frames and open that. Rename the default animation to emote 1 idle, click add frames, and then go into the assets folder and in UI folder, choose emote PNG and click open. Change horizontal to 5 and vertical to 15. Then zoom in and choose the first frame and add frame. Then for this animation, choose auto load and leave it on looping. I will only add 7 animations and the number is the position of the animation in the sprite sheet. So choose add animation and call this emote 2 smile, add frames, choose emotes, open, and then choose the second frames. And this is the position 2 vertically in the sprite sheet. Add 2 frames, add another animation, call this emote 3 ear wave, add frames, choose emotes and open, and choose these 5 frames, add frames, add a new animation, and call this emote 4 blink, add frames, choose emotes and open. And this is the 4th one down, add frames, and call this emote 6 love kiss, add frames, emotes, open, and then count from the top. So we've got 1, 2, 3, 4, 5, and 6. So choose this one here, add 2 frames, add a new animation, and call this emote 7 excited. Click add frames, emotes, and open. And again, count from the top, which is this one here. Choose add 2 frames. And then for the last animation, call this emote 12 talking, add frames, choose emotes, open, and then count from the top. And then choose that 12th sprite, zoom in, and add these 2 frames. So now let's position the emote. Click on the emote control node and choose center. And then for animated sprite 2D, let's position this. So we'll say 20, and then for the y-axis, we can make that 22. And then on the emotes panel, right click, add a child and search for timer, and rename this to emote idle timer. Then change the wait time to 5 seconds, and then turn on auto start. Then choose emotes panel, right click, and attach a script, and save this script in the scenes in UI folder and click create. And grab the animated sprite 2D and create an onReady variable, and then get the emote idle timer and create an onReady variable for that as well. Then for the next variable, we want idle emotes, which is an array, and add these 4 strings. So we have emote 1 idle, emote 2 smile, emote 3 ear wave, and emote 4 blink. Then create and override the ready method and call the play function and pass in emote 1 idle to start. Then create another function called play emote with a variable called animation, which is type string and return type void. Then grab the animated sprite 2D, use the play function and pass in animation. Then back on the emote idle timer, in the inspector, click node and choose the timeout signal and then connect that. Then click connect to create the function, and in the function, declare variable index equals randi range and put a minimum value of 0 and a maximum value of 3. Then say var emote equals idle emotes and then pass in index. So every time this method is called, it will randomly get one of these strings from the idle emotes array. Then say animated sprite 2D and play the emote. So now that we've completed this script, let's now take the emotes panel and add it to our game dialog balloon. Head over to the 2D view and click on the dialog node and add another child. And search for HBox container and create that. Then place the VBox container inside of the HBox container. And then click on dialog, and for layout mode choose position. and just reset the size, and then set the X to be 400 and the Y to be 70. Then add a child node and search for HBox and choose HBox container and create that. Then drag the VBox container and place this inside of the HBox container. Then in the Scenes and UI folder, get the Emotes panel and drag that inside of the HBox container and just position this above the VBox container. Now just click the dialog node, and as you can see it is stretching and the Emotes panel is also stretched. To go back to the Emotes panel scene and select the Emotes panel node, and in the size settings just click this and choose horizontal alignment shrink begin, and for vertical alignment shrink begin too. Then save the scene and then go back to game dialog balloon, and you can see that now fixes that. Then click on VBox container and choose fill for horizontal alignment and shrink begin for vertical alignment. Then in the inspector, if you scroll down to container sizing, underneath horizontal property, choose the expander option, and this will then fix the layout for the VBox container. And now that we've resized the Emotes panel and VBox container, let's just check the HBox container, so this is okay, and then the dialog, so we can still see we've got this bar here. So just go to anchor preset and then just choose full rate, and that will resize that again. So head back over to the test scene guide dialog and let's test our scene again. So just walk up to the guide, press the E key, and we can see now that we've got this all formatted nicely. So just end that conversation and let's close the window. And the next thing to do is just head up to the dialog folder and in conversations, load the guide dialog, and let's replace this text with our own custom dialog. Let's remove all of the text and type Marlowe, then open brackets, and then open brackets again, and type hi with a pipe, hello, another pipe, and howdy, and then put nice to meet you. So the text in the brackets is separated into 3 tokens, and every time the script loads, it will choose one of these. So it will either be hi, hello, or howdy, and it's just chosen at random. And for the next sentence, we can say welcome to your new farm, and then I'll just finish the conversation. As you can see, the cows and chickens are hungry, and you need to grow some crops to feed them. So here are some seeds to grow some crops. And then what we're going to do here is call a method so that the guide character Marlowe gives the crop seeds to your player and enables the buttons on the toolbar. So head to the scripts folder and in the globals folder, create a new script and call the script Game Dialog Manager and create that. Now load the script and go to Project, Project Settings, Globals, and then add the global script. So it's in the script folders under Globals and Game Dialog Manager, and click Open. Then add the script and click Close. And then in the Game Dialog Manager script, create a new signal called Give Crop Seeds, and then create a function called Action Give Crop Seeds and return a void. Then grab the signal and emit. And then back in the dialog script, after the last sentence, say do Game Dialog Manager dot action give crop seeds, and this will call that method on that global script. So when this method is called, let's enable the tools on the toolbar. So go to Scenes in UI and go to the Tools panel script and override the ready method. And in the 2D scene, when the tool panel first loads, these 4 buttons will be disabled. When the player interacts with the guide and gets the crop seeds, we will then enable these buttons. So let's just disable these buttons first. So we'll get the tilling tool and disable that, and also turn off the mouse focus mode. So I've now disabled the button and focus mode for the tool tilling button, the watering can, the tool corn, and the tool tomato. Then go to the scripts folder and globals folder and open the tool manager script and add a new signal called enable tool and pass in a parameter which is tool and is type data types dot tools. Then create a new function called enable tool button and pass in the tool variable, and then get the signal and emit and pass the tool. Then head back to the Tools panel script, and in the onReady function, get the tool manager and then call enable tool signal and connect that signal. So then create a new function called onEnable tool button, and the parameter will be tool and it's the data types.tool. Then say if tool equals data types.tools.tillGround, then get the tool tilling button and then set disabled back to false to enable it, and then set the focus mode to control.focus_all so that it receives focus. Then I'll do the same for the other buttons. So I'll say elif and that completes the elif statement for all of the buttons that will be disabled and then will re-enable when we receive the crop seeds. Now go to Scenes, Characters, and in the Guide folder, open the Guide script, and in the Ready function, get the Game Dialog Manager and connect the Give Crop Seeds signal. We'll call this function onGiveCropSeeds, and then at the bottom, let's declare that method and return void. Then we can grab the Tool Manager and call Enable Tool Button, and then enable the buttons. So the first tool I'll pass in is Till Ground. For the second one, it's Water Crops, then Plant Corn and Plant Tomato. So back on our test scene guide dialog, let's go to the 2D scene and let's run the current scene to test it. And as you can see, in the Tools panel, these buttons are currently disabled. So let's head over to our guide and press the E key. So we'll go through the script, and then on our last sentence, here are some seeds to grow some crops. Once we hit the spacebar again, it will then call that method and should re-enable the tool buttons. So let's just press the spacebar. And as you can see now, our tool buttons are enabled. But let's just make a slight alteration to our guide conversation. So go to the guide dialog in dialog conversations and just remove this line here. And let's add some options. So I'll say hyphen take crop seeds. Then I'll use the name Timo for our player character. And the response from Timo is, yeah, I can grow some crops. So if the player chooses this option, then let's call the action give crop seeds and enable the tools. And the other option is the player can say no, and then Timo will respond, I'm not ready to grow my farm yet, so the buttons will stay disabled. So now let's test this script. Head over to the 2D view and run current scene. And as you can see, the Tools panel UI has the disabled buttons. Let's walk over to our guide and press the E key. And let's go through the conversation. So now we have these two options. And for the first run, let's just say no, I don't want them. And Timo responds, I'm not ready to grow my farm yet. So press the spacebar. Let's walk away from the character, and then the player can approach the guide again. And let's go through the conversation one more time. And this time round, let's take crop seeds. And Timo responds, yeah, I can grow crops. And now the buttons have been enabled. Let's stop that. So now that we've created an emotes panel UI, let's just add that to our game screen. So go to Scenes, UI, and open the game screen, and add a child to margin container, and search for VBox container, and create that. Then position that above the margin container. Then back in the Scenes and UI folder, get the emotes panel, and place that inside of the VBox container. Then get the inventory panel, and put that also in the VBox container. Then scroll in, and on the VBox container, choose horizontal alignment, shrink begin, and vertical alignment, shrink begin too. Then zoom in more, and what we want to do is to center the inventory panel. So for the emotes panel, say horizontal alignment, shrink center, and then the inventory panel, choose this option and choose shrink center. And that will just adjust it to center both panels. Now head back over to the emotes panel and open the emotes panel script. So the emote idle timer will select an animation from the idle emotes every 5 seconds. So go back to the test scene guide dialog and just run this test scene. And this animation will change every 5 seconds. So if I go to the guide and press E, The animations here are also from the idle emotes array. But let's make a modification to the game dialog balloon script so that this animation is the talking animation. So head back up to the dialog folder and open the game dialog balloon, and then open the game dialog balloon script. Then select the emotes panel and drag, then hold Ctrl down and create an onReady variable for our emotes panel. Then once we've got this variable, open up the base dialog balloon script and then just scroll down and keep scrolling until you reach the start function. Then copy the function definition from here and go back to the game dialog balloon script. Then we are going to override that start function, so paste that into our script here. Then when the function is called, we need to call back down to the base class, so write super and then write start for the function and pass in these variables. Then get the emotes panel and call the function play emote, and then in the emotes panel animated sprite 2D, we will use the emote 12 talking animation. So just write that here. Then we will override another method. So go back to base game dialog balloon, and after the start method, copy the next function definition. Then go back to game dialog balloon and just paste that here. Then write super.next and pass in next ID. Then call the emotes panel and call play emote and pass in the talking animation. So that completes the script. Now head back to test scene guide dialog and let's run our test scene. So we have our emote idols array here, which is switching between those different animations. But let's now approach our guide and press the E key. And as you can see, this is the talking animation. And if we wait long enough, it will switch back to the emote idols array. Then press the spacebar and it will switch again to the talking animation. Then it switches back to another animation from the emotes idle array and then the spacebar again. And as you can see, it will keep talking as you press the spacebar. Now there's just a slight improvement for our test scenes. So go to scenes and test and just open test scene crop fields till dirt and run that test scene. Now because we are disabling the buttons in the tools panel, we ideally want these enabled when we run a test scene. To close this, head to the components folder, then go scene, new scene, other node and choose node and click create and rename this to test scene enable tool buttons component and then save the component, and in the scenes components folder just save our new test scene enable tool buttons. Attach a script and we'll just call it test scene enable tool buttons component and create that. Then in the script, override the ready method and just pass for now. Then create another function and call it enable tool buttons. Then grab the tool manager and call enable tool button and pass in the till ground tool. And then do the rest for the other disabled tools. Then back in the ready method, they call deferred, open quotes, and pass that function name. So we're using call deferred so that we just make sure that this is called after the buttons are already disabled. Let's save that. Let's go back to our test scene crop fields till dirt, and then let's add our test scene enable tool buttons to our test scene. Let's just move that to the top, and then let's run our test scene. And as you can see, the buttons are now enabled, so let's just test that. Now that brings us to the end of this tutorial on how to create your own custom dialog balloon complete with dialog scripts. You can interact with the guide and then choose some options which call some actions in your game. I will show you how to use the collectibles in your inventory and give them to a chest in your game to receive rewards. So head over to Scenes, Objects, and let's create a new folder in our Objects folder and call this Chest. Click OK, and then create a new 2D scene, rename this and call this Chest. Then save our scene and go to the Scenes folder, Objects, Chest, and save that scene. Then right click Add Child Node and choose Animated Sprite 2D and create that node. Then head down to Sprite Frames property, click Empty and create new sprite frames, and then open the sprite frames. Then rename this animation to Chest Open, and then click Add Frames. Go to Assets, and then Game folder, Objects, and choose the chest PNG and click Open. Then set horizontal to 5 and vertical to 2, and then choose the sprites in this order, and then add those 5 frames. Then create a new animation and call this Chest Close. Click Add Frames, pick Chest PNG and click Open, and then zoom in and then choose the frames in this order and add those 5 frames. Let's just zoom in on our sprite and let's play that. So let's turn looping off and then go to Chest Close and turn looping off as well. Let's add another animation and we will call this Default. Click Add Frames, choose Chest, click Open, zoom in and just choose this single frame here, and then click Auto Load. So when the scene is added to our scene tree, this is the sprite that will be displayed, and turn looping off as it's just a single sprite. Then head back to Scenes folder and Components, and then scroll down and add our interactable component to the chest. Then add a child to the interactable component and choose Collision Shape 2D, and for shape, choose New Circle Shape, and just make this a little bit wider so when the player interacts with this collision shape, we'll then show the interactable label. Then also back in the components folder, get the interactable label component and also add that to our scene. And then let's just move that and just position that roughly about here. And then open the interactable label component scene. Just choose the root node and scroll down, and in Z-index, increase this to 2. And we just want to make sure that when the label displays, it overlays all of the other objects in our scene. Then back in Chest, right click and add another child node and search for a marker and add a marker 2D and create that. Then for position, just grab the marker and just position it on the edge here. So this is where we will output the rewards when we add items to our chest, and we will create a circle around this marker position where the items will randomly be output. Now let's create a feed component, so go to Scene, New Scene, choose Other Node and search for Area 2D and create that. Then F2 and call this Feed Component and click Save and go into Scenes, Components and save the scene here. Then right click, choose Attach Script and create it as Feed Component Script and create that. Then scroll down and for the collision layer for Feed Component, in the layer properties, just open this and choose Object and then just turn off ground. And for mask, we need to add a new item. So go to Edit Layer Names, and for layer 8, we will call the layer Food and close that. And then select option 8 for the mask. And then in the Feed Component script, put class name, Feed Component, then signal, and pass in the area which is type Area 2D. Then back on Feed Component, in the inspector, choose the Node tab, and then select the area entered signal, and then click Connect, and then connect that signal. And then in that method, call Food Received, and then emit area. So that's complete, so head back to chest, and then get the feed component and add it to our chest. Go back to 2D view, and then right click, add child, and search for collision shape 2D and create that. And then for the shape, choose circle shape, and then let's just change the colour, and we can leave the size as it is. So right click on chest and choose attach script and save this as chest script and click create. So our first parameter is for balloon scene equals preload and choose game dialog balloon scene, then variable corn harvest scene and choose the corn harvest scene here, then preload the tomato harvest scene Then let's add an export variable, which is dialog start command, which is type string. Then export food drop height with a default value of 40. Then export reward output radius with a default value of 20. And then export output reward scenes, which is an array of packed scene. Then click and drag the interactable component and then hold Control and then add the interactable component as an onReady variable. Do the same for animated sprite 2D, also for feed component. Then click marker 2D and just rename this to reward marker, and then click and drag and add this as an onReady variable. And then get the interactable label component and add this as an onReady variable too. Then add variable in range, which is a bool, and then variable is chest open, which is also a bool as well. And then let's begin by creating a function and overriding the ready method. Let's grab the interactable component and register the signal interactable activated. So connect that. So let's say function on interactable activated and just return void for now. And then copy that method in our connect function here. And then when the player walks into the interactable area, we want to just say interactable label component and then show. And then we want to say the player is in range of the interactable area and just set that to true. So get the interactable component again and register the interactable deactivated signal. Let's connect that and say function on interactable deactivated and return void. And in this method, say interactable label component and then hide that, and then say in range equals false, and then just add the method to our connect function. Then back in the ready method, let's just hide our interactable label component when the scene loads. So let's create a test scene for our chest, go to scenes, test folder, and let's just open the test scene collectibles, and let's duplicate this scene and call it test scene objects and chest and duplicate that. Let's close that scene and open the test scene objects chest. Then in this scene, let's just rename that to test scene objects chest and then delete these nodes here and then go to scene UI and just attach the game screen and then save that scene. Then back in scenes objects and chest folder, let's just drag a chest onto our scene here, and then let's run the current scene. And with the player, let's approach the chest. So we get our notification icon here and press E on the keyboard. And nothing's happening because we need to register our event. Let's just close that. So head back over to chest and in the chest script, scroll down and override the unhandled input event. Then say if in range, then if event.isAction pressed and then choose show dialog, then get the interactable label component and hide that first. Then grab the animated sprite 2D and play the chest open animation. Then get the isChestOpen parameter and set that to true. Then we will create some dialog for the chest. Here, let's just test that. Let's go to test scene objects and chest and let's just run our test scene. So press E on the keyboard and the chest opens. Let's move away from the chest and the chest is not closing. So let's close the window and fix that. So back in on interactable deactivated, we should say if chest is open, then play the chest close animation. Then we can set is chest open back to false and then hide our label component and then set the in range back to false. Let's test the scene. So approach the chest, press E and the chest opens and let's move away from the chest and it now closes. So when we interact with the chest, let's show a dialog balloon and then communicate with the chest. So go back to unhandled input and say var balloon, which is type base game dialog balloon, and then get the balloon scene from here and then instantiate that. Then get tree and the current scene and add child and then pass in our balloon instance. Then call balloon.start, and then we'll load some dialog script here, and then pass in the parameter dialog start command, and we've declared that parameter here. So for this dialog script, I'm going to do something a little different, because when we place the chess on our game, we can have multiple chests. So I'm going to create 2 pasture boxes, one for the cows and one for the chickens. So when the dialog starts, we want slightly different dialog. Let's just scroll back down to here, and let's start to create a script file which will work with this. So head up to the dialog folder, and then select the conversations folder, and then choose the dialog option here at the top and click new here. Then open dialog and conversations to save our file here and call it chest, and click OK. So I'm just going to remove this default dialog from here, and then to start this section of dialog, I will call this start cow pasture box. Then I'll use pasture box, and then open square brackets again, and use these 3 tokens, hi, hello, and howdy, which are chosen at random every time the dialog loads. And then say your animals are hungry. Then pasture box again, and then ask the question, would you like to feed your cows? And then let's create those options. So if the player chooses yes, then Marlowe will respond, yeah, let's feed my cows. And then we can say no, and Marlowe will respond, no, I don't need to feed them, I have enough milk. So that's just a simple dialogue for the chest. And when the player presses yes, we will call a function here to perform some actions in our game. Now select all of the dialogue and copy it, and then paste it again. And this time we'll make some modifications for the chicken pasture box. So we'll call it start chicken pasture box. We can keep the first line and then just change this to say chickens. And then for the yes option, we can say, yeah, let's feed my chickens. And then for the no option, no, I don't need to feed them. I have enough eggs. So now this is complete. Let's go back to our chess scene and open the chess script. And in the balloon.start function, we can now load our script. So choose the chess.dialog script, and then let's head over to our test scene. Go to the 2D view, and let's just scroll in. Let's just reposition this chest here, and then go back to scenes, objects, and chest folder, and drag another chest onto our scene. Let's just rename these to cow pasture box, and then chicken pasture box. Then we need to set the dialog start command. Go back to dialog, and the start command is this here. So for the cow pasture box, just copy that and set that here. Go back to the dialog script and get the start command for chicken pasture box. Then click on the node, and let's just set the command here too. Now let's run the test scene. So let's approach this chest here and press the E key. So we can now see the balloon for this. And as we go through the dialog, let's just say yes for this. So would you like to feed your cows? Yes. Yeah, let's feed my cows. And then press the space bar. Let's just test that the dialog is different for this pasture box. So howdy, your animals are hungry. Would you like to feed your chickens? Say yes. And then let's feed my chickens. So that is now working. What we now need to do is for the player to collect the harvest collectibles and then give them to the pasture box, and that will then feed the animals. So go back to dialog, and we need to add an action after the yes option. So if we have a look at what we have done for guide, we've got the game dialog manager and an action here. So let's go to scripts, globals, and then game dialog manager, and then create a new signal called feed the animals, and then create another function which is action feed animals, and then call that signal and emit. Then head back to dialog, and in the chess dialog, in the yes option, write do game dialog manager dot action feed animals, and in the start chicken pasture box dialog, in the yes option, let's do the same. Then head back to chess and open the chess script, and in the ready function, get the game dialog manager and the signal feed the animals, and then let's connect that. Let's just scroll down, and after the unhandled input event, create a new function called onFeed the animals, and the return type is void. Then scroll up and add that to our connect function. Then scroll back down to onFeed the animals method and say if in range and pass, and then let's just create another function called trigger feed harvest, and we'll pass in the inventory item and a scene. So back at the top of the script, we are preloading the harvest scene and the tomato harvest scene. So we just scroll back down to onFeed the animals. We can then call this method, and for the first parameter set this to corn, and then corn harvest scene. Then back in trigger feed harvest method, let's first get hold of the inventory, then say if the inventory does not have the item, then just return from this method. And if it does have the item, let's carry on with the function. So then let's get the inventory item count for that specific inventory item type, and then create a for loop. And we can say for index in inventory item count, then create another variable, which is our harvest instance, equals the scene, which we are passing into the function, instantiate the scene as node2d. Then harvest instance dot global position equals vector2, which is the global position of the chest dot x, global position of the chest again dot y, minus the food drop height, which we have declared again at the top here. Then say get tree dot root dot add child, and then pass in the harvest instance. Then create another variable called target position equals the global position. Then another variable called time delay equals, and then call the randf range function. And for the first parameter, set this to 0.5, and the second parameter is 2.0. Then call await and get tree dot create a timer, pass in the time delay variable dot timeout signal, and now we are going to create a tween. So say for tween equals get tree dot create tween. Then say tween dot tween property and pass in the harvest instance. And the first property to interpolate will be position, and then pass in target position, and the duration is 1. Then tween dot tween property again, then harvest instance, then the property scale, then use vector2, and we'll say 0.5, 0.5 for a duration of 1 second. And then tween dot tween callback, harvest instance dot q3, but take off the parentheses here, and then that will q3 our node from the scene. So the tween here will interpolate these values one after another, so they are not called in parallel. We are calling these actions sequentially. And now we need to remove an item from the inventory. So go back to scripts and globals and open the inventory manager script, and let's add a new function called remove collectible and pass in the collectible name, and the return type is void. Then copy and paste this code here in the add collectible function and just paste that here, and then just change these values. So we want to say 0 for this one, and instead of plus equals 1 we want to say minus equals 1 to deduct it from the inventory, and then just click after the else statement and add another if statement here, and then tab that in. So as long as we still have items in the inventory, then we can remove the item. Let's just save that. Then just go back to the chest script and then call inventory manager dot remove collectible and then pass in inventory item. So we're now ready to test the scene. So head to the test scene objects chest scene and go to 2D view. And now I'm going to add some scenes to our test scene. So to test the pasture bots, I've just added the harvest collectibles directly to the scene. I am not worried about the interaction with the tile map to create the till date tile and then grow the crop, because the output is just the harvest collectible and then adding that into our pasture bot. So let's run this current scene and I will collect these first. So the crops have grown and the output is this harvest. So we have 2 corn and 2 tomato. Let's just approach the box, press the E key and go through the dialogue and choose yes. Now when I press the spacebar now, let's just see the animation with the tween. So we've got the corn, the tween is now performing and it is gone through the position of the tween, then the scale and then Q3'd. So let's move away from the pasture bots and let's do this again. Let's press the E key. So we've got 2 corn here. Let's press the space bar, say yes, and the animation is working, and then the scale and Q3. And then if you check the inventory, it's gone from 2 back to 0. So let's just add the update for our tomato. But when we feed the pasture bots, let's output milk for the cow pasture bots and then eggs for the chicken pasture bots. Let's close that. So head back to the chess scene and open the chess script. And to solve the issue with adding tomatoes, in the onFeed the animals method, use function trigger feed harvest with the string tomato and then pass in the tomato harvest scene, which has been declared at the top of the script. Now let's head to the 2D view for the chest. And when we feed the harvest items to the chest, they start about here and then they'll drop down into the chest. And we need to interact with our feed component and this collision here. So let's go back to the chest script, and at the top of the script, in the ready method, after we connect onFeed the animals, get our feed component, then get the food received signal and connect that. So let's scroll down, and at the bottom, let's create another method called onFood received and pass in the area and return type void. Then scroll up to the top and register that method in the feed component signal here. Then scroll back down and just say pass here for now, and then create a function called add reward scene and just put pass there. Then back in on food received, use call deferred, then add reward scene. Say for scene in output reward scenes, then say var reward scene is a type node2d equals scene dot instantiate. And then on this line, we need to calculate the random position for our award. Let's create another method, which is function get random position in circle, and we'll pass in the center point and a radius for the circle. Then say var angle equals randa function multiplied by tau, which is 2 times pi. Then var distance from center equals, and then use the square root function and then pass in the randf function and multiply that by the radius we are passing in. Then say var x, which is an integer, equals, and then get the center point and the x of that. Then add the random distance from the center, which we've just calculated, and then use cosine and pass in angle here. Then var y is integer equals center dot y plus the distance from center, which is again random, and then cosine and angle. Then let's put these 2 variables together and create a vector 2i and just pass in x and y and return that. Then back in the add reward scene function, say var reward position, which is type vector2 equals get random position in circle, then grab the reward marker, which is here, get the global position of that and pass in the reward output radius, then get the reward scene and set the global position to be the reward position, then get tree and get the root and then add the child and pass in the reward scene. So this is why we're using call deferred to make sure that the scene is added in the idle time. So now head back over to the test scene and choose the cow pasture bot and go to the 2D view. And we now have a parameter in here called output reward scenes. So just click that and then click add element, then go to objects, and in there we have the milk scene. So add the milk scene to the cow pasture bot. So when we then get the rewards, it will output the milk scene. Let's now click the chicken pasture box, and then for output reward scenes, just click that and add element, and then add the egg scene. Now click back on the chest scene and go to feed component and just check the collision layers. So we said that the collision layer that it's on is object and it's looking for food items. So head back over to scenes and objects, and in the plants folder, open the corn harvest scene and open the tomato harvest scene. Let's just click on collectible component and let's check the inspector. So the collectible component is an area and is on the collectible layer. Now we can still modify the collectible component just for the corn harvest. So don't open the scene and add the modification inside it, as it affects everything that collectible component is attached to. However, we are using these default values, but for this specific scene, we can also add a supplement value. So let's just put it on the food collision here and save that. Then open tomato harvest and do the exact same here. So go to collision and layer and choose number 8 for food, and then go back to chest, because the feed component is listening for items that are on the food layer. Now let's go to the test scene and let's run our test scene. So I'll let the player collect these harvest items and then approach the cow pasture box, press the E key, and then enter to pass through the dialog text, and then click yes. And we've still got 2 corn and 2 tomato. Then the harvest falls into the pasture box, and then we can collect the milk items. And the milk items are now in the inventory. So let's now collect the harvest here and add this to the chicken box. So in this pasture box, let's go and say yes, and then feed the chickens. Now let's collect these eggs. And this has also updated the inventory. Let's close the window. So back on the test scene objects chest, let's just zoom out and let's just make a modification to the emotes panel so that when we collect the items, we show another animation here. So I'll go to UI, open the emotes panel and then the emotes panel script, then get the inventory manager and say inventory change and then connect that method. Then the first function is on inventory change and just pass that into the connect method. Then say animated sprite 2D and then play the emote 7 excited animation. Then get the game dialog manager and register to the feed animals signal and then use connect. Then create function on feed animals and then play the animation emotes 6 love kiss. Then copy on feed the animals and paste that into the connect method. So click the test scenes objects chest scene, go to 2D view and run this current scene. And then let's just look at the animation here. So let's just pick up our first collectible and the animation now changes. Let's do the next one and the last one. And then let's feed the chest and say yes. And then we get the love kiss animation. Let's just close that window. And then let's head back over to the scenes, objects and chest folder and open the chest scene. Then right click the chest node and change type and search for static body 2D and change that type. Then right click, add a child node and search for collision shape and then create that. Just drag the collision shape to be below the chest. Then for the shape property, choose new rectangle shape 2D and zoom in and then just cover the chest sprite. Then click the collision shape under the interactable component and just change that colour to distinguish it from the collision shape on the chest. Then click the chest and we'll leave it on the collision layer 1. And this will just prevent our player from walking through the chest. Now let's go back to the test scene and just run our current scene, and the player cannot walk through the chest. And that brings us to the end of this tutorial on how to create some custom pasture boxes to help feed the animals. When you collect the collectibles, you can then put them into the pasture box and modify your inventory and then output some rewards. I will show you how to create your first level using all of the game objects and subsystems from the previous tutorials in this series. You will see the benefits of isolating those components and creating all of those test scenes up front. Over the tutorials, we have created many different test scenes that allow us to create all the different subsystems, the game components and mechanics for our game. And these test scenes have allowed us to isolate all the different behaviours and then use them in isolation. This allows us to make sure that our different game subsystems are working, and before we create our full level, we can always make sure that a game item is behaving correctly. When we start to create levels, sometimes these subsystems may stop working, so it's always good to go back to a test scene as a reference point to see if that game item or subsystem is working as it previously was expected. Let's begin creating a main scene, and then we will create a level, and in this level we should be able to quickly create the tile maps, add the game objects and quickly set up this scene with all of the subsystems which we have created throughout the tutorial series. So I'll head over to the scenes folder and create a new folder and call this levels. And now let's create a main scene. So choose other node and then choose node itself and then create that node and rename this to main scene and then save the scene. So go into the scenes folder and save the scene here. Now right click main scene and add a child node and search for node 2D and select this node here. Then rename this to level root. Then go to the scenes folder and UI folder and then just bring over the game screen and just attach that to the main scene. Then go to the components folder and drag on the day and night cycle component and just put that below the main scene. And just for now, let's just disable that. Then go to scene, new 2D scene, and we'll call this level 1 and save that and go into the scenes folder and levels folder and save that scene here. Then head back to main scene and then drag level 1 scene and place inside of level root. Then head over to project settings, and in the run option, let's load our main scene. So go to the scenes folder and choose main scene and open that and then close. And now we can start to use the actual run game button. Throughout the tutorials, we've been just using run current scene because we've been taking the test scene approach. So let's just run that now. And you can see we've got our UI and now we just need to make the level. Let's close that. Then head back over to level 1 and then go to scenes in the test scene folder and open up test scene tile map layer Y sort and just right click and copy the game tile map. So copy this node and then go back to level 1, right click and let's just paste that. So we've got all of these tile map layers, and this makes it easier because everything is already pre-configured. So let's just clean up some of the layers. So go to undergrowth and let's just erase everything on that layer. Then to overgrowth, let's do the same for that. And then for objects, let's just remove those as well. Then head back to main scene and go to scenes and characters, open the player folder and bring the player onto our game. Then move the player node so that it sits just above game screen and below level root. Now head over to level 1 and I'm going to start creating the level, going through each of my tile map layers one by one. I will speed up the video so that you can watch the process of me creating the level and then you can do something similar. So I'm back in my test scene because when I zoom in, I just want to see which assets are for my undergrowth layer and which assets I would like for my overgrowth layer. So I can just confirm that because we've configured Y sorting. So I'm confident to choose these assets in my overgrowth layer here. So I'll head back over to level 1, choose overgrowth, and I can start to choose the assets for this layer. I'm happy with the water layer and the grass and the undergrowth layer. And now I'll go to the scenes collection, and for objects I will start to add the trees and the rocks which the player can chop and mine. And now I'm ready to add some houses to the level, and even though I've added them to the scene collection, I'm gonna add them manually to my level instead. So on Game Tile Map, I will add another child node, choose Node 2D and rename this to Houses, and then in the Scenes and Houses folder, I can just drag the house directly to the scene and then just nest this under Houses. Now let's head back over to main scene and then just test this. Let's run the scene and let's add a camera to the player. So I'll just close this, right click the player, add child node and search for camera 2D and just create that and then run the scene again. And let's just check Y sorting. Okay, so we just need to configure some of the nodes for the level and the game container. So let's just close that. Now you can always go back to the test scene and then run that again. Let's run the test scene and we know that Y sorting is still working. Let's close that. So let's just check what we need to configure in the level. So in the game tile map, we've copied over from tile map layer node. So this is already configured for us. So let's just check level 1 root node. So let's just enable Y sort here because we have nested nodes with Y sort. And then let's go back to main scene and level 1 is contained in level root. So let's just check level root and then enable Y sort here as well. And then the player is also Y sort enabled. Now there is one more node to configure, but I'll just run this and you can see that Y sorting still doesn't work. So just close that. So I'll add another child node and search for node 2D and choose that node and place this above level root and rename this to be game root and place the level root and the player inside of game root. Now these two nodes are Y sorted, so we need a root node that contains all of the Y sortable nodes and then make that also Y sort enabled. Let's run the game and then let's just move behind our assets. So Y sorting has been enabled. The next step is to go to the test scene NPC chicken and copy the chicken's node. So copy that and head over to the level and then just paste that node. and then I can just readjust these markers and then select the chickens and just move them into this location. And then click Bake Navigation Polygon, then head to Main Scene and just run this scene. I'll just close that. I'll just head to the chicken scene, go to Navigation Agent, and I'll just turn this debug off. Then I'll head back to level 1 and zoom out, and I'll add a cow region here. So go back to Test Scenes, I'll open Test Scene NPC Cow, and I'll copy this cow's node here. So I'll copy that, go back to level 1, and then paste it in my level. And then I'll just select the navigation region and bring that over here and zoom in and just adjust the markers and then click Bake Navigation Polygon. And then I'll select the cows in the scene, just zoom out and just reposition them inside of my navigation region. Then I'll just open a cow scene and I'll just make sure that the debug is disabled, so that's okay. And then let's run the game one more time. And then I'll just turn visible collision shapes off and run my game. So we've got the cows in this region and the chickens. So then click on the chickens node and scroll down and turn on why sort enabled. And then for the cows node, do the same for that. Then open the chicken scene and click the chicken node and then turn on why sort enabled. Go back to level 1. And for cow, open that scene, select cow, and do the same here. And then head back to level 1, and then just run the game again. So this fixes our Y sort with the cows. And then let's just head over and check the chickens as well. And that's looking okay. I'll close that. Then I can copy this again and just paste it one more time. And then I'll drag that region over here and then bake the navigation polygon. And then go to our test scenes and open NPC navigation. And in these test scenes, we are cutting out the collision shape. So if I go onto objects, we have the group on here. And in the previous tutorial, I've shown how to subtract the collision shapes by using the correct group name. So let's just click the group name and let's apply this group. So go back to level 1, open up the tile map and click objects and then just tick navigation polygon source geometry group. Let's save that. Then for chickens, as you can see, because we've copied and pasted it and I've resized it, we need to make this unique. So for this one, let's just right click and make unique. Then I'll resize this again because they were pointing to the same polygon shape. I'll bake that polygon and select this one and bake that one. And it's still not subtracting. And this is because for source geometry mode, I need to say group explicit. So let's choose that one, then this one. Open that, source geometry, mode, group explicit, and then click on this one and open the navigation polygon and do the same here. Then for each one, just bake the navigation polygon again, and that just fixes the collision shapes. Then I'm just going to highlight these chickens again and just drag them over and pop them here. Let's zoom in and then just start to rearrange them a little bit more. So I'll zoom out, and in this scene, I'll go to my Scenes Characters folder, and in the Guide folder, let's bring over the guide here. And the guide will start the game by giving the crop seeds to the player, and then the player can till the land here and grow some crops. So let's just test the game again, and go to the guide, press E, then we get the dialog balloon, and then we can go through the dialog and take the crop seeds. So the toolbar buttons are now enabled. So let's just see if we can create a crop field. So I'll choose the tilling tool, and at the moment we are not getting any field. So let's just close that. And if we look at our game tile map, we are missing the tilled dirt tile map. So back to the test fields folder, and let's open test scene crop fields tilled dirt and copy the tilled soil layer. So copy that, go back to level 1 and just paste that into our game tile map and just place it above grass. And for now, I will remove the save data component because I'll add that later when I create the main menu. So I'll just remove that for now. Then I'll go back to test scene crop fields tilled dirt, and we need to copy the field cursor component and the crops cursor component. And we need to copy the field cursor component and the cropped cursor component. To copy these two nodes, go back to level 1 and paste them here, and then just move them above the chickens node here. So let's just click on field cursor component. Then for the grass tile map, let's assign the grass tile map here. Then for tilled soil, pick our tilled soil tile map layer. And then for the cropped cursor component, we will pick our tilled soil tile map layer too. Now let's run the game and approach the guide, and we'll go through the dialog. We'll take the crop seeds and then let's till the land. And I'll plant 2 corn crops and 2 tomato plants, and let's then water them. And then let's speed up the time. And as you can see, the crops are now growing. And then let's collect the crops. And the inventory panel is updating too. Let's close this and then head to scenes, objects and chest. And let's add a chest here for the cows. So for the cow pasture box, let's go back to the test scene and open test scene objects chest. And for the cow pasture box, we've got start cow pasture box. So let's just copy that. Actually, we can just copy the scene from here as it's pre-configured. Go back to level 1 and then just paste it here. And let's just move that to this location. Go back to test scene objects chest, copy that. Go back to level 1, scroll in and paste node here. Now run the game again and let's speak to the guide. Take the crop seeds and then let's just build the crops. Let's plant them and speed up the game and water the crops. And let's collect the harvest and then head to the cow pasture box and then say yes and then collect the milk. And we've then got 4 milk here. So we have tested growing crops and feeding the cows. Let's close this. And now head over to main scene and just turn on the day and night cycle component and then test our game. And then let's just speed it up. And as you can see, that is now working okay. So I have now completed creating level 1. And it's been really useful to just go back to the test scenes to just see how a certain component has been created. And because I've created it in isolation, I'm able just to run the test scene again, just to clarify 1 or 2 things. I hope throughout the series that creating the test scenes has given you a different approach to how you may build your game. And the added useful benefit is that if something doesn't quite work in the level as you create it, you can always just go back to the test scene and confirm it. Now that brings us to the end of this tutorial on how to quickly build a level using all of the previous tutorials and bring all of the isolated components together. I will show you how to style and create a game main menu and load your level and save your game data. So let's begin creating our game menu screen by going to Scenes in the UI folder and then choose Other Node and search for Canvas Layer. Then rename the canvas layer to Game Menu Screen and save that into your Scenes and UI folder. Then right click Add Child Node and search for Margin Container, and in the Anchor preset, choose Full Rect. Then right click Add Child Node and search for VBox Container. Then right click Add another child node and search for Button. Then rename this to Start Game Button, and in the text, write Start. Then select Margin Container again and scroll down to Theme and click the empty option and choose Quick Load, and then load our game UI theme. Then in the Scenes UI folder, just double click the game UI theme to open it, and then add a new theme style here. And let's create a custom style called Game Menu Button and click Add Type. Click this option here, and for base type, click the plus button and search for button, and then set that base type. Then click back on the button and scroll down, and on the type variation, click this edit button here and set our custom style. So write Game Menu Button and then click to apply that. Then back in the theme, let's just choose this option here and scroll down to normal. Click the plus button to override the item and then click empty and choose new style box texture. Then click again to open it here in the inspector. Then click the empty option for texture and choose new Atlas texture and open that. Then go back to the assets and UI folder, and in the Atlas property, bring over basic UI sprites and then choose edit region. And for the menu buttons, we will use this selection here. So with auto slice selected, choose this option here and click close. Then collapse the Atlas texture and scroll down to sub-region and choose edit region. Let's zoom in and choose snap mode, pixel snap, and then bring in the bars to frame our button. Once the button is framed, you'll see this here and click close. Now right click the new style, click copy, and then go to press and override the press style. Right click and paste the style from normal. Then right click again and make unique recursive. Then open the style, open the Atlas texture and edit the region. Let's zoom out, and this is the previous selected style for normal. Choose auto slice and then choose this option here for pressed and click close. And because we've copied the style and made unique, we don't need to edit the region for this again. So sub-region is already pre-configured. Right click press style, copy that, override the hover item, right click, paste, right click, make unique recursive and click OK. And open the style, open the Atlas texture and edit region. Scroll in and choose this option here and click close. Right click the hover style, copy, enable and override the focus item, right click and paste, right click and make unique recursive. And hover and focus are the same style. So right click the focus style, copy, go to disabled, override the item, right click the empty option and paste, right click, make unique recursive and click OK. And open that style. Go to the texture property and edit the region and zoom in, and we'll choose this option here. Let's click that and click close. Then collapse the Atlas texture, and that completes our game button style. So let's head back over to the start game button and scroll down to custom minimum size and choose 100 for the X variable and 29 for the Y variable. And then for VBox container, choose horizontal alignment shrink begin and vertical alignment center. Then duplicate the button and rename this to save game button. And in the text, write save, right click and duplicate the button again and rename this to exit game button. And in the text, we'll write exit. So click back on margin container, add child node and search for margin container and create that. And just position this above the VBox container, add a child node and search for label, and then create that. In the text, write crop tails, and then choose margin container, and for horizontal alignment say shrink end, and for vertical alignment shrink end as well. Then head back over to the game theme, so load game UI theme, and add another custom style. This time we'll just search for label and we'll add a default style for the built-in control. So just say add type here, then choose this option here and override this style. Scroll up to the assets folder and in the UI folder and then fonts, bring over the pixel font from the Sproutlands asset and just drag that into our fonts here and then zoom in here. Then click back onto our label, scroll down, and for font sizes, turn this on and we'll use a font size of 54. Now for the background for the game menu screen, I'm going to create a pseudo level that will just sit in the background. So I'll go to Scenes and Test folder and open up the test scene Tilemap Layer Y, and I'm going to make a copy of this scene. So I'll duplicate this scene and I will call it Game Menu Screen Background and duplicate that. I'll just open this scene and just rename this to Game Menu Screen Background. I'll just remove the camera 2D from this scene and remove the game screen as well. Then right click the scene in the folder and say move and duplicate to. Open the scenes folder and the UI folder and click move. I will speed up the video as I make some changes to the game menu screen background. When I come back, I will then set the background on the game menu screen and we can go through that. So I've now finished creating my game menu screen background and as you notice I've managed to flip the chicken sprites, and you can do this by just right clicking the scene and then choosing editable children, going into animated sprite 2D and then modifying the flip hitch parameter. Now let's just test the scene, but as you can see the animations are now playing and the flip did not occur, so let's fix that. So go to game menu screen background node and attach a script and then just create the script in the scenes and UI folder, and in the script override the ready method and just pass for now. Then create another function and call this set scene process mode and return void, and then get the process mode parameter and then set it to be process mode disabled. And then in the ready method, use call deferred and then use the string to set this function here. Then go back to the 2D view and let's run this again. And as you can see, the animations are not playing, so we've frozen the scene and the flip is now here. And that's because using call deferred waits for the whole scene to be set up and then we freeze the scene. If we go back onto the game menu screen node here and then go down to process mode and set process mode on this panel, the flip will not occur, and that's because we need to set the scene up first, allow the flip to be applied, then set the process mode. So head back to game menu screen and let's just go to the 2D view and drag on the game menu screen background in the game menu screen canvas, and then just move the node above margin container. Let's scroll in. And now let's modify our title again. So click back on label and scroll down to fonts color and enable that. Then select the fonts color and choose the color picker and I'll just choose this colour here. And then for font shadow colour, I'll enable that and just choose white. And then for shadow offset, I'll increase that to 2. And for shadow offset Y, I'll also increase that to 2. Let's just modify the text on the button. So open up Game UI theme, select Game menu button, and in the text option, let's override the font. Go back to Assets and UI folder. In Fonts folder, just bring over the Sproutlands font. Then choose this option here and override the font size and change this to be 18. Now let's just run the current scene. And this is now complete, so we can just hover over the buttons, but now let's connect up the buttons. So click the game menu screen node, right click and attach script, and create the game menu screen script in the Scenes UI folder, so click create. Then expand the VBox container and choose Start Game button, and in Node, click the pressed signal and connect that. Connect that to the script, and do the same for Save Game button, connect, and create the function in the script. And for exit, choose pressed, click connect, and connect that function to the script. So let's create another global manager script to manage the start, save, and exit game. Head to the Scripts and Globals folder and right click and create a new script and call this Game Manager and create that. Open the script and go to Project, Project Settings, Globals, and open the Game Manager script. Open that and add that to the game and close. In the Game Manager script, create 2 functions called Start Game with a return type of void and Exit Game with a return type of void. Then back in the Scripts and Globals folder, right click and add a new script and call this Scene Manager and create that. Then open the Scene Manager script and then go to Project, Project Settings, and in Globals, select the Scene Manager script and click Open and add that. Then click Close. And for the first variable, call this Main Scene Path, which is a type of string, and then go to Scenes and right click Main Scene and choose Copy Path, and then inside the quotes, just paste that path. For the next variable, we need Main Scene Level Root Path, which is also type string, and just open Main Scene and right click Level Root and copy Node Path and paste that here. And then at the front, say root / main scene and / again. Then create another variable called level scenes, which is a type of dictionary, equals, and for the first parameter we'll say level 1, colon, and then go back to scenes folder and in levels, for level 1, right click, copy path, and paste that path in those quotes. Then create a function and call this load main scene container, which is a return type of void. Then in this function say var node, which is type of node, load, and pass in main scene path dot instantiate, and then say if node is not equal to null, then get tree dot root, and then add child, and pass in this node. Then we need another function called load level and pass in level, which is type string, and return type is void. Then say var scene path, which is type string, equals level scenes dot get level. If scene path equals null, then just return from this method, or level scenes, which is type of node, equals load, then pass in scene path, and then instantiate that, and say var level root, which is type of node, equals get node, and pass in the main scene level root path here, and say if level root is not equal to null, then var nodes equals level root dot get children, and then if nodes is not equal to null, then we can say var node, which is a type node that's in the nodes collection, then we can just queue free anything that's registered underneath the level root node. Then we get the level root again and we add the child. So then add level scene. So now that we've set these functions up, we'll put a breakpoint in line 18 and a breakpoint at the start of load main scene container. Now head back over to Game Manager and in Start Game, get the Scene Manager and load the main scene container first. So this will load first, and then once that's loaded, we want to load our level. And the level is level 1. So back in Scene Manager, we defined a level here in the dictionary. So when we pass level 1, it will get this path here, and it will then replace whatever's here. So even though we have a level here now, when we run this code, it will go to this root node, remove this, and then add whatever is in the dictionary. To go back to Game Manager, and then for exit game, we can just say get tree dot and then quit, and that will just end the game. So during development, this is still quite flexible because we can still add NA levels to this and then just run the current scene and test it out. And then when we run the game, we can use it as a real game. And just open the Scene Manager script, and for the main scene level root, just prefix root with a / and then run the game. Let's click the Start button and go into Load Menu Scene Container, and then choose Remote here, and let's just see what happens here. So we've got our main scene now added to the root, and then let's load the level. So let's open game root here and level root, and that's what's currently attached to level root, and that was done during development. So let's just load the level scene, so that's level 1. So we have a level root, and then let's just get the nodes from level root, and then Q3 that node. Then let's add the scene, and then F12. Let's go back to remote, and you can see that the previous node has been removed, and we've added level 1 here. We still have our game menu screen here, so we do need to remove that. So go into the UI folder and open up game menu screen, and when we start the game, we just want to Q3 the game menu screen. Let's restart the game, and let's just check that. So we click start, then we load the main scene, go to remote, then we load level 1, so I'll just step through that quickly, and then we come out of there. We still got the game screen here, and then let's Q3 that now, and F12. So in the remote, we just have our main scene, and we have our game here. So now let's add a key input binding so that when we press the escape key, we can go back to the main menu. So head over to the Game Manager, and then go to Project, Project Settings, Input Map, and add a new action called Game Menu, and add that, and scroll down, and click the plus button for the input, and press the escape key and click OK, and then we can click close. Then back in the Game Manager script, create a variable called Game Menu Screen and preload the scene from the Scenes UI folder. Then create a function and override the unhandled input event and say if event.itActionPressed and pass in the input game menu. Then let's create another function and call this show game menu screen, and the first variable will be game menu screen instance equals the game menu screen here dot instantiate. Then get the tree and then root and add the child and pass in game menu screen instance. Then copy the function name and back in the unhandled input event, just paste that function underneath the isActionPress method. So now let's run the game. Let's click start. And when the game starts, press the escape key on the keyboard and it should take us back to the main menu. So let's perform some more tests. Let's just press start again. And as you can see, we have an error when we try to get the player from the first node in group. Let's just go to the remote, and we currently are trying to add the main scene to the tree. And as the scenes are being created, this scene is causing an issue here. And this is because as we add the level using the Scene Manager, the scenes get created and we most likely need to wait for the first process frame to complete and then grab our player from the first node in group. So to fix this, let's override the ready method and await for the tree to process the frame. Then after the tree has been set up and the level is added, the frame will complete and then we can grab the player from the first node in group. So let's just say player equals, and then take this line here and then remove it from here. So let's just do a search for any other places where we are using the @onReady variable and getting the first node in group for the player. So I'll just highlight that code and press Ctrl Shift and F and just have another look. So we are currently in the field cursor component, and if I just save that file and refresh, and then we have the situation in crops cursor component. So I'll copy this code from here, then go to crops cursor component, and then at the top above unhandled input, just copy that code here. Just save the file and refresh, and we've got those changes. So I'll run the game, I'll click start, and I'll just approach the guide, and I'll test the balloon because we do add the balloon also to the tree. And I have an issue in the guide script where I use get tree and then current scene. So I'll just highlight this code and then press Ctrl Shift F and just have a look at any other instances. So for this fix, I will change current scene to say root. So it's get tree.root add child, and then can refresh, and in the chest script, let's just go to that location and I'll make the change here as well. So let's test the game again. I'll click start. So I've activated the balloon for the guide. I'll take crop seeds. I'm growing some crops and I'll collect the harvest. So I'll feed the cows and I'll say yes. And the harvest is now being added to the cow pasture box. So this is looking good for now. I'll close the window. So I'll head back to game menu screen and let's connect the save button. So on save game button pressed, get the save game manager and then call save game. And then I'll go back to level 1, and then in components, I will get the save level data component scene and attach it to level 1. And I'll just put that above game tile map. And in the tilled soil tile map layer, I need to add a save data component. So I'll just attach that there. And when I create my crop field, I need to then save that data resource. So I'll go back to the resources folder and I'll just attach the tile map layer data resource so that we save the tile map layer cells. So I'll go back to game menu screen and open that script, and I'll put a breakpoint on the on save game button, and let's run the game. I'll click start. So I'll take the crop seeds and I'll just save this small patch of crops. I'll press escape and then save, and I'll just step into the save game. So I've got my save level data component, and I'll go into save game. I'll just check the path, that's okay, and I'll check the level file name. And I've spotted something strange. The save name says save at node2d at 55 game data, and I'm expecting it to say save level 1. So let's go to the remote and look at main scene, then open level root, and the node name is incorrect. It should be level 1 as we are loading this scene here. I'll press F12 to continue that, and it's generated the save data file with the wrong name. So back in scripts, globals and open scene manager, if we look at load level, in this for loop, we are removing the nested nodes from the level root path. So back in main scene, as we load this scene, we clear this out here, and then we get the level root and add the level scene. Now this is useful in development because you can always run current scene and test other scenes as you build the game. The problem is here, when we queue free, we then add the child straight away. And what we need to do is to wait for queue free to finish, then process the frame, and then add the child to the tree. And the fix is to await process frame and then add the child. I will now run the game and click start and then go to remote. And if I just check level root, I've now got level 1 under level root. So we'll test the save again. I'll run the game, I'll start, and I've made a crop field. So I'll press escape and then click save. And I'll step into the save method. I'll go into the save level data component, and now we have the correct file name. and then I'll continue. And I now have the correct save game data file, which is for the correct level. So now that we are saving the file, let's now load the file. So let's head back to Game Manager, and when we start the game, after load level, I'll get the Save Game Manager and load the game. And I'll just put a breakpoint here, and let's run that, and click Start. I'll just step into Load Game, and we now have the save level component, and we'll just load that. But however, the tiles are not being created, so let's just close that. And here, let's await the process frame. And this will wait for the scene tree to be created, and then we load the data, and then reattach the tiles and create the crop scenes. Let's run the game again, and click Start, back into Load Game, and then F12 to run. And you can now see that the crop field has been recreated. So I'll run the game, I'll click Start, I'll just move the player, I'll press Escape, and I'll click Start again. And as you can see, the scene has duplicated. I'm just going to show you something. If we go to Remote, we've got main scene here, and main scene has been added again. And we just need to fix that. So I'll stop that. So let's head back to the Scene Manager script. And in the load main scene container, we just need to say if get tree.root has node and pass in root and main scene, then just return and don't create the main scene again. And add another variable at the top called main scene root path, and then just pass that into here. I'll run the game, I'll click Start, let's check Remote, we have our main scene, I'll press Escape, and then Start again, and that's now resolved everything there. When we first run the game, this button should be disabled. Then when we start the game and press Escape to come back to main menu, this button should be enabled. Pause this. So head over to Game Menu screen and select the Save Game button, and just add that as an onReady variable in our Game Menu screen script. Then override the ready function and get the Save Game button and set disabled to true. And then after that, set the focus mode to be focus none. Then I'll run the game. So the button is disabled, but we just need to update the style so that we can see the text. So head over to Scenes and UI folder, open the Game UI theme, choose the Game Menu button, and for the font's colour, just override that colour and choose a grey. I'll run the game, and now we can see the text. So now I'll go to the Save Game Manager, and I'll add a variable called allow save game, and I'll make that a bool. Then back in Game Manager, after load game and loading the scene, I will set allow save game to true, and then go back to the Game Menu screen script, and then assign that value to the disabled value, and then just invert the value because allow save game will be false on startup. And then for focus mode, we'll get the allow save game parameter and say if true, then control.focus all, else control.focus none. So let's just test that. So it's disabled on startup, let's go into start, then escape, and it's now enabled. Now let's create our own custom mouse cursor for our game. Go to Scene, New Scene, Other Node, and search for Node, and click Create, and rename the node to Mouse Cursor Component. Let's save that scene, and go to the Scenes folder, Components, and save it as Mouse Cursor Component and click Save, and attach a script, and save the script as Mouse Cursor Component and click Create as well. Then in the script, at export, variable cursor component texture, which is of type texture 2D, then override the ready method, then get input and set the custom mouse cursor function, pass in the cursor component texture parameter, then input dot and set cursor arrow. So head over to main scene, go into the components folder and drag the mouse cursor component onto the main scene and just place at the top. Then go to the assets folder in UI and drag the mouse icon PNG into the cursor component. And we downloaded this previously from the Sproutlands UI asset pack. Then head back to Game Menu screen Go to Scenes and Components folder, get the mouse cursor component and add it to the game menu screen. Then position this at the top and then go to Assets and UI folder again, and then bring the mouse icon and drop it on the cursor component texture. So I'll run the game and you can see the mouse cursor has now changed. And that brings me to the end of this tutorial on how to create a game main menu and add your levels to a scene manager and then start them in your game. As you can see, we've had some issues around process frames, but I have gone through them and explained how the scene tree is being constructed, and hopefully this will help you resolve any issues in your games in the future. I will show you how to use the audio bus layout in your game to play music and sound effects. I will also make an audio playtime component so that we can add a delay time to when the sound effects is being played and then loop them. So let's begin by going to Scenes, Test Scenes, and make a copy of the test scene default and duplicate that, and call this Test Scene Audio and duplicate, and then open the scene. Let's rename the scene Test Scene Audio. And to download some free music, let's head over to Ludo Loon Studio at itch.io, and I'll leave the link in the description, and we will download On The Form and we will use this music for our game. Then head over to my GitHub account, and in the tutorial components and scripts folder, I have created a Crop Tales tutorials folder, and in there I have the sound effects for the chicken and the cow. So just go into the audio folder and download those 4 audio files. I'll also leave this link in the description below. And when you download On The Form music file, you will see that it is a .wav file. So open this in Audacity or any other audio manipulation software, and then either select a portion of the music which you would like to use, or you can export the whole file. So go to File, then Export Audio, and then export the file as an org vorbis file, and you can either export the entire file or the current selection as I'm doing here. Then go to your Assets folder and create a new folder and call this Audio. Then go into the Audio folder and create a new folder and call this Music. And then import On The Form music and just rename your file. Then go back to the Audio folder and create a new folder and call this Sound Effects. And then open the Sound Effects folder and import the 4 sound effects files. Then click on the root folder and create a new folder and call this Audio. Then right click, New Resource, and search for Audio Bus Layout. Select that and create that. And we will call this Game Audio Bus Layout and save that. So open up the Audio Bus Layout, and we currently have one bus which is the master bus, so we'll leave that. Add another bus and rename this to Music, and add another bus and call this Sound Effects. Then go to Project Settings, and scroll down to Audio and Buses, and for the default bus layout, let's change this and go to the Audio folder and select the Audio Bus layout which we've created here and open that, and then close. I will just right click the Audio folder and just set the folder colour to red. Then inside the Audio folder, right click, create a new folder and call this Music, and right click and create another new folder and call this Sound Effects. Now go to Scene, New Scene and Other Node, and search for Audio Stream Player 2D and create that node, and rename it to On The Form Music, and save that scene in Audio and Music folder and save. Then for the stream property, go back to the Assets folder, and in the Audio folder and the Music folder, just bring over On The Form Music and drop that into the stream property. Then scroll down, and for the bus property, change this to Music. So view each bus as a separate channel. and you can then add effects to each of these channels. Now, I will not be covering the effects in this tutorial. However, you can have different sound effects buses and then modify or manipulate the audio further using some of these effects. So for On The Fly music, I will use this channel. Go to Scene, New Scene, choose Other Node, and choose Audio Stream Player 2D again and create that. And rename this node to Chicken Cluck 1 Sound Effects, and then save that and go back to the audio folder, and in Sound Effects folder, we'll save that scene. Then head back to Assets and Sound Effects folder and bring over the Chicken Cluck 1 sound effect and put that into the stream property. And then for this sound effect, go to the bus property and change that to be the sound effect bus. Now I will create 3 more audio stream scenes to cover these 3 other sound effects, and I'll speed up the video. So let's head back to Test Scene Audio, and then in the Audio and Music folder, let's drag the On The Form music scene onto our test scene. And then just move this to the top, and then select Autoplay, and then let's run our test scene. So that is playing our music. Let's stop the scene. And then for our sound effects, let's just go to Scenes, Characters and Cow, and add the cow to the scene. Now I won't add the cow moo sound effects directly to our cow character because I want to control when I do play that sound effect. So I'm going to create a new component. So I'll go to Scene, New Scene, and Other Node, and search for the timer node and create that, and rename this to Audio Playtime Component. And then save this component into Scenes and Components folder. Then right click and attach a script and just call it Audio Playtime Component and create that script. Then create an export variable and call it Audio Stream Player 2D, which is type Audio Stream Player 2D. And then in the inspector, head over to the Node tab and choose the timeout signal, and then click Connect. And just connect the onTimeout function, and then just grab the audio stream player and then just call the play method. Then head back to the cow scene, then go to the audio and sound effects folder and add our cow moo sound effects. Then go to components and then add the audio play time component, and then go to the inspector, and for the audio play time component, just assign our sound effects. Then in wait time, we can just put this to 5 seconds and then click auto start. Now let's head back to the test scene and let's just run our test scene. So we now have the music first playing, and then the sound effects has just played. So the next one should be in 5 seconds, and that is now working. So just head back to the audio playtime component, and as you can see, we can now just modify the wait time using the timer, and internally it will call the audio stream player. So this is just useful for many different types of sound effects that you may want to run in a loop. Now before we add the chicken sound effects, just go back to the audio folder and open the game audio bus layout, and let's adjust the volume for music and the volume for sound effects. Now we can just reduce the volume for the music on this channel here, and then I'll reduce it also for the sound effects as well. So head over to the test scene again and run the scene. And as you can hear, the volume is much quieter for the music and also for the sound effect. And that's how we can control the volume for the different channels in our audio bus layout. Now head to Scenes, Characters, and open the chicken scene, and then head back over to the audio and sound effects folder. Now I could just add the audio stream player, and if I go to components, just put the audio playtime component on here, but I'll only get this single sound effects playing all the time. Now for chickens, I have multiple sound effects files, so I'd like to switch between them. So go to Scene, New Scene, and Other Node, and choose the Audio Stream Player node, and create that, and rename this to Chicken Cluck Multiple Sound Effects, and then save the scene. So go to the Audio folder and Sound Effects, and then save that. Then for the Stream property, click Empty, and choose New Audio Stream Randomizer. Then open the resource and add an element, and go to Assets, Audio and Sound Effects here, and drag the first sound effects file in, then add element again, drag the second one in, and add the third one as well. And for weight, I will just keep it the same and allow the randomizer to pick the next sound effect as and when. And then scroll down, and for the bus, change from master to sound effect. Then head back to the chicken scene. I'll remove this single sound effect, so I'll just delete that. Okay. And then go back to my audio folder and sound effects, and just drag the Chicken Cluck multiple into my chicken scene. Then click Audio Playtime component and assign the Chicken Cluck multiple sound effect. Then for wait time, I'll say 5 seconds, and then click Auto Start. I'll go back to cow, and for audio playtime, I'll just change this to 20 seconds, as we've already heard this one. Then head to Test Scene Audio, and add the chicken scene to our test scene, and then run the test scene. And the music is playing. And we've got the first chicken sound, and the second chicken sound, and then a third chicken sound from the randomizer. And then we've got the cow sound effects as well. So now that we've tested our music and sound effect, go to Scenes and Levels, and in our level, let's add our music. Go to Music, and then place On the Form music into the scene, and place that to the top. And for cows and chickens, the sound effects files are already there. So I'm adding music to this level because if you do create levels in the future, you can change the music for each of those levels. So now that the music is added to the level and we have our sound effects for the characters, I am now ready to test the game. So I'll run this, and I'll click Start. And that is our music for the level, and also the sound effects are working. And that brings me to the end of this tutorial on how to create music and sound effects using an audio bus layout, and then creating a component so that you can then manage the delay time of when your sound effects is played. And that brings us to the end of this tutorial on how to make a 2D farming game. And thank you for sticking with me through this 8-hour tutorial. I hope you found this tutorial helpful, and feel free to leave comments below. If you've enjoyed this tutorial, please consider liking and subscribing for more content like this, and I really appreciate all the comments supporting my channel. Thank you for watching.